Thanks everyone for enrolling this course. In this course, you will learn all the technologies related to CCIE Enterprise. But in case you are looking and you are preparing for your lab exam, please feel free to contact. We are running some sort of 100% guarantee program to make you pass. I will provide you the lab, resources, everything. If you want to know more about this offer, you can go and email to this particular address. Anyways, in this course, you are going to learn all the technologies. This will be very useful course to you. But in case you are planning to write your lab exam, just feel free to contact us. We'll provide you all the guidance, all lab related tips, techniques, all the passing techniques, etc. So please do not hesitate. Feel free to contact us and we will provide you and we will assure you that you pass your lab exam in first attempt. Thank you. Thanks everyone for subscribing my YouTube channel. In this particular CCIE Enterprise section, we are going to talk about DNA, Digital Network Architecture. Now we know at this point of time that there are two new mentions apart from automation. We have DNA and we have SD-WAN. And let me quickly show you the weightage. So let me go to the blog side, and if you're looking for the document, you can go to the giganetworkers.in, where you can see one new tab related to CCIE. We are looking for CCIE Enterprise, so you can go to the CCIE Enterprise, and I'm going to upload more and more document here. But at the moment, if you're looking for the syllabus, either you can go to learningscisco.com or you can check one PDF I have attached from there as well. So anyways, you can use any of the methodology. Now, let me push the image. Okay, so now you can see that there is complete change in the strategy, and the exam that we have now is a little bit different, and I will tell you that what's the difference. But first of all, in this 8th series, I just wanted to show you the syllabus related to DNA. Now, once you are in the section number 2, software defined infrastructure, there you will find 25% weightage for SD access, software defined access, and then 25% obviously weightage will go to SD-WAN. So 12 means in between 25%, you have 12.5 plus 12.5 means half of weightage, DNA and SD-WAN. So next portion, you can see that section number 2.2 is related to SD-WAN. In video number 9, you will find SD-WAN related topics I will cover in that. So in this 8 number video, let's discuss that what are the things we have here related to DNA. So for DNA, you should understand the overall architecture of DNA, what is underlay, what is overlay, what are the different terminologies used inside the DNA. Then you should understand the deployment. So you have to mention that what is the role of different devices, what is the role of the border, what is the role of the edge, what is the control, etc. I mean, so you have to define it, and then you have to understand the deployment. Then if you are doing the integration with ISE integration, so you have to understand about the virtual network and then DNA integration with ISE. Finally, we have one nice capability feature related to assurance. So all the devices, either it's a wired or wireless, they have capability that they are supporting telemetry feature. Now we have the assurance dashboard inside DNA, where you can go and check the 360 view of the devices. And there are a lot, means from there we can do the troubleshooting as well. So it's a nice what you can say, the management platform or orchestration platform that DNA has, and with that management or orchestration plane or the software, management software, you can go and do good amount of thing. Now let me go back and let me show you one other stuff related to the video number 8. Now here uh, we are talking about the change in the certification as well. So what change we have? First of all, we know that you have to pass NCore. Means CCI written is not there, but you have CCNP NCore, and for CCNP NCore that has been covered earlier. So NCore, now you are eligible for your lab exam, correct? Now when you are checking the lab exam, in lab exam also there is change. So let me show you the change, and here you can see that the NCore. So NCore syllabus is not there, but this is actually divided in different. So earlier we have discussed about NCore in detail, the syllabus and all. You can refer the previous videos, and here is a data collab service. But overall it is like you have to do some sort of architecture design, you have to understand about the deployment, you have to understand about the operation, optimization, automation. These are the key areas we have. Now in the new syllabus, what is expected here? So let me decrease my video first of all so you can see the full screen, and meanwhile you can have a look inside the slide, over the slide. So you can see that initially it was, and it's not too back, means like just 2-3 year back you have these sections, means 8-hour lab, correct? So in that 8-hour, 60 minutes or 1 hour for a diagnose or diagnostic, then 2 hours for troubleshooting, and then you have complete 5 hours for configuration. So it was like this, correct? So here you have the 5 hour, but now this has been changed, and now the focus is more on design, deployment, operate, okay, and optimize. Again, I'll come to that that thing. This is, now you can tell that this is the old and this is the new, okay. Now, what was the benefit with the old? That, okay, you have 60-minute timer that you can't alter. That was fixed. 60-minute tick, tick, tick clock was fixed. After 60 minutes, if you are able to do the troubleshooting, so for example, in 1 hour, 30 minutes, and I was able to do it within 1 hour, 30 minutes, then I got 30 minutes extra for my configuration. So at times, if you have bigger configuration or some result is not coming, you have to do troubleshooting inside configuration, then 30 minutes is like gold. Okay, now that is not there, because again we should talk only about the new exam. So in new exam you can see that you have the technology core, you have the CCI track, correct? Means you have 2 modules. Again, in the next slide I will tell you that what 2 modules you have. Once you completely pass both the modules, then you will become CCI certified, correct? Now what's that incremental module? Now Cisco is using incremental module that is very much supported, that is very much supported in the present enterprise network as well. Okay, so means this particular exam model is very much realistic that what we have in the enterprise. So in enterprise, what are the new innovations we have? We are looking for cloud integration, we are looking for automation scripts, we are looking for SDN solution as well, because as a management platform, mostly you'll find either SD-WAN, SDN, or DNA, SDN, or in data center you have ACI, correct? Apart from that, you have good amount of Python scripting or Ansible scripting, etc. All devices, they are supporting the full automation as well. So here you can see the cycle, and you can see that in between automation and network programming, you can go and check your design, your deploy, your operate and optimize. And that's the network life cycle. Let me show you the next slide. So now you have 2 modules here, module 1 and 2. Clearly you can see that you have 3 hour fixed for design. Obviously we'll get the scenarios based questions, and I'm going to show you some samples as well. So Cisco is sharing the sample questions. So I will show you some of the sample questions. So those are scenario based questions, and you can see your backward navigation is disabled. Means once you are done, once you move forward, you can't go back. Again, that's the label of CCI, the exam difficulty is like that. So be sure what you are doing. And to have that much surety, your fundamental knowledge should be very, very good. Your knowledge base should be very, very good. Correct? Then you can see that you have 5-hour fixed, and then you have hands-on and web-based items enable, and you can check. But again, the trick here and the good thing here related to real world scenario, real world corporate or enterprise is that the module 1 belongs to design, and then you have deploy, operate, and optimize. Now if you go and see the DNA dashboard, you will find the DNA dashboard is also like very much like this. In DNA dashboard we have design tab, we have deployment tab, we have operate, optimize, we have assurance tab. Correct? Just very much similar, but this is something like Cisco old type of. If you check maybe maybe 10 year back, we study like plan, implement, operate, optimize, like PID something IOO or PDIOO, something like that. One model Cisco was following from long back. Plan, design, implement, operate and optimize. That's right. So operate, optimize, I can see. Implement is not there, but deploying is there, and design is there. So somewhere in between, you have a plan, and then design, then implement or deploy. I think both are the same. Then operate and optimize. So that's the model that Cisco is following for their exam as well. Be sure, do the designing, and you can see the progressive storyline, means it is going along. So means things are connected. If you are wrong in one place, then it's very difficult to recover from the wrong, and you will reach to the right conclusion. So if you are doing something wrong, it will give you that option, oh, do the wrong. That's the internal thing inside the exam as well. If I'm doing some wrong configuration, I'm going towards some wrong result, then it will give you wrong options only. So you have to be sure, and you will be sure once you go and watch all the videos that I'm going to upload. And whatever videos are already uploaded there, watch all those videos. I told you that 20 video series, this is number 8. Watch those videos, make solid knowledge. Your fundamental should be 100% correct. So even in exam, if you have some difficulty, you can troubleshoot that. Correct? You can recover from that state, and you can fix it within the exam itself. So your fundamentals should be very, very strong, and then you should know each and everything, whatever in the syllabus point 1.1a, 1.1b, 1.1c, etc. Okay, so this particular video series, this particular day 8 video will cover DNA. That's 12.5. That's a big weightage. So please complete each and everything inside DNA, and then we'll move to the next section, that is the day number 9, where we'll go and learn about Cisco SD-WAN. So once you complete 8 and 9, that means you will complete 25% of CCIE lab syllabus. Okay, please continue, watch this, and once you complete this, complete 8 day 8 video, in day 9 we'll meet, and again I will go through. So this is one of the example that I'm showing you, that in the lab, this is the pattern. Again, I'll go deep inside the pattern. We have to check some of the samples as well in the upcoming days videos. Hello everyone, and welcome to DNA. Inside DNA, we have Planning and Deployment is SD Access Fundamental course. Now in this course, you're going to learn, understand first of all the basics of DNA. And DNA is a common framework. Inside that, the underlying technology is SD access or software defined access. So what are the key components of the DNA controller? What are the device role? Which type of devices are supported? What are the best practices to install the controller? First of all, these basic stuffs. Now once your controllers are up and ready, then how you can go and join different devices inside the fabric. Now, good thing about DNA is that it is seeing both the wired and wireless things equally. So either it's a wired network or wireless network, you can integrate inside the fabric, and then you have ISE as a policy plane where you can go and create the policy and it will go and propagate to the DNS center. Or the best practice is that now you have done the integration between ISE and DNA, do each and everything from DNA, even no need to touch ISE. Correct? So all these policy synchronization, everything will happen for both wired and wireless from single pane of glass. And that's your DNS center. So once we understand the device role, once we understand the best practices integration between ISE and the DNA, then I will show you that what are the concepts related to microsegmentation, why it is important to do the microsegmentation, what are the use cases related to microsegmentation or segmentation. Correct? And finally, we'll see some of the examples related to, or some of the best practices related to do the auto LAN, do the provisioning with help of template, do the provisioning for the wired network. So whatever huge infrastructure you have, you can do each and everything from the DNS center, correct? And finally, we have the assurance. We have some analytics feature as well. So overall, starting with designing, planning, provisioning, and then finally moving towards the analytics and obviously the assurance. Finally, you can go and check the automation part as well. So overall, DNS Center, you'll find that it's an orchestrator, and it's one of the best orchestrator we have in the market. It's highly capable of doing the automation, analytic assurance, apart from planning, designing, provisioning, etc., etc. Correct? So I hope that this course will give you good amount of knowledge and thoughts about the SDN solution. That with that particular SDN solution, you can manage the LAN infrastructure. I'm going to walk you through the CCNP Enterprise certification, and we'll see that what are the changes that Cisco is putting from this coming Feb inside the certification. There is complete strategy change you can see inside the CCNP Enterprise. We know that Cisco certifications are always valuable. You will get much salary hike, means compared to other certifications in the market. You will get much more reputation, and they are highly valuable certifications. We have complete sort of certification, means different type of certification like associate, professional, and expert. And as per your certification, even you can negotiate with the companies in terms of salary and other aspects. So they, as per your certification, they will think that you have the right knowledge, skill. You are very skilled in the IT. You are a skilled IT professional, and then you can go and ask for the salary because you are able to take the responsibility. So that's the reason the company will pay you. Here you can see that 99% of organization use certification to make hiring decision, because these certifications are structured in a way that they are going to test your different level of skills. So for example, if you see the old certification stack that we have, means now it's 28th of Feb. So now this become old, and now in the next slide I will show you the new that will be available from 24th of Feb. So this old certification, you can see most of the people at the moment, at this point of time, they have we have associate level certification, professional level, then the expert level, and different type of technologies are there. So for example, routing, switching, security, service provider, wireless, others. Now this has been changed in this. So now you can see that certification has been simplified, but on other hand, that will become much more focused. So now this CCNA, that is the associate level certification, this is the basic for all the professionals, and then again you can go for the expert. But CCNA become basic for the professional level. Now this CCNA will serve the purpose for enterprise, service provider, data center, collaboration and security. And parallelly, you may have the expert level certifications in that particular domain. Now again, Cisco has other certification as well, and that is the DevOps, and their track is different. But you can see that 95% or maybe 90% of things relates with associate CCNA, and then the professional, and then the expert. Now here you can see that if you've done your CCI, so you know that inside CCI, you initially, means before this program, you have the theory and the lab, and that is 8 hour very difficult type of exam. And there you must need very high percentage, for example 75 to 80% of marks in all the sections to pass your CCI. Now comparative to CCI, CCNP exam is also very highly skilled type of things that they are going to ask you. It means they are going to check your depth knowledge inside that particular domain. Here you can see that you have the enterprise core, security core, service provider core, collaboration, data center core. So things has been grouped strategically inside different type of core. So you have one foundation, you have one core, and then you can choose the uh, expert level, or more precisely the specialist level. So you have the core. First of all, you can see that you have the CCNA, and then you have core in these, say for example 5 domain. So you need core knowledge, and then you can go and get your CCNP, and then you can go and get your CCIE. So from your core, now you can see that you don't have written and a lab exam, although your core, after your core you can go and write your lab exam. Okay, so choose between 2 lab exam inside this enterprise core. And what are 2 lab exam? If I go back, you can see that you have enterprise infrastructure, you have enterprise wireless, correct? So like that you have to choose. Now if you are in the security, choose your concentration, means you do your core, choose your concentration, and then take the lab. Like that you have all the tracks. You can see that from the slide, it's very much uh, clear and what to do at what point of time. Again, here you can see that you have enterprise, security, service provider. For everything, you have core exam, and you can go and have your CCNP. Means CCNP has 2 paper. One is core, and one is the concentration, or one is the focused exam, and then you can go and write the lab exam. So for example, for enterprise, you have enterprise lab related to wireless and the CCI infrastructure, where you have different things like SD-WAN and SDA. Those new things are also added. All right, so now you can see that today means, again, today is 27th or 28th. So now we are in this certification track. So 24th of February, we have enterprise core, that is mandatory, and then you can choose one. So either it's advanced routing or SD-WAN or enterprise wireless or wireless implement. Like that, you can choose the certifications. Summary, that Cisco has tried to reduce the number of amount of certificates, and it has been focused and grouped well logically inside single technology, or inside single group. And it's still and even they have removed the CCIE written as well. So you can do your CCNP core and you can write your CCI. You can do your CCNP core and then you can go and focus on any of the specialized exam, like say for example SD-WAN or enterprise design, etc. All right, so this is the track. Everyone has a home, everyone gains, everyone maintains their certification. everyone awarded badges. So obviously by the end of day, once you complete the track, you can see that you have different type of badges. You have a specialist, then you have CCNA, then you have CCNP, and then you have CCIE. So you can start your journey, and then you can slowly move your career from a specialist to the expert, and that's the goal. And once you complete your CCNA up to CCI in one particular domain, then you can move to the other domain. Okay, so there is a wealth of knowledge available, and if you want to gain it, if you want to become expert, go to one technology, complete it, and then move to other technology. That will be the strategy. This particular course is focused on CCNP Enterprise, and once we have one of the core topic, then we'll go and check the SD-WAN. Alternatively, we can go and check the other stuffs as well, like design, advanced routing, enterprise automation. But at this point of time, we can check CCNP Enterprise and the SD-WAN, because the combination of enterprise and SD-WAN will give you weightage. At the moment, SD-WAN is very hot in the market. It's very demanding, and if we combine like these two, core plus SD-WAN, so market value will be very good. What are the core skills you need? We'll see that we have complete syllabus. You can go and check. So now this was the past, where you have route switch, shoot arc, and other stuffs. Now in future, now present, I better tell this. This is the present. So you have enterprise core batch. You have a specialist. Uh, then you have the advanced routing batch. Wireless batch means for individual exam also you will get that exam certificate, but better that will go and club. So CCNP Enterprise with any of the four, correct? All right, so now here again you can see the summary that you have. Like if you want CCNP Enterprise, you do the core and you can do the advanced, or you can do the core, you can do wireless, any of these two. You can do the core and then you can do the design. And here you can see that CCNP Enterprise, Enterprise. Okay, and just try to tell that how it is equivalent to CCNP RNS, CCNP wireless, CCNP DP. So suppose if you want to do CCNP DP, you do the core and then design, and you are the DP. If you want to do CCNP in wireless, the do all these three, and then you are CCNP in wireless. If you want to do CCNP RNS, do these two, and you are CCNP RNS. If you want to be CCNP in SD-WAN, you do core and the SD-WAN, and you are the CCNP in SD-WAN. All right, so this was the certification changes, and I hope that you understand that what type of changes, what certifications we have to obtain our new CCNP, and from there we can go and prepare for CCIE as well. Let us discuss that what are the challenges we have in the networking evolution, and then with help of DNA, what are those things that we want to address, or what are the challenges we want to address inside the digital network architecture. Now we have the list of challenges, and I'll show you all these challenges in the next slide. But at the moment, we know that there are so many things happening in the network. So we have cloud adoption, we have mobile client, we have IoT adoption. All these things are coming inside a single bucket. And what does it mean? It means that you have different type of applications, or different types of services or capabilities. Everything is coming under one umbrella, and that's the thing that uh, DNA architecture or digital network architecture try to solve, and that's the complexity we have. So I want to create, say for example, one segment, and in that segment I want to put the policy. That segment, that policy, that will be valid for different type of users. So for example, IoT user, mobile user, wireless user, any routing or switching user. So throughout different type of users there, but you want common segment, you want common policy, and everything you want with higher speed, with higher scalability, with higher level of security. So everything we want in a rapid pace, we want to integrate everything, but we want in higher speed. Now here you can see the challenges that we have. The list here, say for example, network deployment, we have implementation complexity. Again, uh, we are not inside a unified fabric. So you have fabric where you have all different type of services or users. So you have, say for example, wireless access point. You have some mobile users. You have some switching, routing users. Those are using those routing switching. They are inside VLAN and then VRF, etc. You have something related to IoT. So in that case, if you want to put some new entity in the network and you want to create some sort of segment and policy and ACL, it's very difficult at this moment to integrate with the existing infrastructure, because everything is not inside single umbrella. Everything is not inside single fabric. So that's why we have the network deployment, say for example, implementation complexity, wireless consideration that we need to take. Then we have the service deployment, network segmentation, ACL policies, or you can see the normal policy, user and device onboarding, slow issue resolution. So all these things we have. Now, what I'm going to do here that I'm going to break this particular recording into two parts. So let's discuss network deployment and service deployment, and the next section we are going to discuss about the network operation. All right, so let's discuss about this implementation complexity. The same thing that you have different type of services, different type of applications, or different type of technology you want to group inside same umbrella. So at that time it's very difficult for other entities to understand that what you want to accommodate with. And that's the thing we have inside implementation complexity. You have to touch different technology, and you have to put all those technology inside same bucket. So here you can see that we have too many network variations and combinations, make it challenging to adopt new capabilities and services, and that's true. Then we have wireless consideration. At this point of time, we know that first of all, the wireless is outside the fabric, means you have different cap web tunnel, you have your wireless access point, and then you have the wireless controller. Everything should register to the controller. From controller, we have different type of tunnels, and the controller is sending the instruction. So we don't have a one unified fabric inside wired and wireless traffic can go. That's the first thing. Second thing, that for wireless is still we are not putting segments for wireless. And that's the thing, we are still using the wireless in the same fashion, same old fashion you can say. And that's why it's very difficult to create segments, groups, and then put policy inside wireless domain inside a unified fabric. Then again, the network segmentation, and not only this network segmentation, but once you have the virtual network segment, or once you have, say for example, a VNG, we'll see later on that what type of segments we have, and what is the restriction, how many segments we can create, what are the use cases, etc. But to create the segment, and once you have the segment, then how you are going to put the policy, how you are going to enforce the policy inside the segment. If we have two different segments, then how those segments will communicate, what type of contract or what type of access rules you want to put inside them. So those are very complex in the existing domain, in the existing LAN network, and that's again one type of challenge we have. So here you can see that when you are dealing with the network segments, at that time we may encountered with the layer 2 loops. If we are using STP, 50% of links will be unutilized. It's very difficult to scale. It's a flat layer 2 network. So there are so many restrictions that can be overcome with unified vision that we have with the DNA. So DNA will give you the bigger picture. Inside that, you have to arrange all the small pieces uh, in a SDN fashion, because DNA is again one type of software defined network solution where you have the management plane, where you have the control plane, where you have data plane, and new thing we have that we have to integrate with policy plane as well. So ICE engine basically is going to work as a policy plane. Then we have segmentation and VRF light. So when we are talking about a layer 3 domain, so for example, layer 3 switches or layer 3 switches or routers where we can enable the layer 3 functionality, we can create VRFs, virtual routing forwarding instances, and then those VRFs, obviously those are the independent routing tables or instance of routing tables, but still to manage them and to scale them, it is difficult in the traditional network, because again we are not following the SDN approach, where we have some common controllers or where we have some common control plane devices who has the authority or who is going to have the entire view, or they have the view of the entire fabric. Now, if you put the entire routing table to all the endpoint, all the routers and switches who are understanding routing, so that's not a good scalable design. What is the good scalable design? That you should put all those information to the control plane or the central device, and whenever it is required, the endpoint or the edge devices, they will query, hey controller, hey central authority, I need this information. And that central authority, if you know, obviously he should provide. If you don't know, then he query to some other third party or some other places. Correct? So that's actually the core of this SDN solution, that you have segregation of roles. So you're not putting unnecessarily load to each and every component. Correct? Now that's the reason here you can see that if we are using VRF Lite, requires separate routing protocol, resulting in CPU load and complexity. A VRF Lite using 8021Q trunks between device is relatively simple to implement on a few devices, but become very difficult to implement if we are talking about the wide scale. The typical rule of thumb is VRF Lite deployment should not be scaled beyond 8 to 10 VRFs. So again, you can't manage more number of VRFs if you are using the traditional way to create L3 boundaries. Okay, and that's why we have something called Lisp protocol that we are going to use inside the DNA. Later, we'll discuss more about the Lisp. Now again, if we are doing segmentation using MPLS, this also having a restriction, although it's a very nice way to do the segmentation with MPLS VPNs or the labels. But what is happening here, you can see the challenges that MPLS VPN will scale much better than the VRF Lite. However, they are often too complex for many network managers to tackle. So you need very good skill level who know all the labels, protocols, mapping, etc. And it's actually good to manage end to end, but it's uh, we need some high skill network engineers to manage this. MPLS VPN support is not available pervasively across all the network platform. And suppose once you are running MPLS at one point, you should run this at all the points, correct? So that is not there. That is very much required. Let's continue with the other challenges as well. So now we are talking about policy. You may have policy related to security, policy related to quality of service, policy related to control. Security policies means maybe ACLs, maybe zone-based policy, etc. QoS is very popular. You are using quality of service to manage different type of queues, scheduling, priority, shipping, buffering, etc. Control policies again control. You can see the control based on the VLANs, and then you can give some sort of privilege. What particular section can do how much role. So we can do some sort of role priority with the control policy. Now, what is happening with these network policies? Again, you can see uh, we have policy plane and we have the controller or control plane device who can use some control policy. So who is going to put the policies inside the network? We have different bodies in the existing network, if you see. So different devices are taking different roles. Roles are not divided actually equally, or we don't have a better plan to divide the role to different network component. So which component will do what? That is not the case in case of DNA. DNA has independent, or you can say the uh, segregation or the better segregation of the management plane, control plane, data plane. So all these management body, all these segregated entities, they have their role. They know what they have to do in the network, in the fabric. So here you can see the challenge that adding IoT devices, you need more VLANs who will take the decision, adding IP camera, video endpoint, more VLANs, segments, subnets, etc. Now in the enterprise, we know that we have DHCP server, we have IPAM, we have DNS servers, we have, if it is integrated with ISE, so from ISE also we are pushing the policies, and we don't have any unified plan to put these policy in a streamline, correct? So these are the challenges we have again to manage the large ACLs, because for security reason, all the devices we use to put say hundreds of ACL, different type of devices having different type of ACL. So it's not a structured, a standardized, unified. Those things are not there. So uh, standardization is not there, and a structure is not there, and proper planning is not there in the existing network, and that's the reason it's actually very difficult to manage, scale, do any changes, etc. So the traditional method used today for policy administration, large and complex ACL on device and uh, hardware, and is some typo here, are very difficult to implement and maintain. Then again, it's a very sort of headache to do user and device onboarding, because again you have to go and check multiple places for a small thing. So suppose someone want to implement or someone want to onboard one laptop. So at that time the IT team, local IT team, they will send some ticket to the ISE team that I want to put this device. Please add the MAC address. Then IT team, the local IT team sending to the network team. The network team, someone will put that MAC address into that ISE, and again the VLAN creation will happen, the switch interface where it should map, who will provide the IP address, what will be the IP address coming for DHCP, how the IPAM is working. There are n number of things with for very a small change in that, and it will take time because the process itself is very complex. So we don't have unified say AP who will understand this particular say endpoint, and we don't have ISE integrated with say WLC, and then that will be integrated with one fabric from where we can push the policies. So complexities are there. Everything is not simple in the traditional or the existing network or the existing campus area network, and that's the reason it's difficult to scale and difficult to automate and difficult to provide multiple services. All right, so let's stop here, and in the next section, we'll continue from here and we'll complete this challenge related to networking or related to campus area network. Let us continue the discussion here, and the last piece we have is the slow issue resolution. Why we have slow resolution? Because of lack of visibility, because of lack of tools, or because of the reason that we are not quickly able to reach to the problem. And that's the issue that we have, which is causing slow issue resolution. So at the moment you have certain issue, and you know that what are the probability to solve. First of all, the probability for that issue means what will be the probable cause to create that issue. So is it some routing issue? Is it some reachability issue? Is it loss latency jitter? Is it something got broke down, network health, etc.? So we may have number of category uh, for the problem, for the root cause, but is still, first of all, we have to know that why is the issue, where is the issue, and then what's the solution. Now everything, all these things are actually connected with the visibility. So if we have proper visibility, say network visibility, the devices visibility, the devices connections, orientation, how they are plugged, how things happening, if we have all sort of visibility, then it's actually easy to rectify, say easy to isolate the problem and then rectify. Correct? These things are possible in DNA, but actually this is very difficult in the present scenario because you have different type of puzzles to solve to reach to the actual solution. Correct? Now, if we add all these things inside the existing network, so here you can see we have multiple points here, say 1, 2, 3, 4, 5. So say for example, you have the AD, external identity services, and that AD is connected with the policy engine, that is nothing but the ISE. You have AAA, you have DHCP, you have switches, and you can see the lock button here. You have your entire LAN core, then you have devices in the edge, then you have the access switches or L2 switches, you have a wireless devices, and you have wireless controller. Means this is, say for example, complete setup for the existing network. Now to add or to do any modification, what are the steps that we generally do? So here you can see, suppose if you want to onboard one laptop, for example, what you need to do. So first of all, obviously that user account mapped inside the external domain server, that AD will again go and connect with the ISE. So in ISE you have some sort of rule, and you have imported the AD users. Say for example, Microsoft AD users inside the ISE. So you have integration with the AD, Microsoft AD with the ISE. Then obviously that particular user will be part of some maybe a wired or wireless LAN, and in that LAN you may have some sort of ACL configure, you may have some sort of IP configuration. That particular user will get IP from DHCP server, so for that you have some DHCP relay configured. Correct? And obviously if that particular user is connected with the wireless, so obviously nowadays we have option of both. If you connect with the LAN cable, you become wired user. Most of the time we are roaming, we have the laptop, we are roaming here and there, means we are using the wireless capability. So at that time, obviously that particular access point where the laptop is connecting with certain SSID, that access point has enrolled with the WLC, and obviously there also you have certain rules. Now, if that particular user traffic is going or flowing inside the corporate network from one place to other place, obviously not only we have L2 segment, but we have the L3 segments as well. And obviously if they cross one boundary and reach to the other domain, we have proxies, we have firewall, we have ACLs in between that. So if you sum all these things, you'll find that how many places you have to go and touch. So you have to go and touch the AD GUI, you have to go and touch the Cisco ISE or AAA GUI, you have to go and touch WLC GUI for wireless. Obviously this is a wireless controller. You have to go and touch the switches, routers, CLI as well. So these many things you need to, or these many contact points you have to stitch all these things together to work properly. So obviously the first time setup will be difficult for the existing network, but once everything is in place, still it's easy. But again, different departments will be there. So maybe you have some contractor for laptop, maybe you have some contractor who is managing the switch, maybe someone is managing the routers, maybe someone is managing the firewall, someone is the service provider who is providing the MPLS services, someone is the provider who is providing some secure token. So mix and match of everything, and still you don't have full visibility. Correct? Now if something will happen, which particular section you will go and find out the issue, it's actually difficult. Now in this existing network, you add more complexity. So where you are going to fit the IoT devices, where you are going to fit the mobile user, where you are going to fit the say for example remote user who are going to connect with the IPsec or VPN in the network, where you are going to fit say for example the endpoint with very less intelligence. And then what about the visibility? And now how you are going to put the wireless segmentation? On top of that, how you're going to push the policies inside different segments or virtual network segments. So all these things are actually very complex to understand and deploy, and the common solution for all these problems is the Cisco DNA or DNAC. Okay, so upcoming section will read, learn, study more about DNA, and then we'll understand that how with help of DNA we're going to solve all these problems. What is digital network architecture? If you compare, you'll find that we have different type of automation, or for example, we have different type of SDN strategy in general. So we have SDN, software defined networking. So for example, local area network, we have for WAN, and we have for data center. Now, if we are talking about, say for example, most precisely campus area network or CAN, at that time if you are doing SDN, you are doing automation, you are doing lots of things, that will become digital network architecture. If you are doing the SDN inside the WAN, that will become SD-WAN. And inside data center, we know that we have Cisco ACI or other vendor, for example, VMware, NSX or NSXT, those data center automations we have. Now again, if we go and talk the technical term, or if we discuss the technical term, we know that SDN means decouple of control and data plane. So you have your control plane somewhere, or you may have centralized control plane. You have geographically located data plane components. But nowadays we know that we have management plane as well. And then finally you have something called policy plane as well. So let me write here PP. Now I'm talking at the moment in terms of campus area SDN or DNA. So we have management plane, and that management plane is nothing but DNAC server, DNS center. Actually, it is Epic EM, and Cisco renamed that Epic EM or that server that you have, say for example, UCS C series server that will work as a DNAC. That will be your management plane. Then you have the control plane. Later on we'll go and study about the various type of components, what is the border, what is the control protocol used inside control plane like Lisp, what is the data plane protocol we have inside the data plane, that is nothing but the VXLAN. But yeah, you have border device, you have edge devices, you have WLC wireless LAN controllers as well. To Because here we inside the DNA we are going to add both the wired and wireless, and we have the control mechanism inside the fabric for both the wired and wireless. Okay, and then finally this DNAC we are integrating with ISE Identity Service Engine for policy enforcement. So now once we integrate ISE with the DNAC, then we can go and create the segments, the policies, so for example, contexts in between various entities or objects, and those segments or policies will be pushed inside the ISE because behind the scene both are integrated via the API. Correct? So this is actually the technical overview of DNA or DNAC. Let me quickly walk you through the business purpose of DNA, why we need DNA, what type of things the DNA is going to solve. So we have various type of customers. For example, customer related to education industry. Say for example, you have big universities and you are talking about the network infrastructure of a big universities. So many big universities are there where you have n number of students, n number of uh, you can say that you have n number of buildings inside in a same premise. So you may have, say for example, a big university or college where you have 100 buildings in the same place, or maybe you have a retail shop, you have one complete campus for a retail shop, or maybe you have big hospital, n number of rooms, and n number of small entities, or for example network entities, or maybe some sort of medical devices who have sensors, who have some network plugins. Correct? So those things are there, means either it's a healthcare department or education department or retail or shops, or it's a financial department. Everywhere there are chances that you have huge backbone of LAN network, or you have a huge LAN network. So on that case, say if you go to the traditional switching methodology where STP can create loops, or 50% of link will be uh, unutilized, and it's very difficult to find out what's the issue, how to resolve it, and you don't have proper visibility. Inside that you have in number of roaming customer, you have multiple, or you have hundreds of access points, you have so many, or you have bunch of WLC to manage that. Apart from that, you have roaming devices, you have IoT devices across the premises or everywhere. So how you are going to integrate all these networking, non-networking, or devices who have some sort of networking intelligence? How you are going to do that? The answer is that with the help of IoT. Now the big question here is that how IoT, sorry, the answer is DNA, not this IoT. Let me clean here. Yep. So the answer is DNA, and the big question here is that with help of DNA, how you are going to solve the business need, the business purpose, how you are going to provide good solution, better performance, better security, uh, fast, safe, secure, all these other terms we know that. But what's the business goal? Business goal is revenue. And where is the revenue? If less number of heads or less number of engineers can manage a bigger infrastructure, and that bigger infrastructure uh, should be secure enough. In the other hand, we can tell that the business goals is that you should have very less downtime, or even if you have network issues, it should be resolved very quickly, because if more the downtime, more is the loss of revenue. So here you can see the twofold of this, even the threefold of this. So when we are talking about DNA, we are talking about that we have secure fabric. We should have, say for example, less operational headache, or less operational, for example, count plus complexity, correct? And finally, you should have a better, say I will add those terms, say for example, uh, automation, visibility, and all those things. But the third and very important term is, and that again, that is twofold. The first thing is that you should have less downtime. But suppose if you have downtime, you should be recover it fastly. So both of us, if you have network breakout, how fast you're going to recover it. And all these terms, this is just the three terms, but you can see that they can associate it with the revenue, or they are associated with the revenue, correct? Now the next term is coming into the picture. If downtime is there, if network breakdown is there, how I can do the troubleshooting. If I have full visibility at what time what happened, then it's very not easy, but it is something like we have 30 or 40% or maybe 50% better probability to resolve that issue. Okay, that's the one thing. The other business goal here is, and it's like it's a huge. The other business driver or goal is this, that now we are talking about intent-based networking. We have contextual networking. So I am connected with my ISE, and then we have the pixie grid. We know that inside ISE we can send that context related inputs, and then ISE and maybe other telemetry services who can have the full visibility, who can analyze the data in other terms, and then we can go inside the data, and that will help us to set the business goal. Okay, so that's the big term we have. Means you understand this, that DNA is very close to network, or close to business goal, not network. So DNA is a networking box, but whatever business goals we have, it should be very close to network operation. Means network operations should not create hurdles inside or to achieve the business goal. That's the main concern all the organizations we have. Now you can think, oh, what type of business goal, what type of network hurdles are there? I'll tell you one a very traditional example. Suppose if you are a big company and your office is in Asia, say in Asia we have China, but just an example. Asia, there are so many countries. So suppose Asia, China, and Europe. These places you have your network, you have businesses. Now it's very difficult, or it's almost impossible, the same networking policy you apply at Asia, at China, Europe, USA, etc., etc. So there are itself mental, you can say the mental and the people logical boundary. So people are there who will not allow you to do any change in their region. Okay, but if everything is unified, and if you have one intelligent management plane who can enforce the policy at all the location, and that should be very intelligent, and it should have all the visibility, assurance, and all those key terms, then the zone members, they will tell, okay, you can do the change, because one of the zone, all the head, so whatever the head bosses over that zone, they have the responsibility that that should be working as it is, correct? So that's why they are not taking risks to do any change from any other remote location. And rest of the things you can understand that, yeah, it's very difficult even to do a small change in a production environment. All right, so then what the DNA is going to do, that DNA is very close to the business goals. It has full visibility to the network. It is a secure fabric. The main drivers of DNA are inside DNA we have capability called ST access, software defined access, is we can do full automation. So it can work as a plug and play both for wired and wireless network. We have the policy enforcement. We can have the automated network segmentation and policy group based policy. These things you will understand once you go and learn more and more and more. You'll understand, oh, what does it mean by automation, how much level of automation I have, which type of things I can do with the automation, what type of policies I have, what type of segments or how many segments I can create. If I have those many segments, then what is the policy metrics, which segment can talk, which segment do not talk with which segment, what is the micro segmentation, what is the macro segmentation. So all these things you'll come to know one by one once you go deep dive, once you study more and more about DNA and DNA strategy. Finally, you can see the assurance. So I told you that how fast you are going to resolve the issue. That's the key. Issue will come, network will go down, maybe hardware issue, maybe CPU crash, maybe link down, maybe some disaster, anything can happen. There are uh, multiple scenarios that some issue will come, some problem will come. But the key here is that how fast we can recover, and that fast means that how much you know about the network. So how much your automated system having the visibility inside the network, and then what are the key things you are going to do if you find that network is down, and what is the point where you find the breakages. Okay, so these things are there. It's very much automated in DNA, and DNA or DNA center is going to provide all these capability. I hope you understand what is DNA. We went only 4 slides I covered, but they started with policy plane, data plane, control plane, management plane, and then who is the potential customer who going to use this wired and wireless plus IoT plus mobile plus roaming plus some sort of secure tunnel. You have everything is encapsulated or be the part of DNA, and how DNA is reacting with the business goals, because it has full learning capability, can learn everything, and then you can see this cycle. It can have the input and it can provide the output. All right, so let's stop here. Let us discuss about the hardware specification of DNA. And we have actually 3 different type of core hardware supports. So we have 44 core, 56 core, and 112 core. What type of appliances we have? We have UCS C220M5, and then in the higher form factor we have UCS C480M5. Let me quickly show you the diagram here. So here you can see that you have 44 core, you have 56 and 112 core. And again, depending upon say size of the campus area, it's a um, considerable good side, it's a mid size, or it's a large size. Uh, According to that, these appliances can be used. And then we have the number as well. So here you can see that, say for example, and these numbers are related to 1, 2, 3, these 3 columns. So for example, 44 core, they will support 1000 switch, routers, wireless controllers, then 2000, then 5000. So like that, we have this list and you can compare. So for example, core 44, they can support 25000 endpoints. Then the 56 will support 4000 endpoints. Then 112 will support 100K endpoints. Correct. So you have that list. You can refer this list. Then important thing here that how many fabric domains they will support, how many virtual network they can create. So here you can see in the large network where you want to create some more segments. Obviously, you can go and use 112 core where we can create 256 network. But again, these are the theoretical numbers. No one is using this many numbers, but still we have the option to create it. All right. Let's carry on and let's learn more about the hardware specification. So for example, 44 core, you can see clearly this is one RU unit, the processing, the memory, the storage and disk management. Let me quickly show you the diagram how this look like. So here you can see the front panel, you have slot 1 to slot 10 slots here, and then we have the specification and the description as well. So component and description. So you have say two 480 GB SAS SSD, and in slot 1 to then 1.9 terabyte 3 to 10. Then what about the RAID support? How much RAID support we have from 1 to, for example, 8 and 9, 10. So all description we have inside the component. So which component? Here you can see number 1. Then number 2, here you can see this power button. Then number 3, you can see the unit identification number. Then number 4, you can see that this is the system status LED. Then number 5, the power consumption. Number 6, the fan, network indication, the temperature, etc. You can see the logical diagram is also there. So we can easily go and check these things in detail. And these are here in detail as well. So number 5 is power supply, and then their color status means green means good, then amber blinking, then fan status green, amber, the network link activity when LED. So number 7, you can see the network link activity. Then number 8, you have the temperature. Number 9, that pull off asset tag, and then number 10, that is KVM connect. So 9 also you can see that pull. Here you can see pull asset tag. All right. So once you are very much familiar with the hardware, so how much memory, processor, and other stuffs they are using, obviously we should categorize first my need, how many sites, how many endpoints, because planning is very important before purchasing and then deploying the DNA hardware. So according to that, suppose we plan to go for the first one, that is 44 core or maybe 56 core appliance. So let's go and see the other specification, and this is the rear panel of either 44 or 56 core appliance. So now this is actually very much that we are interested, means network engineers, we are interested. So where is the RJ45? Where is the console? Where is the USB? Where is the backup? Where is the internet connectivity, etc. Now here you can see 1 to 13 options we have. In that we should know at least all the Ethernet interfaces. We have at least 5 very important Ethernet interfaces. So let's see one by one. So number 1, here you can see point 1 here. This is a modular LAN, MLOM, LAN on motherboard card bay. Then you have number 2, that you have the USB 3.0 ports. But if you can see here, the number 3 and number 4, they are the RJ45 type of connection. And this number 3 I have highlighted in black bold letter here, that this can be 1/10 gig management port. This network adapter 1 in the Manglev, that's the operating system we have, Manglev. Configuration, we will connect this port to a switch that provide access to an enterprise network management. Remember, we'll see later on we have list, and when I'm going to show you that what are the installation state, what are the options that we need to choose. So at that time you'll clearly understand that why exactly we need these many different type of interfaces. So this interface, either 1/10 gig interface, that's the first interface we have, uh, RJ45 type of interface that will be used for the management enterprise network. And then here you can see that you have point number 4 here, this place. And this is something like it can be connected with internet. So suppose software upgrade. Suppose if you are behind the proxy. So on those cases, when you are updating so many things, we'll see we have one long list of things that we want, and we want to connect with the internet, and we want to uh, download those software and upgrades from the internet. Correct. So that's why this port is important. That's the port number 4. Then we have port number 6, that is actually again very important, and this is something like GUI out of band management. So once you connect your device, obviously you want to access it via the GUI graphical interface. So for that reason, we have this 1 gig interface we can connect, and we can use that GUI out of band management. We have 7, that is serial port RJ45 connector. We have 8, that is the LED. We have 9 as well. So if I go back here, then you can see that after 3, 4, and 6, we have 7, 8, 9. These are the power slots. Then 10. So let me show you what does mean by this 10. This is something PCI riser 2 slots. And if this card is enabled in your appliance, you must disable it. If you do not disable the card, your appliance will contain 4 extra interfaces which could negatively affect your configuration. This is actually basically for future release purposes. Obviously, these are there that will be used in a future purpose, but uh, at the moment we know that okay, we have these 4 interfaces that can be used later on, but we are focusing on the 5 very important interfaces, where this one is this enterprise management, that is the interface 3. Then interface 4, the item 4 is for proxy connecting towards internet or going towards internet. Then we have GUI out of band management. This is the item number 6. Then finally, we have 2 major interface. The point number, say for example 11, I haven't highlighted here in black, but all these points are important. So where it is used, this is used, and here you can see this is the Manglef configuration, and this is used actually for the clustering. So this is 10 gigi cluster port, and here you can see that's name of this, and while you are doing the deployment, you'll find the same name will come, say ENP94S0F1. This is network adapter 4, and this is the right hand side 10 kbps port for Intel NIC in the appliance PCI riser 1/slot, and this is there for the clustering. Note, although capable of operating at lower speed, the enterprise and cluster port are intended to operate 10 gigabit. So although it can support 1 as well, or it can support low speed as well, but recommendation is that you should have 10 gig. So this is one of the cluster port. Then finally you have this 12 number item, that is the other interface 10 gigabit enterprise network. An important thing here is that this is connected to the enterprise network, correct? So this is going to be connected to the enterprise network. So that's the important thing we have that we studied. At least 2 things that we can summarize from here. First of all, you should know what type of model you have and which type of UCS series they belongs to. Then in terms of how many devices, concurrent sessions, endpoints, etc. Those lists are here. Then finally, we can go and check means which interfaces, which uh, RJ45 interfaces we are going to use as a management interface, as a intercluster link, as an enterprise network, as a out-of-band GUI management, etc. So those things are very, very important here. to understand the hardware specification of this M5 DNA appliances. In this section, we are going to talk about pre-installation plan. So you're going to install the DNA, and what are the things that you want to check? What will be your checklist? So let's see that what checklist we have. Actually, we have three prerequisite. We should have these three things before going for actual installation. So here you can see it is listed step by step. You check the cabling and the switching requirement, and we are going to talk all these things one by one in the upcoming session. So we are going to see the interface cable connections, then gather the IP address. So we should know about the IP schema, the subnetting, and other IP traffic information that we'll discuss inside this section. So one by one, we have all these sections in the upcoming sessions recordings. Then prepare a solution for a required access to web-based resource. We'll see in the upcoming session. Then we should know the firewall port openings and the security policy. Which type of ports will be opened? We have long uh, list of that port numbers. We'll discuss about that. Then gather the additional information used during appliance configuration and first time setup. So what will be those useful information? We are going to check that as well. So we are going to gather those information as well. So let's do this thing one by one. Say, for example, first of all, let's check about the interface cable connection. At the moment, we know that we have three different core, 44, 56, and 112. For that, we have five different type of interfaces or ports. And we have discussed this in the previous section that what type of ports we have. So here also, we are going to discuss one more time. If you go and check the DNA appliance, you'll find that you have one management port, and that 1 gig port is used or going to be used for enterprise management network. Now in this section, after 4 or 5 slides, I am going to show you that diagram as well with various label or various interface color. With coloring, it's very easy to understand. So we have one port for enterprise network management. Then we have 1 gig port for internet proxy or cloud access. Then we have one 10 gig port that will be used for enterprise port to connect with the enterprise network. Okay, and here you can see the hardware specification for 44, 56, and 112 core appliance. Then we have 10 gig port, and that is for inter-cluster communication. So I want 3 DNA center in a cluster. For that reason, we need that. And here we have one note as well. So while we are doing the deployment for maglev configuration wizard, we'll see that how this wizard look like. I'll show you one by one all these snapshots. Now at that time, it is recommended that you, so although you're not using the cluster of 3, but you should reserve one of the link for cluster, because suppose in future if you want to do anything, you have to re-image the appliance. Okay, so that means you have to do all those things one more time. Initially you have done the single appliance deployment, and later on you want to make this in a cluster. You have to do the re-image, and we have complete document for re-image as well. So if you go and search in Google, oh, how I can do the re-image, we have the set or the step or procedure to do the re-image. So something like that, if you are planning, so plan is, that's why you can see the plan is very, very important. You have to plan for your cabling, your IP, your web access resources, firewall port, and then the additional information. We should plan this. So how I'm going to do the clustering, which interfaces, which IP address, everything we need to plan. Then finally, we have one interface for SIMC. A SIMC, that's for out of band appliance management, and that's the reason we have one port, and these are the options. So few of the features we have seen, those are optional. Few of the features we have seen that those are must, because that should be there. Now, this is the diagram I was talking about. Here you can see clearly that in the bottom, and now again it's very easy to understand these bottom interfaces, this green, red, and black color interfaces. So these are, here you can see, one is for SIMC, one is for network adapter, one is for management. It's easy to understand or recognize here the bottom half ports are 1 gig. We can refer like that they are 1/10 gig. So you can see this red one is 1 gig, but the others we have option 1/10 gig, but the top half is 10 gig, 10 gig. So one is used for enterprise port, one is used for cluster port. Correct? So in that way, actually, we can understand that. Now, if you go and check the interfaces related to 112 core, so at that time you will find the difference. So let me quickly show you here. And here here you can see that you have the interfaces 1 gig, 1 gig, or 1/10 gig. And these three interfaces on here in between, you can see I have one enterprise port, and then I have one cluster 10 gig port. Okay, so these are the way that we should go and check and understand that how you are going to do the cabling. Likewise, we have 3-node DNA as well. So let's break this session in two parts. Let's stop here, and in the next session, we'll go and learn about 3-node deployment as well. 3-node Cisco DNA, and what are the IP we need, that is the prerequisite. So let's discuss that. Now, when we are talking about 3-node architecture, or we have different appliances and we want to convert inside the cluster, so at that time you can see the diagram. It's actually clear here that I have 3 appliances, and these 3 appliances, including one of the cluster link that we have. So here you can see that you have your cluster port, that is nothing but the network adapter 4, that is the enterprise 94SF1. So this cluster port, everywhere you can see cluster port we have, and in this way we are creating the clustering of the appliances or various appliances. Apart from that, all the interfaces here you can see clearly going to the switch, and switch is nothing but the representation of one of the network. So since all these colors and marking that you're seeing here going to one of the segment or one of the switch, that's why it is recommended that we should use non-overlapping IP addresses. So we should assign the IP addresses to all these interfaces that should be independent, and that should not overlap. If there is any overlap, then even in the installation process it will not be successful. Now in case of a 122 core, you can see the diagram and the interfaces, and you can see the clusters here. So this is the way that we should do the clustering of 3 appliances, 3 DNA appliances. Now what are the interfaces are used? Here we have the interfaces to NX cable for reference. So what 10 gig SFP we are going to use. You can take this, but you can check this particular slide and make a note. So far we have a study that we have 4 main interfaces. We have 10 gig and 10 gig enterprise cluster port. Then we have 1 gig and 1 gig. So 1/10 gig option for management and cloud portal. And then we have CMC as well. Here you can see that required, mandatory, but other are optional but strongly recommended. So in terms of IP address that you need, one IP address with subnet, 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 and for SIMC also you should have one IP address and the subnet. And in the next slide, I will discuss that in that particular subnet, what should be the CIDR that we are looking for. Here you can see that uh, since you have cluster of 3 appliances, then obviously you need one VIP as well, virtual IP as well. There is one small node that there are 4 interfaces on each appliance: enterprise, cluster, management, and cloud. ECMC, you can think like that: enterprise, cluster, management, cloud. At a minimum, you must configure the enterprise and the cluster port as they require for DNS Center. But there is a caution. The caution or precaution is this: suppose if you are doing the deployment, means you are doing the cabling, you are doing all the hard work, you are assigning the IP addresses, you are reserving the IP addresses, and once you do the deployment and later if you want to do changes, so suppose I haven't done the cluster mode and next I want to do the cluster mode, we should do the proper arrangement and we should have the reservation at least for that interface that I'm not using, allocate it as a cluster interface and assign some IP address. Otherwise, in future, if you want to do the change, you have to do the re-image process. You have to redo that process again. Okay, and this process is not that easy. It will consume lots of time. So that's why the planning is very important to do before doing actual execution. We can see that we have other IP requirements as well. So for example, default gateway IP address we need. Here in the blue color you can see, even you can go and check these links and you will get the DNA Center security best practice. Even I'm going to cover most of the things, but always you can go and refer. In Cisco we have very nice document. You can go and check to their URL as well. Then we need DNS server IP. You should have DNS server IP. If you have any static route pointing towards the gateway, then that also we can go and assign. Uh, we should assign the NTP because we want to do the integration of my DNA with the policy plane. And policy plane is nothing but the ISE engine. So for the integration purpose with the ISE and my DNS center, I should have proper sync between ISE and NTP server, and obviously we should assign the NTP server IP address, not only the policy plane and the DNA, but internally also all the hardware element inside the DNA should sync the time. So time syncing is required, and in the next session we'll discuss more about why actually we need such type of IP addresses, why there is a need of these many uh, non-overlapping, or why there is a recommendation, to be more precise, for all these non-overlapping IP addresses. Now for service subnet, and this service is something like internal services inside the DNA. So DNA has their assurance engine, their inventory, their collection and all. Uh, all these internal services, uh, these internal services, they are getting the IP addresses, non-overlapping private IP addresses in this range, and it should be minimum /21. So the internal processes can communicate with each other with these IP addresses and schema. So we have the service subnet or subnet services IP address. Apart from that, we should reserve the IP address for cluster service subnet. Okay. Again, this cluster service subnet means the database access, the message burst, and so many internal processes they want to communicate. I don't want to overlap all these internal communication and processes or the internal nodes. We are going to assign these IP addresses to DNA internal nodes. It should be non-overlapping. There is one example here you can see. So you can use these two because these are non-overlapping. Minimum you have /21, so you can use the CIDR of /21. All right, so we can stop here, and in the next session we are going to discuss that why exactly we need these many categories or these many isolation of IP addresses. What's the requirement we have? This session is very interesting and it is going to be short, but it is going to be very informative. What we are going to understand and learn here from this session is that why in first place I need these many addresses? Why I need these many address space? And the answer is that if we see the internal architecture of DNA, and for that I should recommend you that you please go and search Kubernetes based services containerization. Let me quickly go and open this link. Uh, Simply you can copy and paste in the Google. Even the URL is also, so once I post this document you can use this, but let me open this particular document. So I opened this particular link, and this is Kubernetes link cluster networking. Although suppose if you don't know Kubernetes and how this container services works, then please go here, have the basic concepts of container. But for DNA understanding, this is not required. This is just for the knowledge purpose. If you go and check the Kubernetes model, you'll find that you have architecture. First of all, you have container. It's like some sort of virtualization of the operating system. In this particular architecture, we have different type of nodes. So you have so many internal nodes, and these nodes, the intercommunication across these nodes are IP based. So all these nodes having certain IP addresses, and according to those IP addresses, they use to communicate to each other. That's the very top overview of Kubernetes, and here you can see this is say traditional deployment, virtualized deployment, where you have hardware, operating system, hypervisor, different guest operating system. In Kubernetes you have hardware, operating system, and then you have some sort of Docker, and then you have multiple uh, binary and library, and you have containers, a binary library. But the behind the scene thing is this, that internally all these containers, they have the nodes. They may have some master nodes as well, they may have some backup as well, but they are doing the communication in terms of that they are doing some sort of IP communication in between them. And that's the reason we have in DNA architecture as well, we have same type of containerization architecture. Okay, and the very reason, that's why we have these many IP addresses. So here you can see that we have 4096 addresses for the services and the cluster services. Correct. So we have two type of services and cluster services, inter-service communication, and the cluster who is doing the communication with various internal services. So that's why we have this IP addresses, and we don't want to overlap in between these IP addresses. Why? Because the last point here you can see that they will maintain the system performance. Why they will maintain the system performance? Because if you have non-overlapping traffic, then they will do not do some sort of inter VRF communication. That means they will not decapsulate the packets. They do not have recirculation inside the nodes. They have their individual space. According to that, they can communicate. Correct. So this inter communication or encapsulation, decapsulation within the system is something process intense, and that's why it is not recommended. Here you can see this leads to multiple in-cap, decap of packets going for one service to the another, causing high internal latency and at a very low level with cascading impacts at higher layers. It is very much abstracted or influenced from the Kubernetes based service containerization architecture. And then currently Cisco model, here you can see that Cisco DNA is supporting, say for example, 100 services, but Cisco is telling that in future there may be so many services can be added. That's why, just for the protection mechanism, they are giving a big address range to be reserved, correct? Then the final piece of this, obviously the point number one is telling that you have some reserved space that can be used in future or filled in the future. Now these service support over these subnets are L3 based. So this is again taken from the Kubernetes, and that is also L3 based. Uh, we have the RFC 1918 and 6598 requirement because of the requirement by Cisco DNS Center to download the package from the cloud. So remember, we have one cloud interface. So from Cisco, all those packages can be downloaded, and that's why we have non-overlapping addresses uh, uh, taken from RFC 1918 and 6598. If the selected IP range do not conform with RFC 1918 and 6598, this can quickly lead to problem with public IP overlaps, correct? So in short, if I summarize this particular slides, first of all, this is the IP based internal communication. There are some 100 services that is enabled at the moment, but in future we may have more services, so that's why we have one big chunk of addresses that is free. And finally, these VRF or these IP based services, they are using these RFCs for their address fulfillment. Okay, so this is actually very important, and I hope that you understand this particular session. Let us talk about requirement of Internet URL and FQDN, that is fully qualified domain name. And we have one list. You can see here in the list that in order to Cisco DNS Center must access these URLs and FQDN. So while we are doing day zero deployment, we should allow these URLs to access, or we want to access these URLs. Why? Because we want to download the updates to the system and application package software, submit user feedback to the product team. We have the DNS Enter update package. So here you can see that you have long list of URL, and that is Cisco Connect DNA. Suppose if you don't want to give single URL, so we can go and use this wildcard asterisk start. That means anything start with this, and then we can use 443 as a port number. Apart from that, we have other URL as well. So for Smart Account and Swim software download, these are the URL, user feedback, then integrate DNA with Cisco Meraki. So we have these wildcards and URL. Okay, what we want here, that we want communication from my DNA to these URLs, and obviously we don't want that directly. We can go and communicate. So in between we can implement proxy server, or the traffic will go via the proxy server. Here you can see you have some more URL. So you have software Cisco, cloud SSO, cloud SSO 1, 2, API console, API Cisco. All these are related to integrate with cisco.com and Cisco Smart licenses. Okay. Apart from that, if you want to render the accurate information in the insight and the location map, so these are the URLs. And for AI related stuffs, we have these URLs. So what I was talking, that you don't want to directly access to the internet. Obviously, the traffic first will go to the proxy, and from there it will go to the go and access the internet and the resources over internet. So in this case, what is happening, the communication between the say my DNS server and the proxy server, that is HTTP only at this point of time. But the communication obviously from the proxy server to the outside, that will fully support HTTPS. So in between DNA to proxy, we have HTTP. From proxy to outside, we have HTTPS. And then we need to go and open these many list of URLs. All right, so let's stop here. What are the required ports we have to do the communication from the DNA to and forth? And this session, you'll find it very interesting, and we are going to revise some of the ports that we know. Oh, SSH, say for example, HTTP, HTTPS, SNMP, other ports. So we have actually long list of port number listed in this particular session or recording. So let's see all those port numbers that is required while doing the day zero deployment. Now here you can see that you have incoming traffic obviously coming to your DNA. So you have the port number, and we'll know that actually these are well-known port numbers. 22 used for SSH, 67 for BootP, HTTP, NTP, SNMP, HTTPS, SSH, TCP. Again, these are some port numbers that maybe SSH can be hosted. Then 9991 multicast domain name system MDNS. For outgoing traffic, SSH, and for telnet 22, 23, we know that. We know that DNS uses port 53. We have port 80. If it is used, we can use 8080. And if you have Cisco supported certificate and trust pool, then obviously to reach to cisco.com/security PKI, you can use these port numbers. We have NTP, and here you can see the supported protocol. NTP, SNMP agent, HTTP, then ISE XMP for Pixie Grid, then 9060, that is the port number for ERS. Actually, these are the integration, API integration in between DNA and ISE. And later on, obviously, we'll discuss about when we'll discuss about the integration of ISE with DNA, what are the things required from the ISE side, what are the things required from the DNA side. Now, in the upcoming slides, you will find the ports or the protocols that should be open if the devices are behind the firewall. Okay, so let's go here, and you have this logical diagram that you have the DNS center, and maybe your WLC is behind firewall. Your infrastructure that you can see that your underlay or your fabric is behind the firewall, your DNS center, your ISE, and uh, DHCP NTP servers are in other zone. So in that case, you can see here, what's your source, what's your destination, what's your port number, what's your destination, and then the description. Now these important slides that you can even pause the recording and you can check. So for example, any to Cisco DNA, obviously UD5053 is for DNS server. So the description is from DNS center to DNS server. Likewise, for example, ICMP, DNS center, ICMP, wireless controllers from DNS center to WLC. DNS center, so from any, the source is any to DNS center, port 80 and 443, that's for AP, and you can see the description. So in the destination, you can see that you have DNS server, you have fabric underlay behind the firewall, you have NTP server, Cisco wireless controllers, Cisco AP, DNS centers. Then internet connectivity traffic, any to DNA, port 443, why it is used for. So you have the registry dot Cisco Connect DNA.com. Then you have Cisco Connect DNA, registry CDN, CDN Cisco Connect, software.cisco, Cisco SSO, and here you can see the description as well. So few of them are for DNS Center package, few of them are device software, a smart account access, CSSM is smart licensing API, CCO licensing, Meraki integration. So these things actually we study, and here good thing that here we have the nice summary format. Then this table is for Cisco software defined fabric underlay traffic. What's the source? What's the source port and the source? What's the destination? What's the destination port? And what's the use? So here you can see. So for example, from fabric switch and the router loopback IP to Cisco DNA and plug and play. So for that, these directions and the source and destination will be used. Same line you can see. Now here interestingly you can see that we have TCP and UDP port number 43, 42. That will be for fabric underlay. That will be used for Lisp encapsulation control message. So here you can see that you have Lisp encapsulated control messages, and then you have Lisp control plane communication. Both are happening at the level of port number 4342. Then here you can see 4789, that is for VXLAN GPO. This is the VXLAN port number 4789. Then you have the well-known radius port number like 1645, 1646, etc. Then you have ports for ISE, care of address. You have NTP, you have wireless controller. So everything should be taken care before doing actual deployment, and you have all these things listed here. So obviously you can take the notes from here as well, but yeah, for your deployment you can make the note from here. So for Cisco wireless controller, here you can see the list of that. So for example, HA server using TCP 1315, that's the DNS server. That's for database server HAQS. Then we have HA database port. You can see the well-known port numbers 1316, 13 up to 1320. Then you have 8082, that is HA web service health monitoring port. Again, here also you can see the long list of port number related to cap wrap tunnel, loopback, related to SNMP, traps, related to MSE services. Okay, so all these things, and finally you have this port number for AP pool, for UDP 68 and UDP 67 for DHCP services. Then you have 514 for APIP pool. That's obviously this port number belongs to syslog destination messages. Then you have these port numbers 69 and 5246 and say for example 5248 for wireless controllers for allowing the cap wrap tunnel. And these port numbers here that you are referring, you can go and check this sheet as well. So here also you have the communication between the inside the cap wrap tunnel from the WLC to AP, and that's the reason we have that port. Finally, for ISE traffic, you can see that if the destination is border and you are using the SGT exchange protocol or SXP, so at that time the port is 64999, means ISE and the other devices can have the secure tunnel. So if they want to communicate, you can create that tunnel. For that tunnel we are using this 64999. Then we have UDP 514, that's obviously for the syslog services. Then you have well-known radius ports for authentication, authorization, and accounting. Then you have UDP, you can see the port number for COE, then 123 for NTP. Now, good thing about all these lists that we are seeing here is that you can go and list each and every services related to DNA, related to wireless controllers, related to AP, related to ISE, related to DHCP services, because all these services are going to be used inside the DNA. So before doing the deployment, we should know the port numbers, services, and we need to enable or open these ports inside the firewall. Alright, so this was actually very informative session, and we have the summary, and actually we have the actual Excel sheet to create the firewall rules. Let us continue our discussion required for required configuration information. So still we are doing the day 0 configuration, and we are going step by step to know that what are the important things required to do the installation. Now in this section we'll learn that different type of user accounts and password and complexity of password required, because this maglev is nothing but the Linux type of server. So once we are doing the deployment, we should give the Linux username, the password should having their standard, like you are using the mix of lowercase, uppercase, numerical, special characters, etc. Then we have the password generation seed. So inside the maglev configuration, we can go and we have that option to generate the password and assign to it. Okay, so these are very much like once you do the installation, at that time it will pop up and you have to simply fulfill all these requirements. Apart from that, we have the password for Cisco IMC user password, and then we have the password for the master node. Suppose if we have cluster, we are using extra node, so at that time we need that. Then we have the password related to super user. We have password for Cisco credential, for Cisco Smart account. These things are very much a step-by-step process that we need to go and give. Then we have to assign the IP address, manager URL and credential, the proxy URL, port, and those credential, Cisco DNA Center users. Step by step, uh, everything will come. We have to go and follow these procedure. Follow this procedure means you should use a complex password. There are some password which is optional, but still you can go and assign it. If you have extra node, then use the master node IP address. Then you have to give the credential for super users, Cisco account, smart account, and then the credentials related to say IPAM, proxy URL, Cisco DNS Center. Now, one of the very important thing here is that while you are doing the integration of your DNAC plus ISE, at that time you have to understand few of the things. So we have to make a note this thing that during the integration, what are the important things. So ISE integration with the DNA, you will need Cisco ISE server IP address, administrative username and password. These are needed to log into and configure your organization ISE server, because we are going to do the mutual authentication. They form some sort of secure tunnel in between ISE and the DNA, and then they start exchanging their information. So certificate exchange, some sort of control packets, and then uh, the DNA, from DNA I can create the policy, push the policy, and it will be reflected inside the ISE. Obviously we need to enable the pixie grade and some sort of other settings as well that we'll see. Now there are some consideration that if Cisco ISE is not configured, or if the required version of Cisco ISE is not present, Cisco DNAC Center install means installation will happen, but group-based policy is disabled. You must install and upgrade the ISE and connect to DNA or DNAC. You can then start the data migration. So suppose if the feature compatibility is not there, the GPO group-based policy BP will not work, and we need to have the compatible images in between ISE and DNA to do this. Then Cisco DNA Center data present in the previous version is preserved when you upgrade. The data migration operation merge data from Cisco DNA Center and the ISE. If the migration encounters a conflict, preference is given to data from the ISE. So suppose we are doing the data migration, and at that time your policy related configuration, in case of any conflict or error, the privilege has been given to the Cisco ISE related to policy configurations. Now suppose if your DNS center is unavailable, so at that time we can go and make that ISE that, hey ISE, you are the policy engine, so move that ISE from read only mode to write mode as well. So from ISE the policy can get enforced, but these are very rare condition, but option is there. If your DNA is unavailable, ISE can work as a primary member or as a master. So this allows you to make policy changes directly in Cisco ISE. After Cisco DNA Center is available again, you must disable the read-only override on Cisco ISE and resync the policy data on DNA Center uh, from that group-based access control setting page. Only use this option when absolutely necessary, since changes made directly in Cisco ISE are not propagated to DNA. These are the corner rare cases that we need to take care. We have the authorization and policy service information. We know that ISE is going to do that. The thing is that ISE is doing its work, DNA is doing its own work. Once you do the integration between the ISE and the DNA with API, then ISE can work, or ISE will work as a read-only mode. You can create the policy from the DNA center and you can push that policy that will reflect inside the ISE. That's the use case we have in the integration. So if you are using the authorization and the policy server that is not Cisco ISE, you will need the server IP address protocol choice. These things you can see once I log into the DNS center. We have this option that you need to add the server IP inside the system, and then you can check that. So again, these are the use cases and corner cases. Also, we can say that, yeah, but it depends that in the existing environment, or in the client environment, you have some existing servers that client want to use it. So although ISE can provide those features, but client still wants to use those services because they are working fine and they are doing their services. So at that time, we have these options as well. Finally, uh, obviously we'll go and discuss more about the configuration, authentication, policy servers. We'll discuss more about that later on. Finally, we have the SNMP retry and timeout values. This also we can discuss later on in the separate section. So whatever blue ones that you are seeing, blue underline these nodes, one thing that you can do here, that you can go and search this thing in Google as it is, as a string. You will get the document, you will get the notes as well. The other thing that we will do, whatever blue ones are here, and if it is important, so we'll go and discuss this separately in the upcoming sessions. So far we have discussed a lot about what type of ports, what type of interface, what type of URLs that should be uh, allowed while we are doing the deployment of DNA. Now in this session have the summary of whatever we have discussed earlier. So here you can see that what type of interfaces you have. You have the SIMC port, you have enterprise 10 gig, intra cluster 10 gig, management and cloud update interface. Now, while you are doing the deployment, the prerequisite is that you should have minimum one DNS server IP, NTP server IP. If your DNAC is behind the internet, obviously you should pass that traffic via some proxy. So proxy server IP, proxy server port is required. Now, here you can see that because you have the services and then you have the cluster node. So what are the best practices for the cluster node and for the services, that you should have minimum /21 address pool reserved for cluster subnet and service subnet. Correct. Now, in case if you are making the cluster of the DNA, obviously the DNA appliances at least 3. So your latency should be less than 10 millisecond for that intra-cluster link. So suitably, you can think that, oh, so probably all those DNS centers are inside within same premises in same location, and that may be true for most of the cases, and until unless you're meeting the criteria of less than 10 millisecond of latency. Correct. Apart from that, it is recommended that you should have cluster of DNAC. Now here in the diagram, you can see that where all these port sits. So you have 10 gig of intra-cluster link, you have 10 gig of enterprise network, then you have 1 gig of OOM management, 1 gig of a dedicated management interface, 1 gig of cloud interface. Correct? Now let me quickly walk you through some of the standard, or you can make a table. In that table, you can put the enterprise addressing, OOB, SIMC, cluster link address, and the service subnet addresses. Here clearly you can see that for cluster link and the service subnet services, minimum /21 is required. For SIMC /32 is okay. For OOB management /32 is okay. But when we are talking about the cluster, when we are talking about the enterprise IP, so if we have three different obviously devices, you should have three physical IP, but you should have one virtual IP as well. Now, coming back to the enterprise IP address, so here you can see for DNA 1, 2, and 3, I have individual IPs, and then I have one IP for the VIP, that's the virtual IP. Okay, so these things are important, and while you do the deployment, you'll find that one by one you are getting the options to put these values. So nothing much more brainer. You can go through it. You can put what IPs for SIMC, what IPs for OOB, cluster, etc., etc. But before doing the actual deployment, we should have list of these IP addresses. Sometimes it's a bit difficult to get the free IP in a running infrastructure because most of the organization, they have already consumed the IP addresses, or maybe one reason don't know that other reason what type of IP addresses they are using, until unless we have some centralized IP address management, IPAM or other tool, correct? Great. You want to pass these URL because few of the URLs for cloud to get the updates from the cloud, few of the URLs to get the packages, Swim software, etc. And these things we have discussed earlier as well in detail. Here you're seeing this as a summary, correct? Now, so these are the requirement, and finally, when we are talking the cloud update, so here you can see that I have my user, I have my DNAC node, and then weekly. So here you can see that update using cloud tethering. Cloud tethered images are available once every few weeks. So you can think like, okay, in a month or in 2 months time frame, I have to get updates from the cloud, and then that I can install here in the schedule maintenance window. Now here you can see that we have the production catalog that is secure and goes through rigorous testing by Cisco Security and Trust Organization. So it's not like that you are getting some patch from the cloud and you are downloading it. It is secure enough because Cisco is doing a rigorous testing to make available those packages to the customer, and it's secure enough to download those images. Great. So let's just stop here, and next section I'll walk you through the steps. I have the snapshot. I'll show the snapshot that while doing the deployment to the DNA, what are the steps involved. In this session, I'm going to walk you through the installation steps. What are the steps involved to do the installation? Now, at this point of time, we know what are the prerequisite. You have unboxed that appliance, you have done the power cable, you have done all the connections. So my hardware label is ready, and now I want to boot my OS. I want to put certain things like the IP address, gateway, DNS, NTP, HTTP proxy, etc. And then my DNS server is ready to serve. So now my, you can think as your management plane, that's a DNAC. But apart from management, it can do orchestration, automation, assurance, etc. So there are so many things that the DNS server can do. So if you do the step number 1, step number 2, that means you are ready with your DNA. The next phase that we'll learn in upcoming session, that how you can do the discovery, how you can add the devices inside the fabric, how you can utilize um, the templates and other features to unify your wired and wireless network. Correct? So let's carry on the steps involved. You can see that once you boot up the server, then it will ask you that is it a standalone or it's a part of a cluster. So here you can see that select a start DNAC C cluster to set up the master node. It is recommended, always it is recommended that you should go and install the DNS server in a cluster. Now, if you want to do that, you have to go and check this particular option. So you want to make that cluster link, yes. you can do it. Now, once you do this, obviously you have to put the IP addresses for the cluster link, and we have discussed a lot about different type of IP addresses, even different type of interfaces that we need to do, and that we have to go and do the configuration. Correct. Now again, in this slide, it's step by step. You can follow all these steps. So here you can see that you can go and give the IP address, the gateway, the subnet mask, DNS server. That's type of mandatory thing that we should put the DNS server, the NTP, etc. Correct. So once you configure the network adapter 1, network adapter 2, then you can go and do the configuration for network adapter 3. You have to put all these mandatory things like the IP address, net mask, gateway, host, etc. Then you can go and put the network adapter 4 IP addresses and all those required information. Now remember here that when you are providing the information for a network adapter 4, at that time you are putting the static routes as well. Now this network adapter 4 belonging to, so let me highlight here, the enterprise network. Now for enterprise network, uh, where is your gateway and where your static route pointing to, you have to go and assign that information. Correct. So once you complete with network adapter 4, then your system will get booting. Now what we have done with all these network interfaces, that we have assigned the IP, gateway, DNS, static route, etc. Once your system will boot up, it will ask you about the proxy information. So are you behind the internet, the DNS server? Because we know that one of the interface is going to be connected with the cloud, and from there it will get all the mandatory packages and all the mandatory files, correct? And that connection communication should be secure enough. So we can go and give the information about the proxy. Then for that DNA, we can go and give again two very important things, that we have to provide, say, IP for the cluster that we have already given, and then IP for the services as well. So how the inter node communication will happen, correct? And the inside architecture is very much inspired from the Kubernetes architecture. That means that you have independent nodes, IP based independent nodes or services, and if they want to communicate, you have to give the IP to them as well. Correct. So now you can go and provide the details, or provide the IP actually for the Manglev. So we know that underlying operating system is Manglev. You can go and log into the Manglev, and you can check certain CLI commands as well that I will show in this presentation. You can go and give the username and password for the Linux user and the GUI and API as well. So set the strong password for the Manglev, that's the Linux. For the API and for the GUI, you can go and put the NTP. So it is going to do the check for the NTP, reachability with the NTP or not. Again, I told you already that we have services, we have cluster, and /21 is reserved for that. So we should assign those addresses as well. And finally, once we go to all these steps that I have shown you earlier, it will take approx 3 hours to boot it and fully functional. Now what we can do at this point of time, we can go log into the Linux shell, that's the Manglev. We can go and check the status of different type of packages. It's very much like we are using in case of ISE as well, where we are checking the application status for ISE. So here also you can go to the Manglev, and then you can check different type of services. So application policy, assurance, automation core, command runner, device onboarding, DNAC platform. Remember all these items that you are seeing here. For these items, most of these items, you'll find that we have the GUI option as well. So we can go and click to the command runner, and we'll get the CLI for certain devices. So whatever device you want the CLI, you can use the command runner. Likewise, we have separate independent tab for assurance, and most of these items you're seeing as a service. You can think these as a services. Next, very important command here highlighted. You can go and check the node status as well. And while checking the node status, you can see here what's the disk space, memory, etc. Those information. So very much like system specific information you can get from here. Correct. So once you do the installation, then obviously you want to log into the DNAC from the GUI. It is supported by most of the modern uh, web browser like Chrome, Firefox, etc. So next session, what I'm going to do, that I will log into the GUI, and in that GUI you will find that nothing is deployed. So up to this point, whatever we have discussed is already done in our lab. I can log into the GUI and you will get the blank DNS server. In upcoming days, what we are going to do is that we will populate that DNA. Means we are going to discover different devices, and then we are going to specify the roles of the devices. Means from the scratch we are going to build our lab, and then in future we are going to do the testing as well inside the lab. All right, so let me log into the DNAC server. Before logging to DNAC, I have few slides to show. So once you have done your DNAC installation, once you put IP gateway, DNS, NTP, etc., means once you have done all the required configuration, then you can go and log in via the web browser. Correct? So at that time, suppose if some other person has done the installation, you can go and change the admin password. That's obviously the Cisco recommendation. Now, once you change the admin password, you can go and register your DNA center with the CCU ID. Why? Because in that case, you will get the mandatory features like SWIM, telemetry, licensing, etc. And it can be added later. We can integrate our DNA center with the smart account as well. And nowadays, you can know that we have different type of smart account manage URL. From that particular smart account manage URL, you can even manage your DNA devices. You can manage your SD-WAN devices. Means you can manage your end-to-end IT infra devices from that software.cisco.com URL. Correct. Now, if you are going to integrate your DNA with IPAM, Infoblox, Blue Cat, etc., you can go and do it on day zero installation. You can go and integrate with the proxy server as well. So you have to provide the proxy server details to do the integration, correct? And finally, you will get one page where you have the terms and licenses that you can click next, and means you are accepting those terms and licenses. That is the mandatory acceptance required. So accept it, do the next. And now we are ready to go actually to do the automation, assurance, provisioning, designing. So good amount of things we can do from our DNA server. And in upcoming sections you will learn, understand more and more. So next session I'm going to log in to the DNA center, and then I will show you each and every tab. Although it's very busy, the dashboard itself is quite busy. Means you have so many options that you can do with wired and wireless infrastructure. So what you can do now, that you can log in with your username and password. You can do the design, automation, assurance of your network. Now, it's a good practice that once you log in first time, you can go and check the software updates. So what is the status of the software? Means what's the status of SD access, it is installed, it is downloaded, etc. Because in day zero, there are chances that you may get packages from the cloud, from the Cisco cloud, and then you have to install it. Now it's up to us that we want to install all the packages at a time, or we can select or deselect. So we can go and select certain packages which I want to install. So I can go and selectively install that. Otherwise, we can do install all as well. And finally, we should go to the software update, and we should check the system update, and we can check the progress for all those updates, installation, etc. All right, so let's stop here, and in next section I'm going to log in to the DNA, and I'll show you most of the things in the dashboard. But obviously during the lab, during um, the steps that we are going to follow related to design, obviously the planning, provisioning, um, assurance, etc., etc. So you will learn the usability of each and every tab. Let me quickly walk you through the DNA dashboard. So I have first install for DNA server, and then we can go inside our DNA appliance or server. Let me give the username and the password. So once we are inside DNA, first of all, you'll get the success message. And then once you get the success message, you are inside the DNA. Now this is 2.1.x. You have this tour button. If you go and use this tour button, obviously it will tell you, okay, take a tour. You can go and check certain very important things. The other option we have that we can go and learn the new capabilities inside the DNAC YouTube channel. So there you can go and check the latest capabilities and features. And here you can see the long list of videos, exactly 15 videos are there related to the session timeout, the integration with the stealth watch, and many more, correct? So these are all Cisco related videos that you can go and refer it, correct? And obviously this is with the latest code, that is 21x. Great. Now once you are in the dashboard, once you have the first install, here you can see that everything is showing 0, 0, 0. But what are the important thing here in the dashboard? Your assurance summary, your network snapshot, your network profile, and the most important things we have here in the bottom. So what are the most important thing, and that we are going to do in upcoming videos and session, that we are going to discuss more about the design piece, the policy, provisioning, assurance, and the platform. Correct? At least the design and the provisioning is very important for day zero and day one deployment. Policy is something that we have to integrate, or we can integrate our DNAC with ISE. So I will show you in the lab that uh, we can spin up ISE 3.0, and then we'll do the baseline configuration for ISE 3.0. And next, we'll go and do the integration of our DNAC with DNS Center with ISE. I will show you all these steps and the lab in the upcoming sessions. Then here in the bottom, you can see that you have various tools. You can discover the devices to add inside the fabric. You can go and check the topology. You can check the CLI equivalence, or you can get the CLI of a device. License manager, you can create the CLI templates. Security advisor, model config editor, network reasoner. So these are the tools we have, and you will see that mostly we are going to use the discovery. That's the day zero job. So you want to add the devices inside the fabric, you can discover via the IP ranges or the CDP, etc. Then the topology and the command runner is also important, but mostly we'll focus that with help of GUI, how we can do the design, deployment, provisioning, etc. Correct? The other thing here, all this information you can get from here as well. So once you go and click to the menu bar, here you can see that you can go inside design. Inside design, you can go and set the network hierarchy, settings, repository, etc. You can go to the policies. These policy you have, then you have provisioning. Again, long list of things that we can do with provisioning. We have the assurance where we have Wi-Fi 6 workflow. Tools is also an important place where we have the command runner, topology, discovery, template editor, etc. Then we can go and check the platform activity and run the reports. So it's a robust dashboard. There are n number of things that we can do inside the DNAC center or DNS server. And later on, what you can do, you can integrate with ACI, you can integrate with SDN, you can integrate with ITSM tool, you can integrate with IPAM manager. There good amount of integrations are available with the DNS center. Okay, so let's stop here, and we are going to continue our baseline study for few coming videos, and then we'll go little bit deeper inside the DNS center, and we'll learn some of the advanced steps as well. Let us discuss that what type of access or role-based access we have. I will log in and I will show you inside the system users that what type of users we can create. Here you can see that we can create 4 different type of user label. We have super admin, obviously that can do each and everything inside the fabric. Then we have network admin who has less privilege than super admin, but they can do all the access, but they do not have access to system related functions such as app management. Users means they can't change the password. Obviously they can um, change their own password and backup and restore. So very critical things they can't do, but they have uh, overall full access to the DNS center or DNS server, correct? Then we have the observer. Observer, as name suggests, that they have the read only or view only access. And then finally we have the telemetry role that's defined as a system role. This is a system level role restricted to connectivity to Cisco, correct? So the users category, they may fall under network admin and the observer. Obviously, if any L3 or L4 engineers or the architects, they have the full access, and then the L2, L1 engineers, they may have less access to the DNAC server. And according to that, it can be managed. So the thing here is this, that simple rules, obviously, and we can define the rules in these 4 categories. So what I'm going to do, let me quickly log into the DNS Center and let me show you that from where you can find this and from where you can create the users and assign the rules. Alright, so we are inside the DNS Center, and from the menu you can go to the systems. Inside system you can see that you have the user and roles. You can go there, and here you can see that you can change the password for the net admin or the super user. Then you can do the user management where you have option to add. So now you can go and add the users, and then you can give them the access level, either it's a super admin or network or the observer, correct? Now we can go to the role based access, and here you can see that even you can create the new role as well. While assigning the role, you can go and give the role and then the description, correct? Alright, let me go back quickly because I don't want to create any user, but I'm just showing you that how easy and simple that you can do all these things. Now if you want to integrate with the ISE server or AAA server, then you have this integration mechanism. So in upcoming labs, we have to integrate our ISE with the DNA, and once we do the integration, I'll come back to this place and I'll show you that, okay, you can see that you are able to see at least that your integration is there. So at the moment it's showing that there is no server found. Once we do the integration, we'll come back here and verify this particular page. Now again, going back to the system, here you can see that you have the software updates as well that we have discussed in the previous section. You can go ahead and check the installed app. So here you can see that long list of, so first of all you have the DNA core, then you have the automation, then you have assurance programming and integration, and finally you have the policy applications, correct? So at this place you can see all these software installed and what type of packages are installed or not, correct? Great, so let's stop here, and next section we are going to log into DNA again. We'll go inside the design section and we'll learn how to add the site and the area and the building, etc. So those things we'll discuss in the next session. Planning is very important aspect in all the SDN solution. Either it's a DNA center or it's SD-WAN or ACI. Now, what we are going to do in this particular lab section is that we are going to do the installation, first time installation for the site design. So how it look like, let me walk you through few of the slides, and then I will log into the DNAC and I'll show that how you can do it from there. So what's the design workflow? Create the design, define the network common settings like AAA, SNMP, etc. Then define the wireless setting if you have WLC and if you have APs. So you can define that wireless setting, create the template, that's the optional. Then define the wireless network profile, and then finally assign the wireless network profile to site. Only one additional step you have, that for wireless network, you have to define the wireless network profile, correct? Rest all the pieces are very easy. Now once you log in, you can go and check the design. Inside the design, you have that option. So once you click to the design, here you can see that you have the network hierarchy, you have the network setting, emails repository, network profile, auth template. So these settings we can do inside the design, and here you can see the steps involved. So create the site, define the network common setting, wireless setting, template, wireless profile, and then assign the profile. That's the same thing we have discussed in the previous slide as well. So first of all, what we want to create such a type of hierarchy. And now you can think this, that this is a very normal thing for an enterprise network, because enterprise network, they may have their offices across the globe. So you can go to the global setting, and then you can define different countries. Inside different countries, you can go and define what's the area, what's the building, what's the floor. Because obviously inside the floor, you have the floor plan, you have your APs. We have option here. So once you go and define the building name and the address for that, you will get the longitude and longitude. So you can locate that device, particularly which particular area, with help of GPS location. Now coming back to the floor plan, so you have option. You can upload the image as well. So maybe you can take those information from Cisco Prime, and those things that you have taken from the Prime, you can import here inside the DNA, correct? And once you obviously import that, you will get the floor plan for the APs. Here you can see that we have the common network setting like DHCP, DNS, syslog, etc. Correct? I will show you all these things in while I log into the DNAC. So let me do one thing before moving to the next phase, that's to discover the devices, do the integration of ISE with DNM. Let me quickly log into the DNAC and let's do few of the tasks, few of the things. Alright, so I'm inside the DNAC. What you can do, two things you can do here. Either you can go to the menu, and from there you can go to the uh, design, or you can go to the main dashboard. You can scroll down. Once you scroll down, in the bottom you can see that you have the design page. Once you are inside the design, here you can see that we have the design here. You can go inside the design, you can click any of these options. So add site location on the network. Here you can see that nothing has been added. You have option this plus sign here, or even you can click this gear icon, add area, building, import sites, map, etc. So I can go and add the area, and I'll give the same standard name, say San Jose. So parent is global, import site, it's okay at the moment. So now you can see that I'm one level down. Again, I can go to the global and parallelly I can add the other places as well. So I can go and add a pack location. Likewise, I can continuously add on. Now suppose if I want to add the building inside the San Jose. So I can go and give the building name San 10, and then the parent, you can see it is automatically populated. Then I can go and give any random address, but obviously you are going to give the correct address. So just for sake of simplicity, I'm showing you this. Now once you give the correct address, it will populate with the latitude and longitude, and it will locate that particular location that you can see here in the diagram, in the GPS location here. And now we are one level down inside this. Now again, you can go here and then you can edit the building. If you want, you can delete the building as well, but important thing here is that you can go and add the floor. So once you're adding the floor, so suppose this is floor number 10, parent is San 10, then the width is 100, but obviously you have this option that you can go and give the floor image, you can upload the file. The moment I don't have, I can click add. I sure want to proceed without the image, yes. And now here you can see that DNAC is giving us some default page, which is looking like this. And is even telling as well that updated just now, but once it has the data, it will get updated, etc. So this is the way that you can go and create the site hierarchy. Now again, if I go back to the global and let me go back to the, actually I can scroll up a little bit. Now one thing before telling you the rest of the configuration here, it's important here in the production network that you may have good amount of sites, and it's very difficult for you sometimes that you landed to the correct site, correct area, correct floor, etc. Maybe you have multiple floors and you want to search one particular floor, etc. So for that we have this search option here. Suppose if I want to search any San 10, I can check that, and here you can see that I am here. Okay, so those options are there. You can easily search from the search bar. Now let's go back to the design, and here you can see the other options we have is the network setting. Okay, don't show this again. So here you can see that you have the network setting where you can go and add the important things. So you can go and add the DHCP server, DNS, you can define the time zone. So these common network setting we can add. Then we can go and give the device credential. Now this is also network setting. So you have to define that the how DNA will log into the device, because remember we are going to manage everything from DNA. So DNA can use SNMP, or it can use normal SSH, or it can use netconf, or it can use SNMP to log into the device, and then even it can write or read some information, correct? So these system-wide configuration we can define, and later in the discovery phase I'll show that there are multiple ways, there are multiple places as well where you can go and add these things. Now if you defining the wireless network, you can go and define the address pool, you can associate this pool with the fabric or the VNs as well, then SP profile, wireless telemetry. Those things we'll see in the upcoming recording, because we have started with the basics, and later on we'll add more and more concepts, and we'll make this little bit complex, not much but little bit. All right, so this is the significance of the tab here. That's the design, and these are the options we have. Obviously, we are going to explore more and more in the upcoming sections. Next, very important topic we have is the integration of Cisco ISE with DNS Center. Correct? Now for that, what I have done that I am going to record different videos. So first of all, I have 7 videos from the top. So let me highlight till here related to basics of Cisco ISE. So suppose if you're not familiar with Cisco ISE, you can go through these 7 videos, and once you are familiar with ISE, it will become little bit easier that you can go and do the deployment of ISE, and then obviously we have lab to do the integration of ISE with DNA. For these two, we have hands-on lab that you will see in the once you complete all these videos. Or suppose if you are good enough in IC, you can skip all these 7 videos and directly you can come to the bottom and you can check the deployment. What are the things we need to enable while we are doing the deployment, or maybe post deployment also we can go and enable the Pixie Grid ERS services, and then how we are going to do the integration with Cisco, obviously IC with the DNAC. Now again, if I go inside ICE and if I uh, create some sort of tagging or some sort of SG ACLs or TrustSec configuration, if I do inside the ICE, you will see that those things are going to be reflected inside the DNAC or DNS Center. Again, first of all, complete the 7 videos, and then uh, we are going to do the deployment and integration with IC. But parallelly, I have some slides as well that what is going to be happen once your ICE is nothing but your policy plane inside this SDN solution. So what capabilities that ICE has, and with Pixie Grid, those capabilities will get exchanged with DNA or DNAC. Okay, so please complete first these 7 videos. If you know you can skip, you can go directly to the deployment of IC 3.0 and integrate IC with the DNAC. Before starting discussing the architecture of ICE, let's first of all discuss that what are the capability and what exactly ICE is doing. Now ICE is nothing but the identity services, and who can understand the identity of a various endpoint. So what type of endpoint it can understand? It can understand wired, wireless, VPN, any type of mobile devices, etc. Now once ICE can understand that which is the endpoint and what type of endpoint, again, see the endpoint may be bring your own device, it may be corporate user, it may be guest user, means the endpoint may be of different segment. Now depending upon that which is high priority segment then the low priority segment, the ICE can do the authentication. Now authentication process may be common for different type of endpoints, say for example MAB or .1x or any other. But after doing the authentication, what authorization means, how much those clients can do, and once these clients are getting access, getting authorized, then what they are accountable for. Okay, so all these 3 important things like authentication, authorization, and accounting, that is done via the ICE, but ICE can understand in different type of endpoints, and that's the key we have with the ICE. Now, if we go and check the evolution of ICE, so before that, Cisco has introduced ACS, Cisco Clean Access, NAC, etc. But you can think ICE as a combination of all. So whatever solution that Cisco has given so far the best one is the ICE because it has n number of capabilities. Now, when we are talking about n number of capabilities, here you can see in the diagram that who, what, how, different type of threats, when, where, health score, and CVSS. Apart from that, it has some other capability as well, but ICE is a identity server who is able to understand each and everything related to endpoint. Okay, and sometimes we think, oh, endpoint means laptop, endpoint means any type of so for example printer or any type of handheld devices. But now think like this, even we are talking about laptop, there are n different type of laptop with different type of operating system, with different type of patches, fixes. In general, these terms means associated terms related to the endpoint, they are termed as a attribute. So maybe one entity having n number of attributes, and those attributes we are sending to ISE. ISE could understand those, and then ISE can take action. Correct. So here you can see in the diagram that who, when, what, where, how, health, threat, and CVSS. Apart from that, ICE can take the context sensual information with the pixie grid. So we have the integration with uh, external RESTful APIs, or we have integrative or integration with APIs, and then we can do the pixie grid integration as well, that we'll check later on. So we can take the feeds, we can take the input, and then ICE can uh, take the action. What are the benefits? We have greater visibility. We know that once we have ISE, it can understand n number of endpoints. So that's the visibility is high. Now we have better security feature and experience for bring your own device, and that's actually a big advantage we have with ISE. Again, ISE, they are thinking that they are inside the zero trust model, means they are not trusting anything. And once you have the authentication authorization, means once you have authentication, then you can get the authorization. Once your authentication or maybe authorization get broke, if authentication get broke, means everything will go. But suppose your authentication is successful, you have any issue related to authorization, then your authorization can also decrease. Okay, then it is scalable. It's highly segmented, as I already told you. The different type of segments are possible in ISE, and ISE can act upon different type of segment metrics. Okay, ISE can track, and this is very important, that's why it is highlighted in red, that it can track up to 2 million concurrent endpoint session, and you can see that how big this. So ICE is capable of tracking 2 million concurrent session. Now again, the summary we have that we have the asset visibility, access control, guest access, bring your own device, segmentation, threat control, and device administration. Okay, so ICE is going to give these many high bullet point. Apart from that, there are some other features as well, but these are the top features we have inside the ICE. Again, that ICE is trusting none, means it is based on zero trust model. And here in the diagram you can see that it is going to improve the visibility and decision, software defined segmentation, service access entitlement. So nowadays, ICE can be integrated with, say, for example, SD-WAN, and ICE is a part of DNA now. So Cisco has one policy plane, and that policy plane is nothing but the ICE. Now this DNA can be integrated with SD-WAN, can be integrated with Cisco Data Center Solution, that is ACI. Again, the use case is that when you are dealing with multi-domain architecture. So in case of multi-domain architecture, uh, with a user, they will get one security group tagging, and that tag will flow throughout the network when we are talking about multi-domain architecture, and then that policy will be retained from one end system up to data center and vice versa. Okay, even apart from that, if we are not using the ICE inside this SD-WAN and ACI, but still we know that ICE is a robust tool, and it is providing n number of capability features and the security options. All right, so we can stop here. Next topic we have to understand about ICE architecture and various component. So let's understand. Basically in ICE you'll find that we have four major component. We have PSN, that is nothing but the service node. We have administration node, that is PAN. We have MNT, that is monitoring, and then we have policy exchange grid or PXE grid. Okay, so these nodes, now again I'm going to define that what does it mean by node, what does it mean by personas, what type of services we have, what network resources, endpoint and role. Each and everything we are going to understand, but this point of time we should understand the service, that's PSN, administration, that PAN, MNT, monitoring and PXE grid. Mostly in the production environment as well, you find that you have to understand at least PSN, PAN and MNT. So let's understand one by one each and everything. First thing, let's start with the node. What is definition of node? Now this node can be physical instance or can be virtual. So you can deploy the OVA file, or maybe you may have some ISO files that you can extract and install over the virtual images or or hypervisors, etc. Okay, so it may be hardware, it may be virtual. We have OVA files. We have so many OVA files, and if you go and check the Cisco download page, you'll find that is starting from generation 1 and then 2, and now we are somewhere in 2.7. Uh, One of the popular release for ISE is 2.4, and we are going to do perform lab on 2.4 and 2.6. These are the versions of ISE. What I will do in the next section, that I'll log into Cisco page and I'll show you at least the images, what is the naming convention by default when you're downloading those OVA files or other images from Cisco, but you'll find that you need big uplines. If not, you are using Cisco UCS type of servers, you need big uplines with very good capability in terms of CPU processing and RAM. Okay, then what is persona? Persona is nothing but determine the services provided by node. So you have the node, that's your appliance, and inside that you have services, that is personas. Majorly we have four different type of persona. We have administration, policy, monitoring, and then we have the policy exchange or the PXE grid as well. Correct? Now, what are the use cases, or what's the main role of all these persona? So persona role, so for example, service node. As name suggests, it will go and create services or policy services, radius and tachicus servers. So whatever services we are creating or whatever policies, decision policies we are creating for the endpoint, that will fall under PSN. Now what is PAN? Policy administration. You can think like this: whenever you are logging in to the ISE, where you are landing, you are landing to the web page, and that web page or that GUI or that ISE dashboard is nothing but the PAN. Okay, policy administration node. So in terms of say programmer, in terms of application programmer, you can think that you have the front end, then you have the back end. Your front end is nothing but the PAN, policy administration node. Your back end is nothing but the PSN, that is the policy service node. Correct? Now obviously we want to do the troubleshooting and monitoring, so where it can be stored, for that we have MNT. And if you want to learn and take action related to contextual services or contextual entities, then we have the PXE grid. Okay, great. Now one by one we can go and check the features related to PSN, PAN, MNT and PXE grid. So for example, PSN, and this diagram below that you are seeing is actually very important, related to all type of identity services. So you have something called supplicant, you have networking devices termed as a network NAD, or maybe network devices. This is nothing but authenticator, supplicant, authenticator, and then you have the authentication server. Now, this authentication server may be connected with the external AD server or external uh, maybe any type of database servers who is going to store the credential of user identity. So user identity is stored in other terms. Now we have the PSN, policy service node, that is integrated with any external resources. In between the networking devices and the PSN, we have protocol running radius or tacticus, and then the devices. So these devices, they can again use various type of method like MAB or .1x, etc., or maybe web uses. So here you can see that we have the web auth, posturing, client provisioning. Actually, these are the policies. So you can go and create the posture, the client provisioning, web authentication. These things I can go and create over the PSN. And again, it can be distributed to n number of device across the organization. That's the key factor we have with PSN. Then policy administration node, again I told you, whenever an administrator log in, he's logging in inside the GUI or the dashboard, and that dashboard is nothing but the PAN. What we can do overall management of each and everything. So license management, admin authentication, authorization, admin audit, these things we can do. Now, in terms of actual deployment, in terms of, say for example, distributed deployment, we may have one primary, one secondary. One primary is the active one, and secondary may be the backup. Here you can see that I want to write policies, but before writing the policy, I have to land upon, or I have to log in to the PAN, policy administration node. Again, I have the primary and secondary, so I can create policy, and then this policy will be synced or pushed actually to PSN, 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 PSN. So here you can see each and everything is getting pushed to PSN. Uh, because I have the PAN primary, so again the policy is going to push, or I have to do the sync. Policy should be sync across the ISE different personas. So it should be sync across all the PSNs and the policy administration node. Now again you can see that from PSN we are pushing something to the PAN, and the PAN is going to update each and everything. All right, so I hope you understand that the use of PSN, the use of PAN. Let's quickly go and discuss about NAD. Again, I told you this is working as an authenticator. Uh, Between NAD and the policy server or the ISE server, we have radius protocol that is going on. Between NAD and the end user, we may have different type of authentication as well. Correct. Now, what is the role of this NAD? Role of this is it is working on behalf of, or you can think this is working as an authenticator. Not behalf of, but it is a networking device from where the request will uh, reach or carried through the ISE server. Now, from ISE, depending upon what policies we have, we may get the DACL from ISE. We may get the group tagging from ISE. Again, it depends upon which what type of security policy, what type of policy we have from ISE for the networking devices. The next term we have the Pixie Grid. I already told you that they are there to do the third-party integration. So maybe I can get the context information from, so for example, firepower, or maybe any other networking or security devices, so that I can get into the ISE, and then ISE can analyze those and it can take decision. Now again, there are various terms like Pixie Grid controller, Pixie Grid publisher, Pixie Grid subscriber. So here you can see the subscriber list where you can see the ASA, IPAM, WSA, and other devices, IPS and other devices. Now starting from 2.4, the ICE is also supporting as a subscriber, that is the profiler probe. So although you are getting the information in terms of context, you can send the information as well in terms of profiler probe. That's the use of pixie grid. Again, it's very important in terms of if we are in the highly secure environment, we enable the pixie grid and use it properly. Then finally we have the MNT, monitoring and troubleshooting node. Everywhere after deployment, in operation, day to day, we need to take the logs, we need to take the tech file, we need to take the various type of syslog message, or whenever the problem is happening, we have to collect the log. So all those type of logs and the troubleshooting the stuffs are inside the MNT node. And one important point here is that max one primary and one secondary MNT is possible. Okay, so if you go and check the nodes, you'll find that it is given that how many maximum nodes you have in terms of pixie grade, how many nodes you have in terms of uh, administration node. So what will be the less number and what will be the maximum number? Even better that we can go and refer the data sheet as well before doing the actual deployment for the ISE. Let us continue our discussion and let's check the dashboard and the rest of the terminology. We have very nice dashboard. I'm going to log in and show you the dashboard. And this dashboard, we know that whenever we are logged in, we are logging inside the dashboard. That is nothing but the PAN, Policy Administration Node. Now this PAN, you can see that the topmost part, and again it's not that visible. Let me quickly log in and show you this. So here I have my ISE hosted over cloud. Now on the top you can see the first portion where you can see the summary, endpoint, guest, vulnerability. Again you have the home, context visibility, operation policy, administration, work center, etc. Now on top this belongs to the policy administration node. Again, if you want to go and create the policy, you can go to the policy, and here we are going to check these things later on. So we have authentication, authorization, profiling, posture, client provisioning. These things are actually related to policy, PSN, policy service node. This is the work of the PSN to create such type of policies. Now in our example, we are dealing here with the single deployment mode. So what does it mean by single deployment mode is that all the four personas I have in same ISE deployment. So here you can see that I have the administration and how I can navigate at this. So I went to administration and deployment, and then I click to ISE. Hostname is ISE. Here you can see the FQDN, the IP address, the node type, identity services. This is the primary because this is standalone. Now, if it is in distributed fashion, so I may have primary and secondary. For MNT also, I may have primary, secondary, and they can be distributed. Then I have n number of service nodes, and again I may have integration with the pixie grid. Each and everything you can see here. So administration node, the monitoring node, that's the role is primary. Policy service, that's the PSN. Enable service, session service, enable profiling service, enable the device admin service. These things are enabled for service node, and finally pixie grid is not enabled. But you can see the important three one, PAN, MNT, and the services. I have everything in single node because this is the standalone node, correct? But you can see that you have nice dashboard. Let me go back to the home and we can discuss this in upcoming sessions. The below portions that you are seeing here is belonging to the MNT, the monitoring node, and that's the thing we have in the PPT. So PAN, MNT, when the if you go to policy, you can reach to the PSN as well. Inside operation, you can see that we have the troubleshooting option as well, the diagnostic options as well. We can go to the radius, we can check the live logs, stack access, live logs, policy list, endpoint assignment. Then we have the troubleshooting option like diagnostic tools, download logs, etc. Okay, so overall we have the nice dashboard, and let's quickly discuss that whatever we study in previous section, that we have personas like PAN. So PAN is there to do the administration. You can create the policies and then you can push to PSN. PSN is actually where you have to create the policies related to radius, stack access, profiling, auth, posture, sponsor portal, etc. MNT is monitoring, troubleshooting, and network access. Pixie grid, then we have, actually it is not shown in this diagram, to take the contextual data, and then you have the authenticator, that is the NAD. So what does it mean by service? Service is nothing but some work, correct? Whenever we are talking about service, this is very much taken from the application world. So services, maybe in my Windows server, I may have n number of services. So services, for example, network services, maybe any web services, maybe any HTTP services, any SSH services, etc., etc. Like that, in terms of ISE, the network services are network access. So who has what type of access, profiling, posture, security, group access, monitoring, troubleshooting, etc. Okay, so these are the services related to ISE. Then what is a network resource? Network resource, again we'll see that in terms of endpoint, so endpoint belongs to MDM, mobility management services, or network devices. They have to do authentication with respect to radius, and then the authorization will come into the picture, and they will get a certain level of access, and then obviously the accounting will be there, that a particular user, after authentication, authorization, how much he has done, what type of work, etc. Correct. And finally we have the endpoint. So all the endpoint devices, such as say laptop or PCs or printers, etc., those are fall into the endpoint category. Role, I already told you that we have primary and secondary role. Now in terms of deployment model, I may have a standalone deployment that we have seen. In case of a standalone deployment, your all the four personas are inside single deployment, or in the production network we have distributed type of deployment. So we have the MNT somewhere, we may have Pixie grid somewhere, we may have PSN somewhere, we may have primary and secondary PAN or the administration node. Correct. So role depends upon what type of deployment we have, that can be changed. Now if we go and put everything together, we'll find, and here you can see the summary diagram. So first of all, we should understand the terms. So what does it mean by node? What is personas? Different type of personas. What is services? What is NAD? And again, different type of roles of different type of personas, like what MNT can do, what PSN can do, what PAN can do, what Pixie Grid can do. Correct. So for that, we have this summary slide, and assuming that up to this point of time we understand the role of different type of ISE component or personas, plus the network device and different type of endpoints. Correct. All right, so let's stop here. Let us understand about the deployment option. We have basically two type of deployment option: standalone and distributed. Inside standalone, again you can see that we may have a standalone with single node, or we may have a standalone with primary and backup, or primary or secondary. So how the standalone single mode will look like, that you have single node, inside that you have all the personas. So our PAN, our PSN, MNT, and Pixie Grid, everything is inside the single node. Now the problem with this particular design is that, suppose if your a node will go down, that means you lose the ISE access, and it's that cause very weird situation. Correct. So that's why we are going for the, suppose if you have to go to a standalone mode, so you go in the redundant fashion. In this way you can see that you have the primary and secondary, and remember we have primary for PAN, MNT, Pixie Grid, and secondary for PAN, MNT, Pixie Grid. But very important point, but the PSNs, they are working as a active. So we don't have the primary and secondary for PSNs, but they are working as an active node because they are the policy enforcement engines. Parallelly, you can see the number of concurrent connections as well as per the appliance or the hardware. Correct. Now next we have again it's just the deployment model. So here you can see that we have MNT, PSN, PAN as a primary, and those things are as a secondary. But again, in this case, it's okay that if the primary will go down, we have the backup from where it will get the authentication and all the services. But for the first model, that's the standalone deployment, here it's not a good design. And again, depending upon what type of use case we have, what type of organization size is there, people make choose one versus other. The next we have the hybrid distributed model, where you have the nodes, and in the node you can share the service. So still, suppose if I have two node where I'm putting pan MNT Pixigrid as a primary and secondary, and then I have distributed PSN. So let me show you the diagram. You can see that DCA have pan and MNT as a primary, and inside same DC you have pan and MNT as a secondary. So same data center I have primary, secondary, but my PSN working as active, it is distributed across DCA and DCB. Correct. Next we have the dedicated distributed mode. In the dedicated means that you have one node for one service. So for example, if I have two PAN, two MNT, four Pixigrid, that means each personas, they have their own services. Correct. But again, this PSN that you are seeing in the bottom, they are active, they are working actively, or they are working as active fashion, and they can be distributed across the network. All right. Then finally, we have the fully dedicated distributed deployment, where you can see in the diagram as well that you have your PAN and MNT, primary in data center, secondary in data center B. So primary in data center A and secondary in data center B. And then I have the PSN distributed across as active fashion. Correct. So here you can see it's actually very important and interesting that if you have the budget, again everything behind all this deployment, the cost is also a big factor. So what type of deployment the customer want, high availability and redundancy, so they have to pay for the licenses of the PSNs and all the different node. Correct. So as it's looking like the okay, we can go for fully dedicated distributed deployment as per the diagram, but it's still the software licensing cost involved there. Okay, so while doing the design for the ISE infrastructure, we should think about this deployment option and the software licensing cost as well. Let us understand the concept of sessions and sizing. Now sessions, they are very important, and when the session will get created, session term is very useful when we are talking about, so for example, firewall. So inside firewall, how many active session have? Means when a client or user, they try to access something that is going through the firewall, that will be one active session, right? And there may be sessions that is active, inactive, or maybe a stale entries will be there. But session simply means that how many active session you have monitored by that particular appliance. Correct? And now this has the significant role, because if the number of sessions will increase, they will go and impact the appliance sizing. And we'll see in upcoming slide that what does it mean by sizing of the appliance. Now here in the diagram, you can clearly see the formula that is used by ISE to understand the number of wired user, wireless user. In wireless user, we are taking wireless user into 2. That means we are expecting uh, 2 mobile devices connected with the wireless user. Then the guest access, that will give you the final number of the radius session, correct? So that means that if we have one switch, so here you can see that access switch port, a 48 port switch, and then the wireless AP, so AP into 2 plus 1, so means 1 AP. For one user, you can think as one, but again, the guest will be different entity, means how many guests. So in short, the number of active session or number of sessions will be more if layer 2 switches are more, access points are more number of guests are there. And according to that, we have to size, or we need to think the sizing of the ISE node. So here you can see starting with 3415 where the requirement was less, only 4 core, and the clock rate 2.4, the RAM 16 GB, and the hard disk is 600 GB, correct? But as we are moving down here, you will find that 3595, the CPU is 8, clock cycle is more, the RAM is 64, and the physical disk space is 1200. Again, as we are increasing the sizing, as we are increasing the capability, the number of sessions for these devices will increase, correct? So we have some more slides related to sizing. Now here in this you can see that it's sizing projection VM to physical appliances. Again, the sizing projection for VM to physical appliances. The bottom one is 3695, and the core, the clock rate, the memory, and the physical disk. You can see this is increasing. Now this purely depends upon the number of users we have. Suppose if you have less number of users, then why you will use 3695 rather than you can go for the lower end product. Alright, again you have the summary related to 36XX. So what will be the processor, the memory, the hard disk, the RAID process, the Ethernet NIC, how many NICs we have, and then the redundant power supply. So how we are going to build our ISE node over the data center. For that, what are the hardware required, what are the processing and cycles required, everything is listed here. Again, depends upon the number of users that you have, and depends upon that how much load you are putting in the ISE node. You can go and refer the specific data sheet. Obviously, if we have the valid account, we can raise a case with Cisco and we can ask the latest specification as per actually what operating system we want. We want 2.4 or maybe 2.7. So according to that, we can go and check that what is our plan and how many users we have, and then we can go and check the capacity planning and do the sizing. A few of the appliances are EUL, EUS. So here you can see that 3415, 3495, they are US, EUL, but we are using 3515 for a small, and then you have the medium size of deployment. So again, the sizing is important depending upon number of users and what compute or what type of hypervisor we have and what capability we have in a data center. We can go and choose the product according to that. Finally, if we are doing the deployment over the VM, and then again, it depends that what type of deployment we have. So in the single ISE, do we have the PSN, MNT, and PAN in a single node? Or we are grouping PAN and MNT, or PSN, MNT, PAN, they are individual entity, and then we are grouping one by one across the data center. According to that, the disk space will go and change. Okay, here you can see that we have one bug as well, which is telling that you can't go more than 2 TB for the virtual ISE deployment. And again, the best option whenever you are doing the deployment, you go do refer the data sheet, because these parameters are changing time to time, correct? So we have the baseline thing that how many sessions we want, how many users we have. Considering those things in the mind, what is our budget, what compute RAM and the power facility we have. According to that, we can go and choose the ISE product. In section 2.7, we have to understand about the TrustSec. What is Cisco TrustSec? Now, Cisco TrustSec, you can think, is a next generation type of methodology for providing the ACE entries or ACL entries. This is purely based on the labels. This is purely based on the security group tracking, SGT. So what is happening here, you can see that with help of central policy, that means from ISE, we have the access entry. We have the access entry that is based upon label, and from ISE, it will be pushed to all the NAD. That's the idea here we have with a TrustSec. So what is happening here is that the endpoints, that's the employee and the users. So we have the dynamic classification based on who, what, how, where, when. Actually, interesting thing here in the TrustSec is that we should understand three key points. Now those three key points are classification, propagation, and finally enforcement. So what is happening that you are doing the classification means which particular source wants to talk with which particular destination. Now, what permission they have, that will come from the central policy, correct? So for example, employee wants to communicate with employee, but employee don't have the communication with manager. So here you can see in the chart, that's the matrix we have. So employee to manager is blocked, employee to app server is allowed, but employee to financial services are blocked. Likewise, financial services to managers are open, but financial services to app servers are blocked. So like that, we have the chart who has what type of permission, and that you can think very much is the classification. The next thing is that we should have some mechanism. So for example, SXP, security exchange propagation. So we should have some sort of propagation method by which these classification can propagate, and obviously the ISE has to enforce these policies to the NAD. So the end goal here is that once ISE is pushing certain policy, and what are those acronyms, let me quickly show you that what terms that we are going to use here. So for example, the endpoint access control clients using 8021x, MAB, WebAuth, etc. Then obviously we have this NAD, network device access control. We have security group. Now what is security group? That is the user's endpoint that share the access policy defined by the ISE. And then we have SGT. SGT is 16-bit assigned. It's a number, 16-bit number assigned to the devices. So obviously what is happening actually that you are creating these TrustSec, these numbers, these tags actually inside the ISE, inside the policy. You have to map this, and then these policy obviously from the network devices, it will push to the it will push to the network devices. Means enforcement is network devices, but those things will be propagated to the end machines, and those end machines then they have the permissions, correct? So you can think like uh, classification, propagation, enforcement, that is from the employee till the ISE, and in reverse direction you can think enforcement, propagation, classification, correct? Now these numbers are actually auto generated, and they are big. 16-bit is a big number. That means it will cover most of the policies. Now these headers, these TrustSec headers, they are inside layer 2 frame. And while we are adding this metadata, means while we are adding these headers, they have complete overhead of 40 bytes. That is less than the baby giant. Now here you can see the information that we have 8021 AE header, where you can see that we have MACsec. Again, this MACsec is optional. That's not required for SGT, but inside the Cisco metadata, here you can see that inside CMD, we have the SGT value, 16-bit SGT value, and other fields also, just for your reference. Finally, the summary is that we have the classification, propagation, enforcement, and as per the metrics that we have, means what source has what destination permission, it can be propagated and enforced. Correct. So again, the important key points, we have the SG ACLs, control access based on SGT, downloadable environment data, means you will create all these things to the ISE and it will be downloaded with the NAT devices. We have the propagation method, that is the SXP. Some SGT are reserved as well. And then we have the IP to SGT mapping. Remember, TrustSec is IP independent. So whatever IP is there, it doesn't matter as long as we are able to enforce the policy with respect to tags, with respect to labels, that will work perfectly to us. And finally, we have identity port mapping that define end port to the port connection. So here you can see that it got propagated and enforced to the devices. Now, while using TrustSec, what benefit we have? If you go and compare with the classical uh, ACL or the async, so suppose if you have one source who having 6 destination, and suppose if you have 4 permission like HTTP, HTTPS, and some different port. So here you can see that one source having 6 destination, 4 permission, the total number of ACE entry will be 6 into 4, 24. Likewise, if you have 4 different source with same number of permission, so you can add 24 plus 24 plus 24 plus 24. That means 24, 4 times 24, 96. Correct? So these many entries you need just for 4 source. Now what will be the calculation if we have 400 source and 300 destination and 4 permission? The total number of entry will be 48k ACE, and that's a huge, and again this will get propagated throughout the network. Rather than if we go and use the TrustSec, so in that case it will be reduced drastically because now we are creating the policy based on labels. So 4 source, 4 destination and 4 permission, in this case it will be only 12. Again, if you calculate with 400 source and 300 destination into 4 permission, so total number of ACE entries in this case will become 300 into 4, means only 12k entries versus 48k entries. So obviously the great amount of reduction in the ACL entries. And while we are talking about data centers, this ACL entries are the overburden to the data center devices, that will get reduced to 70 to 60 to 70%. All right, so that's the TrustSec. Let me show you that how we can go and put the TrustSec label. So for that, we can go to the work center. Once you are inside work center, here you can see that we have the TrustSec. You can go to the components. Once you are in the components, here you can see that we have the security group. We have the IP SGT static mapping, the security group ACLs, network devices, etc. Now, once I am inside the security group, I can go and create one. So if I go and create security group, name say PC1, I can choose the label, and here you can see that we have the option to propagate to ACI. If we have the integration with ACI, you can use that, but let me click submit. And now you will see, okay, so PC1 is already there. So what I'll do, I'll go and create, say for example, PC2. And if I go and click the submit, you will see that the tag, so here you can see the PC2 and here you can see the tag as well. So tag is automatically generated via the ISE. Like that, you can go and create PC3, 4, etc. As per the requirement, we can go and create the tags. Now, once we have the security group, what we can do, again, I can go back to the policies, and inside policy, I can go to the policy set. And suppose our policy is employee access default. I can go inside the authorization policy. Once I am inside the authorization policy, let me scroll down. So where we have the wired policy, let me go a little bit down. So here you can see from bottom the tier 2 wired access. I can go to this tier 2 wired access, and then here in the security group option, you can go and check and you can select PC2. So I can scroll down here, and if I come down inside security group, even I can go and search as well. So let me do the search. Here you can see that we have the PC2. I can take that security label here, save this, and this way you can see that policy has saved successfully. So we have created the label for the TrustSec. We went inside the work center and the components, and then we have utilized that label inside the policy, inside the authorization policy. So this way we can configure the TrustSec label. In this lab, I'm going to show you that how you can go and deploy ISE 3.0. So let me go and log into the VM console of the ISE 3.0, and from there I will show you all the steps required to do the day 0 deployment. So here we are inside the ISE 3.0 VM console. The first thing you need to do is to type the command called setup. Now we can give the name of the IC, ISE01, and then the IP address. So let me go and use my management IP address range. That's this one, and then the subnet mask that I'm using some broader subnet mask. Then the gateway. So gateway is this one, this IP. Likewise, you can plan your IP, your subnet mask, and the gateway. You have IPv6? No, we don't have. What is the default DNS domain? So let's put that, and then it will ask you about the name server. So my name server is the same, that whatever I have as the as my IP of the IC, in my case the ICE server IP range. So let me go and quickly give that, and the same IP is for the AD as well, and same IP is for DNS services as well. All right, great. We are very much done. We don't have second name server. The NTP, no. Time zone, enable SSH, that's the mandatory. We should give yes, because what is going to happen in future, that when you do the integration of your DNAC with the ICE server, then the DNAC will use SSH services to log into the ICE and do all these necessary changes or configuration. Correct? So these are the setup commands for the ICE. Once you put this command, it will take approx 30 to 40 minutes to start all the applications inside the ICE. So once all the services will get started, we can log into the IC server, and then we can go there, because again we have to go there and enable certain services. We have to enable Pixie grid setting, we have to enable ERS. So once we enable that, then in the next section, in the next level, I'll show you that what type of configuration you need inside your DNAC server, and then this communication will happen, or the integration will happen in between the ICE to the DNS server, correct? So let me go and stop this recording here, because in this section, once my ICE is up and running, I will do the GUI access to the ICE, and then we'll do the rest of the steps. Let us continue the integration of Cisco ISE with the DNAC. What are the steps involved? Here you can see that we have some prerequisite. You should run ISE 2.3 code, and you should enable obviously the pixie grid setting and the ERS. You should have the ISE super admin credential, your ISE GUI and the CLI. Both places you must have the same user account, means you should have the highest privilege, because ISE can't trust anything. So while creating this trust in between your ISE to the DNAC, you should have the super user credential. That's the first thing. Apart from that, the ISE and the DNAC, obviously they are going to exchange the certificates in between them. So there should be a certificate exchange, and that should be legitimate. Next, what we are going to do, that we are going to enable the pixie grid. Uh, uh, Again, I'm going to show you all these things in the lab as well. So you will understand more and more in the lab setting. But we are going to use the FQDN as well, and I'll show you that in the DNAC we have to put that ISE FQDN in between, how the exchange process is happening in between DNAC to ISE. So what is going to happen, that you will go and open add server inside the DNAC. You will go and put the information. So you are going to put the information about the IP, the username, the password, FQDN, subscriber name. Correct. Now in between DNAC to ISE there should be a tunnel, secure tunnel, obviously, and that is something termed as a SSL based secure tunnel. So here you can see that we have the token, we have the search chain, and then the communication will start. So they have the initial handshake. The communication is actually SSH. Obviously, that's a secure way to do the communication. Then you can see that the ISE will respond. So push ISE trust is to, so DNAC and ISE, they are creating trust relationship. Once they have the trust, then obviously we are enabling the pixie grid setup inside the ISE, and we know that ISE, when they want to talk to the external world, when they want some contextual information, with help of pixie grid they are getting it. Correct. So now the pixie grid session is set up. So first the trust relationship or trust is established, the pixie grid setup is done. Then again you can see that download TrustSec metadata via pixie grid. Then we have the ERS, that's nothing but external RESTful services, that is enabled. And then with help of ERS, the ERS call to add network device create trust policy. Correct. So these settings, pixie grid and ERS, we should enable inside the ISE. And before even doing the communication between, actual communication between the ISE and DNAC, they should establish the trust relationship. Correct. How you can do it, how you can go and approve the pending approvals, etc. I'm going to show you in the lab. Now the configuration wise, it's easy. Let me show you the configuration, and some of the slides are just for the reference purpose, that you can see here that what is the negotiation. They did the DNAC trusted ISE trusted DNAC, where I have to go and approve the pending approvals, etc. Now coming back to the configuration, what you need exactly. Correct. So you need a certain configuration. Again, I will show you in the lab that inside the DNAC you should give the IP, the host name, so the IP, the username, password, the FQDN, etc. And then from the ISE you have to go and approve it. Inside the ISE you should enable the pixie grid, you should enable the ERS, you should enable the services. Right. Again, there are some prerequisites that I already covered, again just for the reference purpose. And then this type of page will come where you are adding the ISE inside the DNAC. So let me do one thing. Let me go and log into the lab section, and in the next recording I will show you all the steps that we have seen in these slides. Now I'm going to show you the integration steps here. and you can see clearly that ISE is still rebooting. It's still starting the applications. Once all the applications will up and running, then in the ISE we can log in and uh, do the configuration related to ISE specific, that is related to DNAC. Now you can see that the ISE is back here, and let me quickly go and try to log in. So let me put the username and the password. We are logging into the ISE 3.0 first time, and it is taking few seconds. It's getting logged in. So we have login success. The provide later, because we are not using the license, so we are using the evolution 90-day evolution version. That's just for our lab and demo purpose. All right, so now here you can see the new ISE dashboard. It is clean because nothing has been configured, nothing has been connected with this. Correct. Now what we want to go and check the deployments and the setting. Now again you can see that dashboard is very much clean. It is looking like this because you know that inside ISE you have n number of options and you can do n number of things. So that's why this dashboard is like this. Now inside this dashboard, you can see that I can go to the administration, and the basic principle is the same. Go to any of the tab, go from top to bottom, and you will get most of the things. So what we want at this point of time is that inside system we want to check the deployment. So I'll click there, I'll go to the deployment, and once I'm inside the deployment, you can see the name is IC01. I can go there, and here you can see that FQDN. This FQDN is required while we do the integration. Meanwhile, let me scroll down here because we need to enable few of the features. And because this is the single ISE node where you have all the components, like you have your policy administration node, your MNT, that's your monitoring node, your policy service, and one more thing I want to enable is that's the pixie grid. Before enable pixie grid, you should check that you have this enable profile services, that is check marked, and then here in the bottom you can see that have the pixie grid. Correct. So I can save this first of all. That's required for our integration, and then I can go up here, and what I want next is to enable the ERS services. Okay, and that is important because again we are using the RESTful API method to go and do the integration, or actually the communication between the ISE and the DNAC. So I can go back again here to the system. Here you can see everything you will get from this page. So now we are inside the system, we are inside the deployment, and then you can go and check. See, you have multiple things. You can go and check the settings, you can go and check the admin access if you are looking for the access and all. So I'll go back to the settings, because obviously inside setting you'll get most of the system related settings as well. Enable ERS read and write, and if you want to create ERS related username and password, and where it is required. So suppose you have your central uh, automation server or central automation system from where you are configuring ISE, your Palo Alto, your firewall, etc., etc. So you want to integrate everything, or you want to do the configuration everything with your Python converted APIs, correct? So at that time, for that API user, you should go and create the ERS username and the password, and for that you can go to the admin access, and from there you can create it. Okay, just as a side note. All right, and if you want to check what type of API is supported and what type of programming that Cisco is providing to the customers, you can always click here and you can have a look. It's still loading, but once it will come, you can check the supported API and other programming things that is supported inside this 3.0. All right, so we have done the mandatory things. We have enabled the uh, ERS, we have enabled the pixie grid. Now next what we want to do, so let me show you here. I can go here and here you can see that pixie grid summary. You can go inside the pixie grid and at the moment total clients 0, view pending clients not showing anything. Do I have anything? You can see nothing is there. All right, we'll come back to this particular place later on. Okay, again it is asking about the ERS username and password that you should create to log in here, but leave it this point of time. For this you can go and refer the Cisco docs. All right, so let's come back here and we can go inside the work center, and inside work center I'm looking for this TrustSec. Obviously we can start with overview and we can check all those things, but inside TrustSec you can see that what type of tags we already have, correct? So here you can see the contractor, the developers, employees, etc, etc. I want to create here few of the things, say account, and this is the identity. We can use any icon, any logical thing, and then submit. Because why I'm creating this, once you create this and once you have your integration, you can see all these information inside the DNAC as well. So here you can see account and HR I have created like this. Then what I want here is that I want to go inside the administration and I want to create some of the identities and group. So first of all I'll go here, I'll create the group and I want to create user defined group. Employees there by default and some other groups are there. I'll go and create HR, submit, and then I go and create one more called account and I'll submit this as well. Now you can see that I have user group HR, I have a user group account. Now next what I want to do, I want to create identities, and inside identities now you can see the power and capability of Cisco ISE HR1, and this is internal user. You want to give the login password, enable password like that. So I can go and give, let me quickly give that password, and then I'll scroll down. Again you have multiple information that we can give, but this particular user, that's part of identity. This particular user who's is HR1, this is part of a group and I should have that group here. So let me search here because I have created HR as well. HR, correct? So here you can see that you can go and uh, create multiple users and you can put inside the group, correct? Like that I'll go and create HR2 and I'll give the password here. I'll give the password and then I'll mark this under a user group the same. HR we can search like this, we can add. And once I have these two, then I'll add one more for account, only one more, account 1, and then I'll give the password like same,
and then mark this or put this under the account. So very much like ISE related things we are doing here, correct? Great. So from ISE side, we have done more than what was required. Required thing only to enable pixie grid and the ERS setting. Now what you can do here in the new DNA, this is new DNA, and here also you can go here to the menu, and then obviously here you can see there's n number of options here as well. The moment we are interested to do the integration only, so I can go here and add, check the settings. Now inside the setting, here you can see that you have the external services, authentication and policy servers. Otherwise on top you have the search. You can go and search that. So now it is asking that what's your AAA or ISE server IP address. So let me put that. That's 198.168.133.100 shared secret, correct? And then enable the IC or say username and the password and the FQDN. That's the important thing, correct? How you can get that FQDN? You can go here, you can go to the system and deployment, and then you can go to that particular guy here, ISE01, and from there you can get this FQDN, correct? That's very, very important. So now I have the FQDN, I can go and put here the FQDN. You have SSH key? No, I don't have. Let me try to save it. Now once you save it, if it will go and SSH, obviously we have seen that inside this slide that how they first of all they try to build the trust. Once the trust setting is there, then the pixie grid services will get enabled, and then with help of ERS the communication will happen. Now if the trust is not enabled or if trust will not get created, you'll get error here. If trust is created, then what you can do here, you can go back here, you can go to the pixie grid settings. So here you can go to the summary, and then you can see that pending approvals. So if you go inside the pending approval, you should see pending here. Something is wrong. Let's go back. Still it is in progress. Let's see. Let's wait here for a few more seconds. I waited exact 10 more seconds, and here you can see that this integration is in progress. Now let me go back here and let me try to refresh this page, and you will see that oops, I can see here, see clients, and now you can see that client is in progress. So I want to show you this particular page. Here you can see that approved is 50, pending is 50. View pending clients. Click here, and now here you can see that you have pixie grid DNAC integration is in pending state. On top you can see approve option, trash option, and all those other options, correct? And top itself you have this refresh page as well. So you select it, click approve. Yes, approve this. Server response is successful. Now go back here. It was showing in progress. Click refresh, and now it is active. Now since this is active, now you can go here and you can go and check your policy. Once you're inside the policy, you can go and check the group based access control, and here we'll come back to these things. But here if you go and check the scalable group, and now if I scroll this down, you can see the groups. It is showing total 18, and let me scroll down. We should see that whatever groups that we have created inside the inside the ISE, it should come here, correct? Again, it is not refreshed. Click here, refresh, and you can see that total number of groups are 18. Let me scroll down. Let's go to the next page, and we can see the PCI, test servers, TrustSec, all those groups. Guest external employees, etc. So total 18. And if I go back, let's check here in our TrustSec. I want to go and check this TrustSec and the components. So we have the components here, and here its total is 18. To do this full migration and to do the integration of DNAC to the ISE, we should go and do the start migration here. Now you can see clearly mentioned in the point that in order to being using Cisco DNA as the administration point for the group-based access control, that is GBAC in short, Cisco DNA Center must migrate policy data. So you can go and click this start migration, and now you can see that uh, during migration, changes on policy data may take place on both DNA Center and the IC. A data backup is recommended. Do you want to start the migration? Yes, I want to do the migration. So now the migration has been started. Here you can see that migration is in progress. You cannot. Now you can see that it has been migrated because there are very few policies that was there inside the IC, and that's why this migration happened very fastly. Now I can click refresh here one more time. Now I can see that again the total number of groups is 18, but still I can go and check and see my account and HR that I have created, correct? Now migration is complete. Cisco DNA Center will be the policy administration point now, and the screen of a scalable group. Access contracts and the policies, we'll see all these things later on. And the policy in Cisco ISE will be read only. So now my central policy authority system is my DNAC server, from where I can create the policy, and the IC will be in the read only mode. You can review the policy migration log. So we have the log, we can go and review there, and change the administration mode in the GBAC configuration. So we have this group based configuration where we can go and check here, correct? Even we have this view the migration log. You can go there and you can go and check the scalable groups. You can go and check the policies if you have any, correct? So you have the intranet, you have the extranet, etc. So now here you can see that we have done this integration, and whatever scalable group that we have inside the Cisco ISE, that we can see here, correct? And next what we can do here, that if you want to create any scalable group, we can create here. So suppose I'll create test01, and this is under default VN. Obviously we'll understand about the use related to infra VN, what is default VN, etc. By default everything will go inside the default VN. We are not propagating inside the ISE, so we'll leave it. Now this test01 that we are creating here, it should go and sync, correct? So now the scalable group is 19, and if you want to search, obviously you have this filter and you can search, but let me check here if I can directly go to the, I can show you this test because now the number has been increased. So test 01 is there. We haven't assigned any contract and any those things at this point of time. What I want here, I want to go here back and I want to do a quick refresh. Now here you can see this also become 19. So if I can go and I can point you towards test 01, and here you can see that we have the test 01 inside the default VN that has been created inside the DNAC, and it has been propagated successfully here inside the IC server. Correct. So this much thing that related to group based policy, uh, you can create from the central authority. Now your central authority is your DNAC server, and then very easily you can work around with the policies. So now this policy creation will be very easy. You can go and create it. We'll see that in later sections when we will learn about the segmentation and etc. So you'll see that it's very easy drag and drop type of thing that you can go and create it, and it's very easy to manage, handle all these policies from the DNAC rather than managing from the IC server. Correct. So let's stop here at this point. What is software defined access or SD access? And with help of DNA, inside DNA we have capabilities related to automation, assurance, provisioning, planning, analytic, that is part of assurance. So these things, how these things are fitting in a same place. So all these pieces, they are fitting inside DNA. What are the components? What are they used? Why they are used? Where they are used? All those things, terms I'm going to explain in this particular video. So here you can see that we have a digital network architecture. What's the goal? Few customer they want full automation. Few customer they want analytics or assurance, but assurance is the bigger term than the analytic only. In assurance, there are lot many things, and we have complete section with assurance. Complete one section where you will find videos, n number of videos, good amount of videos actually. So assurance is also a big thing. So few customers they want to use DNA just for assurance. They want to learn the behavior of a network and then they want to react or take action. Correct? Few customers they are prone. They want to do automation to each and every department. So that's the networking department we have with DNA. So they want to do the automation for their networking or IT infrastructure as well. That's the automation. But the point here is that okay, this solution evolved from the SDN solution. We know that we have software defined networking where we know that we have the management plane, we have the control plane, we have the data plane, and somewhere you'll find that in management and control plane you have policy plane as well. Correct? So majorly you have these many planes or these many, you can think as areas that is constituting SDN solution. Correct? Now here, what's your management plane? You can think. So my management plane here is nothing but my DNAC server. That's a DNA. Then what about your control plane? Your control plane is nothing but your control plane routers or CP routers where they are using the underlying technology called Lisp. So whatever endpoint are there, so at the moment these devices are going connected with the edge node. They are nothing but over the edge. So these switches or routers, they are termed as an edge node. So these edge nodes, they are registering their endpoint entities with help of Lisp to maintain a central control database or control plane database. That's the CP. That's the control plane. Everything you're doing from your DNA center means your automation, assurance, etc., planning, provisioning, etc. So that's your DNA center. That's your management plane. You can think like this. Then you have your control plane that you can see in the diagram. Your data plane is your edge nodes, and in between we know that the communication from edge to edge is VXLAN or customized VXLAN. That's the data plane, correct? And somewhere here you can see that you have the Lisp, here you have the VXLAN. So this is your control plane, this is your data plane, and then your Cisco TrustSec or CTS. That's the policy plane. So your policy plane is sitting here inside the ISE. Correct? Now, one thing I haven't covered here is the NCP, Network Control Platform, where you can go and do most of the analytical stuff, etc., etc. Again, this is the high level, but it's again logical, because if you go and compare control plane of DNA, control plane of SD-WAN, suppose if you are coming from SD-WAN world, or suppose if you are coming from ACI world or NSXT world. So there also you're finding the data plane, your management plane, control plane, orchestration plane, etc., etc. Correct? Like that, you can go and compare here as well, because whatever benefits I have inside ACI, what we want in ACI, we want VM mobility. In DNA, you have host mobility. In ACI, you want to use the subnet, means your endpoints should be independent of IP. Here also these are independent of IP. What you want in ACI, you have the VXLAN tunnel, you have the endpoints, you have the leaf switch, and then you have the VXLAN tunnel in between that. Here also inside the fabric, they are creating the dynamic tunnel if you want to do the communication in between. So the moral of this thing is that you take any of the SDN solution and same type of behavior or achievement or the end goal even in DNA also. Correct? Great stuff. So here you can see that once you go and log into the DNA, you'll find the design, provisioning, policy, assurance, and it's a big platform, this DNA, that can do n number of things. So it's a unified fabric for both wired and wireless network. Correct? And it has its own brain or different type of set of worker. So ICE, when we are integrating with DNA, it is working as a policy plane. Then you have the network data platform. Inside the software package of DNA itself, you'll find that there are so many software packages. In one software package, you'll find ST access. In one software package, you'll find analytic, etc., etc. And then obviously you have the endpoint devices, be it router, be it switches, be it WLCs, be it uh, wireless APs. Now again, this control plane management plane thing is not new, because if you go and study in deep about wireless networking, you'll find that yeah, in wireless region, the APs, they are forming some sort of cap WAP tunnel in between AP to the wireless. And again, there are two type of cap WAP tunnel. One is for control, one is for data. Correct? Now, this complete wireless thing has been shifted from wireless networking inside the DNA, and how it look like. So let me show you one combined picture here. And in this picture, you can see here clearly in the diagram all the components that I have explained you earlier. So here you can see that you have the edge node where you are registering the endpoints, and even we'll see later on that we are connecting the APs as well with these edge nodes, and their communication is VXLAN. But these APs, we'll see that how they are going to go and connect with the WLCs as well. Obviously, to reach to WLC, the control connection is the cap wrap, but when the traffic will move inside the fabric, that will be the VXLAN, encapsulation, decapsulation. So later on, when we'll go deep inside the fabric and their rules and how actually the traffic is moving, we'll discuss more about that. But at least at this point of time, you can think that okay, your edge point, they are registering the endpoints, or your edge devices, they are registering the endpoints. Then you have the border nodes or border router or devices where you want to do the communication. So maybe uh, across your fabric, maybe going to the data center, maybe going to the known or unknown networks such as internet or your corporate network. Correct? So you are going to use a border node. Then we have the central map registry system, that's nothing but your control plane, where you have your map servers. So again, you can see it's quite obvious here that, okay, I can identify my data plane, I can identify my control plane, and this we can think as a collapse control, because not only in conjunction this border and control plane, they have the routing capabilities, but they are knowing the entire database, so they know about all the endpoints and how to reach to the endpoints with help of Lisp protocol, correct? So now you can see that you have your data plane and then you have the control plane. Here you can see that you have your IC, where you can do the analytic assurance, where you can have your management things as well. So you can do automation and assurance. Finally, here you can see that you have your ICE as a policy plane. Now everything is okay, but what about wireless? So for wireless also you have consistent policy frame that you can go and create from the DNAC. And this wireless network, you can see here again we have separate set of videos, like we have separate set of videos for assurance, we have separate set of videos for wireless as well. So there we will learn more, understand more about how this wireless controllers and wireless APs, they are getting integrated with the SD access or DNA fabric. Okay, going back, so what is fabric? Fabric is nothing but the overlay. So in underlay you may have a redundant underlay network, but overlay, that's your virtual network, you can create multiple logical diagram on network. The good examples here you can see the listed: GRA, MPLS, IPsec, CAP, PAP, Lisp, OTV, DFA, ACI. These are the example of overlay network. I'm not stretching much here because we have two ways to understand this. Suppose if you are coming from ACI, you are coming from SD-WAN, and with respect to Cisco or even non-Cisco as well. So you can go and think, okay, in ACI, I know that what is overlay, what is underlay, and I'm coming from SD-WAN world, I know what's the overlay, what's the underlay. Like that, you can compare and understand here as well. What is going to change, that who is going to do the data plane, who is going to do the control plane, how the endpoint register will happen. So for example, in ACI, it is using COOP database, Council of Oracle Protocol. Here you have the Lisp and you have the control plane routers or CP routers, term as a control routers. So like that we can compare and then we can understand. So this is this happening in ACI and this way it is happening in DNA. So things will become easier. Otherwise, to memorize all these different rows, device types, how they are doing the network, how they are doing the data, how they are doing the control management, it will become little bit difficult to obviously have that much database inside the brain, correct? So we can compare, we can create one chart sheet somewhere, and then we can compare ACI this, SD-WAN this, and then DNA this. Likewise here also you can see that you have underlay network, you have overlay network. In underlay network you can run ISIS, OSP for any type of routing protocol. Remember again, it's recommended that we should use a routed or L3 fabric in underlay as well. And the same thing we have in ACI as well. We know that inside ACI we have IS routed network, correct? And that's why it's very easy to build dynamic VXLAN tunnel. Here also it is recommended that we should use L3 routing protocol ISIS as a control protocol, correct? On top of that, obviously we are using Lisp and then we can use any type of other control protocol. There is no restriction. Again, I'm not comparing with SD-WAN, but inside SD-WAN also you have something called Smart, and then you have the OMP, overlay management protocol, as a overlay control protocol. And in underlay you can use any type of IZP like OSPF, EIG, RPS, static routes as well. So obviously we are going to use the feasible routing dynamic protocols like uh, OSPF or EIGRP. But in case of DNA and ACI, it's mandatory. But in case of DNA, recommended is to use the ISIS protocol. Now, again, what are the challenges we have and how the DNA is fixing? Now, DNA mindset is altogether different, correct? So it is starting with automation, assurance, LAN, auto provisioning, and so many cool things. Whereas in the existing network or in the traditional network, what we are doing that, okay, if issue is there, we are fixing it. Issue is there, fix it. This issue, write this script. Although on other side you have your inbuilt framework, and even you are expecting certain issues as well, and then you can integrate with AI or other DevOps tools to rectify these problems and give the solutions. So in that regard, new service integration is very easy. Mobility you have, you can plug and play with the devices. You can insert n number of services. You can scale to any degree because these new solutions are fabricated in a way that they should scale. They should scale to big amount, to across the geography. And that's why whenever we are logging to the SD, either SD-WAN or ACI or maybe a DNA or DNAC service, you are seeing that you can check all the devices geographically separated across. So we have the geolocation map facility as well, showing that how you can scale. And not only you can scale in terms of devices, but you have a scale factor. You have Lisp that can scale, you have ISIS that can scale, and again you can create the virtual network and policy integration that can scale. And uh, obviously we have the programming and other flexible options as. Let us start where we left off in the previous recording. Fabric underlay, manual versus automated. What's the key difference? And actually this slide is one of the reference slide. You can think that where we want to reach and where we are heading. So do we have n number of devices that we are configuring it manually, or do I have one process, or do I have a framework, or have I decided to do the configuration in terms of automation or in terms of automated fashion, correct? Now when the term that is coming automated, one thing that is coming into the brain is that, oh, do I have a switch I want to plug in? Means once you plug the cable, once you power on, plug the cable, and poof, that switch will get all the configuration, and then it will join the fabric, and then you can go and connect the endpoints. Correct? So that's the term we have, PNP, plug and play. So how much it is suitable for plug and play? On other hand, when you are doing the manual underlay configuration, so in that case, you have to decide L2 or L3, what type of IGP, what's the role of that device. This we are going to discuss more and more in the upcoming sessions. So edge, border, or control plane or control device. What type of device nature is it? What we are going to define, correct? Now, in fully automated way, when we are doing the auto LAN or such type of provisioning, then it will support PNP. It will go and obviously what you need to do, even when you are booting up the device and when it is asking you want to go yes or no, do not press any yes or no. Even you don't have to do anything, just connect the device, and then plug and play agents are there in the edge devices or the devices, and then it will detect DHCP configuration, each and everything, correct? Okay, what's the key consideration? You have to configure a seed device. That's a prerequisite. So what is the seed device? You have your DNA, and then you have the seed device having a minimum configuration to bring the underlay devices as the auto LAN or the automation. Now this seed device that we are talking about here You may have primary, secondary seed devices. They should have the reachability through DNA. And what DNA is doing while doing this auto LAN provisioning or automatic provisioning, that DNA will go and configure certain temporary things inside that seed device. And once your automation will end, you have to go and press button. Okay, you want to stop it. So all those temporary configuration from the seed device will get erased. Okay, so that's the thing. And now what Cisco is doing, that in case of automated underlay, is that they are using best of the configuration. So whatever Cisco recommended configurations are there, those are getting pushed to the edge devices. While when you are doing them manually, you have to choose each and everything at all the places. You have to consider the MTU, and you have to go and configure the MTU as a uh, more than 9,000, and then you have to consider about the latency and those stuffs. So auto, you can go connect the device and automatically the fabric will push the configuration. Manual is still we have to take decision what type of configuration will go at what particular place. We are still building our fundamental knowledge about DNA, and with that respect, this particular video is very important. So what we are going to do now is that we are going to discuss about different type of fabric devices and their roles. So we know that what type of component we have inside the DNA fabric. Let's start with control plane node. Here you can see small database as well. Let me go back. And that's true. The main point here with all these control plane node, that they have the host tracking system. Is with the help of host tracking system, they come to know that what's the endpoint connected with which particular device, and then they will build populate their database. That's the key role. And here you can see that they have the endpoint. They can use IPv4, IPv6, those type of lookups. They extract those end ID with the known prefix. That means your corporate network, unknown is internet or any other, and then they resolve it. So what will happen that in future, if others will ask, oh, where is that endpoint, then they can go, they can do the query with the control node. Control node do have this information, and you can think that control node can work as a proxy. Like in ACI, a very popular term, we have a spine proxy. So this can work as a control proxy, and if someone will ask on behalf of others, he can give the first response, and then the dynamic VXLAN tunnel, with help of dynamic VXLAN tunnel, the communication or rest of the communication will happen. Correct? What is the supported platform we have for that? You can see a long list of family series. We have Catalyst 3K, 9K, 6K, and then ASR, ISR, and CSR virtual. Again, to get the updated data and data sheet, we can go and check Cisco site with the latest data sheet. What is the latest images? Those are supported. Now, how we can assign the role? Obviously, these things we have to check inside our lab. So what you can do basically, you can see that you have the option. You can select the device. You can make as a CP as a control plane node, but the rest of the options here you can see that you can make certain devices as a border as well, or you can have the collapsed control plane node and the border node. Correct? So these are the device rules that we can go and assign, and rest of the thing the DNAC will take care. Second very important node we have is the edge node, where you have the actual endpoints or the users connected, and from one place to other place you have the VXLAN tunnels, so that's why they have to do the encapsulation and decapsulation. Now again, here we have the concept of pervasive gateway or anycast gateway, that work for any of the user if they are roaming user from one location to other location, since their gateway is defined as an anycast gateway. So it doesn't matter, they will reach to their stretched gateway or anycast gateway, that's the proper term. So they can reach to their anycast gateway, and then if they want to go outside inside the corporate network, they can use this. Actually, they can reach here to the border, and then they can go and reach to the corporate network. Suppose if they are using the internet uses, so they can go to the border, and then they can go and use the internet resources. Correct? Again, these devices, they are basically configured in terms of they can do the static 8021x or uh, external identity integration. So basically they can do the authentication authorization, whatever ports connected to these edge devices, and they have the /32 IP addresses to register to the mapping server or to the control plane node. Supported model 3K, 9K, 4K, and 9400. You can have a reference for these slides. Even we can get proper data sheet DNAC supported devices in from the Cisco site, so that you can refer. How you can give the device role here. You can go and select the device, and then you can make add to the fabric, and that means that you are making this device or you're making this particular hardware part of fabric as a edge node. Final term. Finally, we have border node. So who has to do the communication to the outside world or the internet, but they have the communication with the control plane node here. Even the WLCs, they are also communicating with the control plane node, because these border devices, these WLC devices, they need to know the endpoint information. And who is going to provide the endpoint information? That's nothing but your control plane node. So here you can see that we have two types of border node. One is internal, so this is I border, and one is external. Suppose if you are doing some sort of internet access or going outside to the your corporate network, from your corporate network you are going outside, so in that case you can use the external border. So two different type of role we have for the border. One is the internal, other one is the external. Long list of devices: Catalyst 3K, Catalyst 9K, 6K, ASR, ISR 4K, Nexus 7K. How you can assign the role? Again, you can see that do you have the control plane, do you have the border, do you have the control plus border, means do you have collapsed device role. So a single device can work as a both control plane plus the border device. Then finally, we can go and discuss about the internal and external nature. So I already told you that internal means that you are communicating within your organization, maybe your data center uh, or maybe regional hub, etc. So those prefixes that you know, that will come under known network, correct? And then you can export all the internal IP pools. You can have full sort of communication in between that. So the story here is that you can do the import and even you can do the export as well, because you know that what type of prefixes you're importing. You're not importing complete internet. Like here, if you import, that means that is you're importing a big internet or BGP table, and that's not a recommendation. Maybe your device will get crash, and maybe device will get rebooted. Okay. So here you can see that in terms of internal border, you're doing the communication with your internal network. Then you can export all the internal IP. You can do the import and register to the known IP subnet from outside into the control plane system. So from here, it can go and um, get identified the control plane system. It is doing the handoff for the mapping of VRF and security group tagging, SGT. Basically, you can think this as a gateway for your endpoints that is doing the communication within the network. Now, what are the rules here? Again, you can see the rules for this control plane devices. Obviously, we are talking about the control plane devices. Three rules are there. Rest of the company, that means your internal communication, correct? Then outside, that means your internet or any outside communication. And then you have anywhere. So either inside or outside, it's like default type of thing. So be careful while choosing the rule. You want to uh, fix that device only within the corporate, or you want to leak outside, or you want to do everything inside plus outside, correct? So be sure that what type of border device role you are assigning to that particular device. Next, we have the external border where you have the unknown network. Now remember, the key factor is this one: does not import unknown routes. No entry is available in control plane. So if you import complete internet, or if you import some routes that you don't know, that's the high level risk, is not recommended. Again, the handoff require mapping of the context from one domain to other domain. So if you are moving from one domain to other domain, then if you have the labels, tags within the VRF, then that handoff is required from one label to other label. How, what are the restriction, or how they are doing the communication? Connect to the unknown network like internet, public cloud. Export all the internal IP pool outside. Means you can export your internal network to outside, but never take any unknown thing from outside to inside, and that's the key. How you can enable this? You can simply check outside world. So now you can see clearly the inside world, outside world, or maybe in lab scenario, you can go and enable anywhere to anywhere just for the lab case, or maybe some of the test cases you'll find that you want the third option as well, but that will be limited. Now, what about the deployment model? Now, for example, if you point out all the routes, either it's a known or unknown, towards the external border, and suppose you have only one border, for example, that means it's not a efficient good routing. So the things will come to the border, again they will go and check the specific route, and then it will go to the branches, rather than to optimize such type of routing. What we can do, that we can give high specific routes to the branches or data center, and then we have one default route going towards the internet. So if those routes will not hit, then finally it will go and check external the default route and reach to the external network, rather than uh, if you have the default route. So rather than, what is happening in this case, that everything is trying to check to the outside. So you have the specific destination, a specific route, and then if you have the default route, it can go to the internet as well, or the public cloud as well. All right, so this was the very important session we have, and we have checked different type of device roles. Not only we have discussed about that, but inside the DNA you can go and basically assign the device role to the devices whatever you have discovered, and then you can go to the border and you can check that you have the external border, internal border, or maybe you have third option, that external plus internal. So everything you want to allow. All right, so let's stop here. Let us continue our discussion and discuss about fabric enabled wireless. Now in the diagram you can see clearly that in between AP to the edge device, and that's the key. So in between AP to my edge device, I have VXLAN tunnel, correct? But from AP to the WLC, I have the CAPFAP tunnel. And here you can see CAPFAP and VXLAN tunnel. Now what is the significance here? The significance here is that my SDA fabric, my DNA fabric, Inside that, I have seamless, again, I have seamless integration in between wired and wireless network. So the user, either it's belong to wired or wireless, they are unified inside a single fabric. And that's the power we have with the DNAC. So here are some points. Let me quickly walk you through that points. We have the underlay as my wireless network. We can use it. Now the cap map tunnel, you can see in between the WLC to the AP, and the VXLAN tunnel is in between the edge node to the AP, correct? Again, we have dedicated host pool, and we'll see all these wireless related lab and wireless related theory little bit in deeper in upcoming session. So we have actually complete section for wireless device onboarding and wireless technology in upcoming sections. Again, the fabric enable AP connects to edge with the VXLAN that we have discussed. Wireless client SSIDs use a regular host pool. Now, what is this host pool? It will come in next video. I'm going to cover it. But host pool is there just to provide IP reachability, correct? So the SSID uses regular host pools for data traffic and policy. Same as wired, means there is no difference in terms of policy. So suppose when you are creating the policy from the policy builder, there is no difference that you are creating the policy with respect to wired network versus with respect to wireless, correct? Now the fabric enabled WLC register client with the control plane, and that's key here, see? So what is happening here, that we know that control plane has all the endpoint information, all the host tracking information. So whenever any endpoint get connected with the edge device, edge device sending that information to the control plane. Hey control plane, this is the information, you please put this into in your local entry, correct? And now, because control plane and WLC has the connectivity, so control plane is exchanging those information with WLC and vice versa, correct? Means they are doing the communication. That's the key here. Great. Now, what are the models and devices supported? So here you can see 3540, 5500 WLC, 8500 WLC, then Wave 2 and even Wave 1 is also supported. So mostly these are here you can see on the top, first, second, three. These are the WLC, and then here you can see that AP. But still, if you want to know much more about what type of products that is supported, so obviously you can refer to the DNA supported device matrix. Again, in the lab we are going to discuss more and more about the roles of the devices, but here you can see when you are doing the provisioning fabric and the device onboarding, again we'll see this later on. So you can go and check that particular device, you can go and check that these devices are connected with which particular uh, edge edge node, correct? So edge node and the APs are connected. Again, we are going to discuss these things, the lab and the theory in detail in upcoming session. So let's just stop here, and in next section we are going to uh, cover few more terminology, few more fabric construct, and then we have lab related to DNA device discovery. The next topic we have about the fabric construct. Now this particular video is very much important related to SD access fundamentals, because this is the key and these are the topics that we are going to use more and more while we are doing the deployment or the actual deployment, correct? So what you want? You want virtual network, because we know the concept of underlay, and we know that on top of underlay we are going to build the overlay. So you have the underlay, and this underlay should be resilience enough, should be resilient, that on top of this you can go ahead and you can build the overlays. So you may have virtual network. Virtual network is nothing but overlay, and this virtual network concept is true with all the SDN solution. That's the interesting thing. So learn one type of SDN and the key concept will be used in other SDNs as well. So for example, if I go and compare the SD-WAN and the SDA, correct? So inside SD-WAN, you know that the overlay management protocol is OMP. That's the overlay management protocol name itself. And in SDA, we have overlay management protocol is a Lisp. But obviously there is underlay, correct? So here you have the underlay, and in underlay you can run any type of protocol. Again, on top of underlay, we have IPsec tunnel from one edge device to other edge device. And here we have some sort of VXLAN tunnel. And that's the customized type of VXLAN tunnel because they are going to encapsulate some sort of tag as well. And we'll go and learn about this tagging as well. That's the security group tagging, SGTs, because they want to carry from one location to other location. And once you have, in terms of SDA again, not SD-WAN. So in terms of SDA, once you have the underlay, then you want to segment it, correct? With the virtual network. That's nothing but your overlay. So let's focus more here. Your virtual network is like VRF or VRF, correct? Now here you can see that it can be default VRF is instant ID 4098, means you can have 2 to the power 12 VRFs. And again we can check what is practically supported and what is theoretical number, correct? So theory versus practical thing you can select. So for example, if it is in theory, we can select, we can support 4K VRFs, but in practical, how many VRFs can device support? Because technically you don't need that many VRF, or you need that many VRF if you are a service provider network, or maybe you are a big enterprise network where you need different VRF for different department. Then only you will cross 4000 VRF, correct? Anyway, so what is this virtual networking is nothing but the VRF, virtual routing forwarding instance. By default, it will be default whose instance ID is 4098. Nodes add vnet to the fabric encapsulation, correct? You can see here that nodes are part of the vnet. Vnet is nothing but uh, virtual network identifier, is just the type of encapsulation that will be carried inside the data packet whenever you are moving from one endpoint to other endpoint. In between, if you have the VXLAN tunnel, obviously inside the fabric from one edge device to other edge device, we have the VXLAN tunnel, and that's the capability of VXLAN tunnel. If you go and check the encapsulation, you will find that one field is reserved for VNet, and that is going to give you the 2 to the power 12 number of IDs, correct? Great. So endpoint ID prefixes, that's a host pool. Again, we are going to discuss about the host pools are routed and advertised within the virtual network. So you have one virtual network, you are doing all the routing and switching inside that. But if you want to cross one virtual network to other virtual network, you should have to do the route leaking. So some sort of mechanism that we know that we need to import and export the route from one VRF to other VRF. Use the standard VRF definition configuration along with the RD and RT. That's the same thing. If you know BGP, that you know that you have the IPv4 VPN, or maybe IPv4 or maybe IPv6, any type of address family. But if you're dealing with the MPLS and you know that you have the VPN address family, or maybe you have some sort of labels. So from BGP to MPLS address families, whatever we are using, we can do this import and export keyword, correct? The other example is in case of Cisco Viptela SD-WAN, where if you have different VPN, then you can export from one VPN to other VPN and likewise. Great. The next very important topic is the security group tagging. Now we know that we have the policy plane, that's the ISE. So ISE is working as a policy plane, and once your ISE is completely integrated with DNA, then you can go inside the DNAC or DNA, and inside the policy you can create different type of groups, and for those groups you can put certain contract. So that's the key. Now if you check this inside the ISE, even with the ISE also we can do it, but still in ISE that is little bit difficult because the GUI is very much populated inside the ISE. You have so many options inside the ISE to go where and to do what you want to do, because there are n number of options inside the ISE. But if you check the DNA GUI, it's quite simplified, just simple drag and drop type of thing. So suppose if you have HR and the IT cells or IT department, that you have created two tag or two label, HR and IT, then you can put some sort of contract in between that, that if you have a permission or certain type of port numbers or certain type of application can talk, rest will not talk. So those type of things we can go and create it. Again, we will see this thing later on in the lab, and that will make some more information, that will make some more sense here, because at this point of time we are simply talking about the theory, but still here you can see in the diagram as well that you have SG, SG, SG 1, 2, 3, like that inside the VRF. Again, the whole idea about the SDN solution or the SD access is that we are independent of IP, and since we are independent of IP, then whenever it comes to the access level or whenever it is coming to the permission level, so we should allow or disallow this thing with help of tags or security group tags, correct? And that's the whole idea about the scalable group. Again, you can see it's very easy. You can go to the policy virtual network. There will be two default VNs. One is default VN and one is the infra VN. And rest virtual network you can create. Now, suppose in this particular group, that's the default VN, you have 12 different type of let me yep, 12 different type of groups, and it's easy. We will see that you can simply drag and drop in between that. And again, if you want to create some sort of contract, you can create it. Means just the access permission. More on this we are going to discuss later on when we are going to perform the lab related to security group ACLs. Now, again, very important concept, and all the time we are coming and seeing this host pool. What's the meaning of host pool? Remember, when you are doing the site design, so what you are doing, that you are going and in hierarchy you are doing some sort of site design. Now, if you assign one IP pool here, say 10.0.0.0/8, and then for one site you can assign say for example 13, one site maybe you can assign 24, and one site you may assign 26, like that. The IP addresses in hierarchy with respect to the site, global site, and the subsequent sites you can go and assign. And that's the whole thing about this host pool. So host pool is there to provide the basic IP functionality or the reachability. Each node uses SVIs with IP address and mask as per the host pool. Fabric uses dynamic EID to advertise each host. We know that whenever they are learning anything, they are sending that information to the control plane. Then the Fabric EID allows host-specific MAC address advertisement and mobility. Remember, again, I'm telling you that if you go and compare this with Uh, say for example ACI, this time I'll compare with ACI. Last time we have done the comparison with SD-WAN because ACI little bit close to this type of thing. So we know that we have a spine and leaf structure, correct? Now you know this thing that a spine, whenever they are connected with any device, they are learning the endpoint information, and then they are using some sort of COOP hash mechanism to send that entry to the spine, and a spine is building the complete database, correct? Same as here you can see they are learning the endpoint information, and they have some endpoint information, say in terms of /32 or 128 in case of IPv6. Once they are learning this, then with help of Lisp, and inside Lisp again, when we are going to discuss detail about Lisp, you will find that there are two type of ID. There are much more things inside Lisp. So with help of Lisp, they will go and register that entry inside this database. And again, you may have uh, multiple control planes, and they will go and sync as well. Again, it depends that how big the infra is. So in short, that they will go and register here, and then he has to maintain the entry. Now again, if the users are talking from one location to other location, they are inside the VN. We have put some sort of SG ACLs. Inside SG ACL, we have some sort of access permissions. So according to that, so you can see how much security we can put. First of all, this is independent of address. ACI is also independent of address. User can move anywhere to anywhere. So if user will move from anywhere to anywhere, then what will happen? This switch will learn, oh, this is the new entry I have. He will tell to the control plane. Control plane will delete the old entry and then relearn the new entry, correct? The same thing is happening in ACI as well. Sometimes it is referred as a spine proxy, L2 or L3 spine proxy in ACI, correct? But inside ACI also, the leaf switch, they have the loopback addresses, and they are termed as a VTEP, correct? Virtual tunnel endpoint. Here also you can see the host specific entry is /32/128, but you are getting from where? You are getting from the host pool that you have to create while you're designing the site, or even while you are doing the host onboarding as well. That will be used. So host pool can be assigned dynamically via the host authentication and statically per pool. Great. So we have the dynamic and we have the static method to assign it. Finally, we know this concept that this is using stretch subnet by default as well. So any user, they are reserving their IP address, So if the user will move from one place to other place, is still they have the same IP, because we are using one concept here called anycast gateway. So you move from anywhere to anywhere, that doesn't matter anything, because anyways the new location that plane is learning. So once you move from one location to other location, control plane with help of Lisp and some internal mechanism, they will learn the new location, and then they will rebuild their database. So we have the fast roaming here, we have complete host mobility, and that's why we don't need to even require to stretch the VLAN, because we are in the stretch subnet. Again, these terms are fancy terms: stretch subnet, host pool, and scalable group, virtual network. But virtual network is there in all the STNs. Scalable group is there inside ACI as well. Host pool, in case of wired and wireless onboarding, you need IP reachability, so you have the host pool here. That's the new thing. But a stretch subnet type of technology we have in other SDN solution as well. Finally, the Anycast gateway. As I told you already, that they have some sort of pervasive gateway, and this concept is true inside ACI as well. If you closer look inside BD and bridge domains, and inside the pervasive gateway, you will find that you may have multiple bridge domains specific to whatever application profile you have, or whatever EPGs you have. That's the more precisely. Now, for those EPs endpoint groups, they are independent of again the addresses, because how to communicate from one place to other place, that doesn't matter, because on top of all the EPGs you have a pervasive gateway. So if you even move from one location to other location, now again it depends that you are moving from complete one subnet to other subnet. Obviously you will move inside one big subnet or one big address range, but once you move, the spine will learn with the coop mechanism, and then they will update their database that this end system is at new location, but still we have the gateway defined. That's nothing but the pervasive gateway. That is nothing but any cast type of gateway. So you have one common IP, say 1110, and that is visible for all the devices inside 11110 range. You may have common gateway for 2220. That depends, that is valid or that is true for all the devices who are in the range of 22220. Correct? Finally, what about those devices who don't have IP addresses? Such as some old devices, such as some, there are a number of medical devices, there are a number of other type of devices who don't have IP addresses, so they can't do L3 communication. They are purely dependent upon layer 2 communication. So those devices, either they know only broadcast or multicast. Correct? So for those type of devices, we have the concept of layer 2 extension. What will happen, that those devices, they will multicast inside multicast, or maybe they will broadcast inside the broadcast. But the key concept here is that the communication is very much like VPLS technologies. VPLS is type of L2 multicast technology, where you have point to multi-point type of tunnel. Correct. So point to multi-point means one point has multiple reachability. That's very much like multicast. When you are doing the broadcast in a group, or you are doing the multicast in a group, that's the key concept. So for those type of devices who don't have the IP addresses, so those type of devices, they can still do the layer 2 extension, and they can do the communication. All right, and again in the lab section we are going to learn, understand more and more about all these terms. At least we'll understand all these terms in again we can discuss about layer 2 extension as well. At the moment I don't have any non-IP endpoint, but again I'll check later on if I can get those type of network where we have this non-IP endpoints as well. All right, so this is very much about what type of components we have inside the SD access, what type of technology we are using inside SD access. Very much, if we go and compare to ACI, you will find 80% match in terms of technology. If you compare with Cisco SD-WAN, you will find at least 30 to 40% match. Again, in terms of the way the things are arranged, the way the things are working. So what is different? You have wired and wireless, and then you have policy plane integration. Nowadays we can integrate DNA with SD-WAN and ACI as well. So the thing here is that overall the concept will be the same, but some of the endpoints will be different. Maybe we have the wireless network here which is not there in other technology. Wireless, when we are talking about wireless is using SDN solution from long back. Remember, in wireless these APs, they have to register to WLC, and WLC is nothing but just your management plane from where you are managing all the stuffs, all the data plane devices, correct? All right, so let's stop here, and next section we are going to do the lab related to discovering the devices. And next important topic we have to do the DNA Center first time installation and device discovery. Now earlier what we have done, that we have already designed or planned our site hierarchy, correct? Now next time what we want to do here is that I'll go and discover a few of the devices, say 3 of the devices. Now while we are discovering the devices, there are some consideration. In the lab also I will show you that what type of consideration you should do. But you should open these ports, say ping, SSH, SNMP, SNMP trap, syslog, netflow, HTTPS. If you have firewall in between your DNA and in between that devices you want to discover, correct? Great. Again, you will see in the lab section that what type of methodology you have. But one very important key here is that in your DNA, while you're going and starting or creating the discovery, so in your DNA, that DNA center or your tool, it should go and contact to the device. Obviously, he want to configure, he want to discover. Now, in that regard, there are different ways. So what the DNA is going to do, that either it will go and SSH to the device and even it can SSH and write as well, or it can go and do the telnet is not a recommended way. So at least you have the SSH, or maybe you have the netconf, or maybe you have the SNMP method to reach to the device and do the read write, correct? So that's a very important key here during the discovery process. Now how you are going to do, you can see that you have the tools, and I'll show you inside the new DNA system. You can go to the tools again, the same place, and you can go to the discovery. Once you are inside the discovery, you can go and write the name of the discovery, and then we have option that we can go the IP range, or we can use some sort of other mechanism like CDP, etc. So what we are going to do, that we are going to discover 3 devices, and once we discover those devices, then I will go obviously and I'll show you all those steps related to that. Let me quickly erase all these pointers. Let me go and go to the next page if I can go. Yep. So here you can see that I can go and give the name of the discovery. I can use CDP, range of the IP, or LLDP. I will show you in the next section how you can do that. And once you do this, then you can press the button in the bottom here. You can see the start button. Once you press that start button, then it will go and discover the devices, and this is the key I want to highlight here. So let me quickly highlight this portion, that we are using SNMP, CLI, HTTPS, netconf, etc. We're going to do all the methods listed here. I'll show you all those things. So what is happening, that DNAC is pinging, then it is using the CLI method, CLI maybe SSH or telnet, and then it is discovering the device. Now once you discover the device, then you can go and assign those devices. So you can go to the inventory, and then you can assign those devices to certain site. Now once you assign that devices to certain site, you will see that last sync, manage. You can see the site status as well. So very much this type of page you will see once you discover and assign the devices to the site. So let me quickly log into the DNAC server. Here I am. Here you can see my DNAC server. Now here you can see that I have site 5, but I don't have any network devices. I don't have any other thing because this is a fresh new system. If I scroll down, you can see I have the discovery inside the tools, or you can go to the menu and you can go to the tools. You will get the discovery. add the discovery. I can go and click add the discovery, and then I can give the name. So router and switches. IP range. Since I know the IP range of those devices, even the CDP is also enabled to those devices, I can use CDP as well. And then I can scroll and I should give the credentials, correct? But let me use the IP addresses because most of the places people are using IP addresses and ranges. So let me quickly give you write the IP here, all these management IPs. And suppose if you have only one IP, so obviously you can use in the from and in the to as well. So what you can do here, that if you have only one IP, you can give the range like this, click plus sign, so you'll get the new um, area or new field, and then you can go and give the other IPs as well. 23, and that is from 23 to 24. Now these four devices, 198.168.128.23, 24, and this 145, I want to discover, but before doing the discovery, you can see that you should go and give the credentials. So I can go here and I can give the credential, say device access. Again, very important, super important point, that the devices you are discovering, those devices should have SSH enabled, and they should have such type of username and password also. Save this as a global setting, yes. Okay. And admin as a recommended username and password is not recommended from Cisco. So you should not use admin because that's the default that is coming with Cisco mostly. You should use some very highly secure username and password, etc. Or you should follow some sort of secure standard. Alright, so here you can see that I am giving the CLI information. I'm giving the SNMP read and write information. Version 3, SNMP HTTPS netconf. Netconf is port number, I need to check, maybe 830, and save this. Great. So once we have these, here you can see these these areas, they are now blue with some sort of pink background or this pink type of border. All right. So now you can go and press the discover button. Yes, you want to discover now. Yes, I want to discover now. Now if I scroll a little bit down here, oops, if I can get to that place, the same place I should go to the advanced as well. But anyways, the discovery is in progress. Here you can see in progress, and again you can see here the logs as well, the detail about all those information. What I want to highlight here is the protocol order is SSH, correct? So that means the DNAC is using SSH to do contact to those devices. So it will go and SSH to those devices. Maybe it will take some information and come back. Great. So here you can see that is still in progress. Here you have the counter that success is 0. We should get some success messages there. And finally here in the bottom you can see that you have the stop button as well. Now what I'm going to do, in between you can see I have one success message. So let me check that which device. Here you can see the ISR device has been successfully discovered, and what methods it has. So it has the ICMP, SNMP, CLI and netconf. All those methods is green and checked. So that means these information, these things have been configured or must be enabled there in the device as well. So that means in this ISR device, the netconf is enabled. Now it is contacting the rest of the devices. So let me quickly pause this. Let me pause this section here and wait for a few seconds. Once the device will fully get discovered, I'll come back and I'll continue my recording from there. It took 30 to 40 more seconds, and you can see that clearly it is telling that two of the devices are unreachable. Maybe the IP address that I have given was wrong, or maybe those devices are down. So what it is telling is simply that SNMP method not working and the netconf is also not working. Those two devices are unreachable. So what we can do here, that we can go and run this discovery one more time. Okay, so let me quickly, even in the bottom you can see you have the rediscover button as well. You can do the rediscover one more time. Again, let me pause the recording. It is rediscovering is queued actually, here you can see. Okay, all right, let me click here. So only one device got discovered. Now what I'll do quickly, that I'll go here and use this discovery name as a switch, and I'll use other method CDP and then discover it. Okay, let me give the IP to IP because we have two switches, 23 and let me give the range of the address because I'm not able to give the range. Great, so let me quickly give 23 and 24, discover it, start. So here you can see on the top that if I go and click, we have one successful discovery, that's in the bottom router switch. Now we have other discovery is in progress. So once you do discover these devices, on top you can see the DNS server, it is telling that now what you can do next. You can go next to view inventory and then you can assign those devices to that site. Correct? In last section that I have initiated the discovery process and we've seen that it was failing. So what I have done, simply I logged into the device, and from that device I simply pinged to the IP addresses of the DNAC server, and then I reran that particular discovery process one more time. So here you can see that it is successfully discovered one of the switch. Still one of the switch discovery is in progress. Correct? And the methods you can see here is the SNMP, CLI, and netconf is not enabled. So once your discovery process will happen, here on top you can see that you can go to the view inventory, and here you can see that you have two unassigned devices. One is that in last discovery process we have discovered. Other one is we have discovered now, and you can see the MAC addresses, and good thing that the DNAC server automatically try to figure out that what is the device role of these particular devices. So one can work as a border router and rest of the switches can work as a access devices. So now what we can do, that we can select these devices and then we can assign the site. So here you can see that if I go to this particular device, that is 4451, I can click assign, and then we have this option to choose the site, I can go and click to this drop down menu. I can assign to this particular location. Yes. And here you can see the information. Click assign. And likewise, I can go to the other device. Let me scroll a little bit here. I can see 23 is also there, which is unknown. Reachability is unknown, but leave that this point of time. I'll go to the other switch. And this also I can go and assign here. Go next. Finish this. So now if I go to the label, that's the USA. Inside the USA, you can see that I have these devices assigned, and if you go and click to the topology, so very much you will see the diagram here that you have your device here. Let me go and go to this particular building, and here you can see the diagram. So this is the way we can discover the devices, and then once you discover the device, then you can go and assign the site, correct? Which particular site this device belong to. Now let me quickly show you this from this new GUI, that you are inside the provisioning and the inventory, and then you have assigned the site, correct? And again, later on we will focus on more about all these options that you are seeing here. When I can go to the design one more time, and I want to show you the network hierarchy. So once you are here, and if you go to that particular building and that particular floor, once I'm in this floor, you have one option here, edit. Now if you click edit, and suppose in that particular floor you have the access point, we can go and assign the access point as well, like this, correct? So I'm showing you both the option, both the ways that you can go and add the device. So one way, then once you discovery, you can go to the provisioning and the inventory, you can assign the site. That's the one thing. And if you want to assign some of the APs, so you can go to that particular region, that particular area, that particular building and the floor. And then on top you have this edit section where you can add the access point. Same thing I'll show you in the slides as well. So that's why I'm showing you here first, and then I'll show you in the slides. Now let me quickly go back to the policy. Once you are inside the, sorry, not the policy, let's go back to the design. So once you are inside the design, then you have the network setting. Now all these settings that you are seeing here, I want this message to come again and again, because this message is simply telling that the DNAC has the inheritance property. So if something is applicable to the global, so if you made something, some configuration to the global, it will inherit to all the childs or all the sub labels below that global. So suppose if you go and define the global configuration here, and then it will be inherited to everyone until unless you go and override. So you can go to certain site labels as well, and then you can define these values there also, because again it depends that certain site is using different AAA, a certain site having different DHCP servers and all, correct? Device credential we have already defined, and at this label if you want to use these, so you have to check it, correct? And then you have the IP address pool. Again, you will learn more and more about these things later on, and some of the stuffs related to wireless and telemetry. Great. So this is the way. The whole idea point here is to understand the discovery process. So this is the way that you can discover the devices. Once you discover the devices, then you can go to the inventory, and then from the inventory you can go and assign the sites. So how many reachable devices we have? Here you can see that one router once is still one of the devices not reachable. Maybe I don't have the route, maybe I don't have uh, the SSH configured in that particular device that the DNAC want to log in and he is not able to log in. Correct? So one is unknown, and here you can see the device name. Now the device is reachable, but somehow uh, my DNS server is not able to get more information about the device. Correct? So maybe sometimes you'll get such type of issues as well. Let me quickly jump to the slides. So in the slide, I just wanted to show you that once you discover the devices, then you can go, and those devices you can go to the provisioning devices and the inventory, and then you can assign those devices to the sites. Correct? Assign devices to the site. Once you assign it, then again you can see here this single status managed, and you can see the devices, and those devices are mapped with the site. So what happens when a device is added to the DNAC? The DNAC will do the inventory collection. DNAC will configure push to the device. So whatever configurations, AAA configuration, DHCP configuration, SNMP configuration, those things from DNAC it will push to that device, and they will establish a streaming telemetry over secure connection. So here in the diagram you will see few of the things. Clearly you can see in the diagram that DNAC is downloading. So these devices, this WLC is downloading the cert from the DNAC. DNAC is pushing the WSA configuration, and in between the DNAC to the WLC, DNAC is using REST API to do the communication with the WLC. Correct? Likewise, you can go and check the switches as well. So in case of switch, the switch they are downloading the PKI, IPDT, HTTP server, SNMP configuration from the DNAC. Then you can see here that SNMP poll and CLI telemetry collection is happening. And then the communication in between the switch and the DNAC is happening with syslog and SNMP trap. The last thing here, I told you that you can go to that particular selected site and the floor. Once you click the floor, you have the option to click edit. Once you click edit, then you can go and add the access point. The same thing I have shown you here. About the assurance, we are going to discuss more and more in the assurance section. So I have complete section for assurance where we are going to learn about the assurance feature that we have inside the DNA. All right, so let's stop here. Now we know the fundamentals of DNA fabric, what are the key components and terminologies inside the DNA center. I'm going to explain you about the workflow. So here you can see that we have primarily 4 different type of tasks or areas that we should focus. We have design section, we have policy, provisioning, and assurance. And one by one, all these workflow that we are seeing here, we are going to discuss more and more because that's the key we have inside the DNA center. So what are the stuffs we have inside the design, what we can achieve with policy section, the provisioning, as the name suggests that this is the provisioning section. From here you can provision the devices, and then the assurance. So your telemetry, your visibility, troubleshooting, all those things will come inside the assurance. Correct? So now starting with design, and one by one again we'll go and check all these options. Even I will log into the DNAC center, and I will show you that where you find all these options, and once you go inside any of the workflow, then inside that what are the things you can achieve. Now suppose if we are going inside design section, so you can go and change the global network settings, site profiles, DDI swim, that's the image management, plug and play option, and user access. So what are the things we can do? We know that a big enterprise network, they may have offices across the globe. You can go and define the global option. So what's the country? Inside that country, what's the state or region? Inside that, what's the sub-region? Inside that, what's the area? What's the building? What's the floor? Like that you can define. So you can define the site, building, area. Inside area, what's the area and building and floor? Because obviously inside the floor you're going to provision your APE as well, and maybe you have the floor map. Good thing about the DNAC is that with running prime infrastructure 3.x, you can import all those floor plan and export from the prime and import here inside the DNAC. So what are the options here? Again, I'll go and log into the DNAC GUI and I'll show you that you can go to design. Once you're inside the design, you can check the network hierarchy, network design. Then you can see that image management and network profile. So these four options we have, and plus we have the authentication profile as well. What I will do that in next recording, I will log in inside the DNAC and I'll go and highlight all these areas that it's actually the font is very small. You can't see that, but here you have the network hierarchy. You have the network hierarchy. Then you have the network settings where you can go and uh, add your DHCP, AAA, SNMP, and all those types of global network related configuration. Then you have image management, and finally you have the network profile, but you have one more, that is the authentication profile as well. So these many design options we have once we are inside the design section, and one by one we can go and um, create the things inside that. So suppose if I'm inside the network hierarchy, I can go from first level global, and we have seen this thing in our previous sections videos, that how you can go and create the site and then the area and then the building and then the floor, etc. Correct? And once you are in the floor, obviously you can go and add the APs as well. So once you are done with the site hierarchy, that's nothing but the network hierarchy, then you can go and check the settings related to network settings. What type of things you have? You have the collector information, AAA, NTP, and DNS, DHCP, and then the password management. How you can do it? It's very easy. You can go click and you'll get all the GUI options. Only important thing here is that you may have multiple labels. So suppose you have one main label and then you have the sub labels, and this is something that they have the inheritance property. So that means if you define the access at the level of global, then that will be inherited until unless you go to that particular label and change those configuration. Correct? So there may be chances that different region they have different ISE, or maybe group of regions they are pointed towards different IC server, like that. So those changes we can go down to the hierarchy and do it. Correct? Then here you can see again is less visible, but what I will do, I'll go and log into the DNAC in the next section and I'll show you all these options. So you can go to the network setting. Inside that you have the network option, then device onboarding, then IP address pools, wireless, and SP profiles. Correct? We'll see that in upcoming sections. Now next what you have the design map. Now these design map we can import from the prime, and we can actually export from prime and import in the DNAC. Again you can see this site floor mapping and all. Again this I will show you in the next recording, and on top you can see that you can edit a little bit. So your visual representation you can edit, you can change the color, etc. Correct. So once we have the floor planning, then finally you will see that other options inside this. You have the network, you have the device onboarding, then you have the IP address pools and wireless NSP pools. So let me quickly go to the IP address pool. We have two options. Either we can use embedded IPAM management, IP address management, or we can integrate with some third-party IP address management tools like Infoblox. We have the full integration possible with that. So once you go and integrate with Infoblox, for example, then all the directories and all those IP related schemas that you have inside Infoblox that will get imported inside the DNAC system, and from there you can manage all the IP addresses. Correct. So either it's a locally managed pool or imported from the Infoblox. And the end goal here is that you can have a bigger pool at the top level, and then you can go and assign different type of pools for different type of work. So for example, generic, LAN, management, service and WAN pools, we can go and assign. Again, we have the full integration with respect to REST APIs with the external IPAM management tools, correct? And again, if you are doing it locally, so you can go to the IP address management. Again, I'll log into the DNAC and I'll show you that how this GUI look like. But yeah, we can manage from there. Whatever addresses you will allocate, it will show you that how much percentage is free, how much is allocated, etc. So those informations you have. Obviously, from a bigger slice, if you want to allocate to the LAN management service, from that bigger pool, you will have a slice and then you can assign to different areas. Again, finally, it will look like this. So for LAN, you have /28, for management is 21. For services, you have 25. For internal use, we have 27. It depends that how we want to do and go and manage and assign these IP addresses. Finally, we have the software management as well. Now, what's the key here? At the moment you'll go and discover the device, DNAC is intelligent enough that it will sense that what image it is, and is that image having gold image, means the stable version from the Cisco. Suppose if you want to tag that gold image, I will show you that tagging as well. Again, in this green box, small yellow color, golden color highlight is there, but again, I'll show you in the next recording that you can go and tag it. Okay, this is the gold image, I am tagging it. Okay, so while you go and see different type of images related to that particular hardware, you know that, oh, this specific software is the golden image, correct? So that's the design workflow we have, and it's quite a big actually when you go and use it, because anyways we are going to use this as a GUI option, because everything we are doing by the GUI. So you'll find it easy once you are very much familiar with what option is going to do what, correct? And this design and policy, these are the two areas from where you are taking the input and then you are consuming inside the provisioning state. So that's very interesting that you have two options for the solution architect or the design engineers, and those two options, those two design consideration that you are taking in the design and the policy phase, you are putting inside the provisioning phase. So if everything is ready, you can go and provision the device, and that device will go and add up inside the fabric, correct? So let me stop here, and in the next section I will log into the DNAC and I'm going to show you all the design option that we have discussed here. Now let me walk you through the design workflow and design options. Here you can see that I have fully populated DNAC server. You can go here on the top, design, and then you can see that we have the network hierarchy, network settings, image repository, network profile, authentication template, correct? Now, once we are inside the design hierarchy, let me quickly walk you through that what options we have inside this. So obviously you go and define the site, And inside site, you can go and define the area. So you have multiple areas, area 1, 2, 3, or maybe area represented by the countries. Inside that, you may have city and small cities, etc. Correct. So in this region, you have this country, USA, and inside that, suppose if you go inside the California, so you can see the hierarchy. Starting from global, you can go inside multiple sections. So whatever business units you have in different geolocations, you can create here. And how we can create it, we know that you can go to this particular gearbox and then you can go and add it. Correct? Great. Now again, I can go here to the one of the location, either maybe San Francisco or San Jose, anywhere. And then if you go here again, you can go to the building, and if you go and click to the floor, now this particular floor, you can see that it is so many APs are already deployed in this particular location. And we on the top, you have this view option. So if you go and click to the view option, then here you can go and change the settings as well. Correct? So whatever things you want to see, if you want to see the legacy heat map color, natural, you can uh, show the grids, etc. So those options we have, that we can go and filter, and then we can see like this. Then suppose if you want to add the AP, this already discussed earlier, that you can go and add the access point, and then again you can play around with different knobs, that different options we have here. Correct? So this is the network hierarchy. Once you are done with the network hierarchy, you can go to the network settings, and inside the network, again you can see that this particular building, I have these network configuration option. Correct? And again on top you have the design option. Inside design, we are inside the network settings. Inside network settings, we are inside the network. So inside network setting, we have the network, device credential, IP address pools, QoS, and wireless. These many settings we have. Correct? Now, what about the inheritance property? So here you can see that there may be chance that this configuration is coming from the global configuration. So if I go and click here, now if this global configuration, if you go and save this as a global configuration, if this is true for all the regions, that's well and good. Otherwise, you can go here and then you can choose your own options as well. So maybe the IC server here in San Jose pointed towards different location than somewhere in the Asia or in the Europe location. So those things we can go and change as well. Okay, and here you can see that you have the add server as well. So if you have additional information, additional server information, you can go and add as well. So you can see all these very important configuration, and most of uh, the the configuration that you are seeing here via the GUI, they are common. So triple A configuration, the DHCP, DNS, syslog, SNMP, NTP, even the time zone. These are very common configuration globally, at least to those routers sitting in that particular region. Correct? So maybe in San Jose, I have 200 devices. They have same type of these global configuration. In Cisco terms, we are telling it as a global configuration because in the config mode, we are giving this configuration via the CLI. Then you can go and check the device credentials. It's not recommended that you use Cisco or admin type of username password, but in lab environment, it's okay. Then we can go and check the IP address pool. Now inside IP address pool, at the moment it is telling that this particular location IP address pool is not there. But if I go to the upper label, that's the San Jose label, and here also I don't have any IP address pool. So let me go one label up to the California label. Here also we are not seeing this. Let me go to the global directly. Now in global label, I have this IP address pool that I don't have in a particular site or region level. So that's okay. You can have a bigger slice at the level at the higher level, and then to the sub label you can go and use the smaller pool addresses. So maybe /8 you have at the top level of your IPAM, and then you can use /16 or 23, 24, etc., etc., as per needed inside the fabric. Correct? And that's why you can see that we have 44 pools, and then it is defined like this: AP pool, border, infra, etc., etc. Correct? So that's the address pools we have. Then we have the QoS setting. Uh, Here you can see that we can have the VZ profile, BT, OBS profile, etc., etc. And finally, we have this wireless configuration. Now, uh, about this wireless deployment and configuration, again, we are going to discuss later on more and more. So we'll check about this. So here you can see that first of all, you have the network hierarchy, then you have network settings. Inside network setting, you have these many options. Then you can go and check the image repository, because for the operational engineers, it's very required that they should manage the image across the enterprise infra or the IT infra. And there may be thousands of devices there they want to manage the gold image, the stable release. Now here you can see that I have a 9300 switch, and I have 18 such type of switch. Let me show you the different type of images, and they are running these type of images, but out of these images 16.12 is tagged as a golden image. So you can tag your golden image, and you want that this golden image should be running to all same type of hardware, correct? So we have this marking capability. We can go and tag the golden image as the golden color. Then we can have the network profiles. You may create the profile for router, wired and wireless, etc. And then finally the authentication template, where you have the options like open authentications. If you have the device, if you have non-IP type of devices like sensors, or maybe those type of devices used in medical areas where they don't have the IP addresses, etc. So what you want some sort of open authentication. If you have any closed authentication, you can create the template like that. If you have any low impact, you can create the template like that. But very much this particular profile, particular workflow, or this particular option inside the DNAC is related to network design engineers. So they have to design about the global network setting, the site hierarchy, the overall framework, what's the IP pool, what's the image they want, etc., etc. Correct. So let's just stop here. That was the walkthrough related to design workflow and what options we have inside the design area inside the DNAC. Second workflow, we have policy in software defined access, SDA. Now this is actually big, and Cisco has tried to make this simple, or SDA access has tried to make this simple, but although the overall concept you'll find is quite a big, because underlying your IT infrastructure, your enterprise network, you are going to provide this security, and that security, again, you will see that there are multiple level of security. So one level of security we have called macro level, where you have virtual network, or you can say that you have a different type of VRF. We know that once we have different type of VRFs, they are not doing communication to each other by default. Obviously you have to leak the route in between that. Now very much similar type ACI, where you have endpoint group and two different type of EPGs or endpoint group, you need contract in between them to do the communication. That concept is very much called whitelisting model or zero trust model. Means you are not trusting anyone, and if you want to do the communication, you have to create the contract. You have to create some sort of permission in between that. Now in SD access, that is inbuilt. So once we have the fabric, and once we have multiple level of VRF, where you can see that we have the VRF related to building management and campus user VN. By default, they will not do the communication. You need
some sort of permission or contract in between them. Now this is macro level. What about within campus user VN or within building management system? That will fall under micro level. So within, say here you can see that you have campus user VN, inside that you have finance user and employee. In between them, if you want certain permissions, then you can go and create the contact. And that's the power we have with the SD access. Correct. So these things and these labs you will see in the next section, where I will go and create the virtual network or the VN, and then different groups that has been important. Now what's the next big thing we have? Let me quickly show you here. The next big thing we have is the integration with IC. Correct. So not only that you have a virtual network or you have the VRF, and if you have different VRF 1 2 3 etc., they need some sort of route linking in between them, and you need permission in case of micro level communication or micro level policy as well. Now the power we have in the SD access is that once we do the integration with the IC, then all the groups inside the IC will come inside DNAC. And with help of DNAC and with help of uh, policy framework that we are discussing, this is the policy workflow, you have the groups. So here you can see that you have the groups. You have imported the group from the IC, and then you can create the access rule. So you have different type of rules that you can create. Once we log into the DNAC in the lab section, that's the next section, you will understand more about what type of permission, access level, VN type, etc. we can create it. This is the dashboard. This is the snapshot from the ISE. We know that you have to create the authentication, and then you can go and create the authorization policy, correct? And here you can see that you have the scalable groups. So as per the permission label that you have, you can go and create the rules inside your DNAC, and those rules, those metrics you can see inside the TrustSec scalable group. So here you can see that if you go and check the SG ACL inside the IC, you will see all those permission that although you're creating from the DNAC. So from the DNAC, from the policy administration, group based ACLs or based access control we are creating, and then we can see these things inside the IC. Let me quickly remind you one thing, that you have the DNAC, you have done the integration of DNAC and ISE, and you know that ISE is sending their information with help of Pixie grid that we have enabled, and then DNAC is sending the instruction with help of ERS or RESTful API or REST. So that's the communication channel, and that's the communication or the way that they are communicating in between ISE and the DNAC. Now again, this is the logical representation that you have virtual networking, you have a scalable group, user and devices, they are part of a scalable group, or users are obviously the group, or they can group inside different categories, correct? Again, you will see that in the lab section that will make much more clear about these concepts. And then you have the virtual network, and then you can go to the DNAC, and very easily with few clicks you can go and create the rules and policy. Finally, the same thing again you can see in the different type of diagram, different type of logical diagram. So you have IC, and then you have the DNAC. From IC you have the endpoint profiling, you have the authentication authorization, then you have the group and policy. With help of Pixie grid, all these information related to groups, they are coming inside the DNAC. Inside DNAC policy workflow, you can go and create the policy, and then you can apply it, and then it will go and push that policy with the RESTful API inside the ISE. Right, so that's actually the workflow we have. Again, we are going to discuss about the virtual network. I have given one slide related to virtual network. By default, there will be two type of virtual network. One is the default VN. So if you do not create anything,
everything fall inside the default VN, and one VN is there for the access point. So by default, you will find that inside your DNAC, you have two virtual network. One is for AP management and one is that's the default VN. Cisco is giving one for all the customers, but you can go on top of that and you can create the user VNs or VRF as well. And inside user VN or VRF, you can go and put whatever groups you have. Now in this lab, I'm going to show you that how you can go and create the user defined VN and then how you can go and put the groups inside that. It's very easy. You can go and use the policy workflow for that, and then you can go and create the group based policies. Correct. So when I log into the DNAC, I'll show you that where you can go and check whatever there by default and how you can create your own defined VN. So this is the page here. You can see this is the same page you'll find inside the DNAC. If you have the groups that is imported from the ISE, you can go and create your new type of VN, and then you can simply drag and drop these groups. So you'll find that suppose if you have 10 group here, if you drag and drop 3, so in the default VN remaining will be 7, and inside the new VN you will find that 3 groups. Now with those 3 new groups that you have drag and dropped inside the new VN, you can go and create the rule. Correct. So in the lab, in the next section, I'm going to show you the lab related to intent-based security for IoT. And inside that, I'm going to show you the micro level policy. And we'll see that we'll go and create one VN and then we'll move some groups, some non-authenticated groups related to no auth devices or related to some IoT devices. Again, we have to learn. So upcoming sections after the lab, we'll go and learn about what type of authentication methods we have. I have few slides related to that discussing that we have no auth or auth with 8021x or auth open, etc. Those things we are going to discuss in the upcoming section, but at this point of time I want to perform one lab, so we'll get much more familiarity about what are the options, what are the tabs we have, and how we can go and create the group and the policy, etc. So let's start one lab related to VN and the VN and obviously the policy. And next section again we'll go and continue with the theory. Let us perform the lab task. Now what we are going to do here, that in one of the site, one of the location, we have some IoT devices. Those devices we want to create virtual network, and we want to do actually the host onboarding. Again, the theory will come in upcoming sections, but you'll understand that while doing the host onboarding, what type of workflow we have to go. But more or less, we are going to create policy. I will go to the policy workflow and I'll show you that what are the options we have, how we can create the policies, and then inside the fabric, inside the host onboarding to that particular device, to those particular interfaces, how you can go and apply it. Now, most of the times what you want that whenever I am onboarding my host, those authentication and all those security stuffs should happen dynamically, but sometimes there are chances that the devices are not intelligent enough. Maybe in ISE we don't have profile created for those devices and we want some sort of manual or static authentication. So the DNAC is going to give you both the flexibility that you can go and do the dynamic. So most of the time you want to do the dynamic authentication uh, at least at the port basis. And then those devices who can't do the dynamic authentication, then for those devices we can go and do the static or the manual authentication as well. Correct. So let me show you all the steps. Let me walk you through step by step and slowly about this workflow. So first of all, log into your DNAC, go to the policy, Once you are inside the policy, you can see that you can create the group-based ACLs or access control. Then you have the IP-based access control. Then we have the application policies. We can create the traffic copy policy as well. And here you can see you have the virtual network. Now, once we are inside the policy and the group-based access control, here you can see that we have the list. Now here I want to show you groups as well, and you have the scalable groups. You can see we have the groups imported obviously from the ISE because we have the ISE and the DNAC integration in the back. We have seen this thing. But if you go and check the virtual network here, you'll find that everything is belonging to default VN. Remember, I told you that you have two by default. One is default VN and other one is infra VN for AP onboarding, etc. So let me go and refresh this. So you can see it is still connecting and getting the information. So here you can see that you have the default VN having 52 groups, and infra VN I don't have anything at this point of time. Let me go back to the group-based tackles, and the same thing you can see here as well. So here you have the name of these tags, say employee, guest, HVAC, etc., and then associated policies. And then here you can see that they are belonging to default VN, correct? Now suppose if you want to create new virtual network, you can go here and you can click this plus sign, and then you can create, say, no auth policy. You can give any logical name, and here you can see that you have these available groups. You can move these groups obviously. So let me go and select say batch readers, and then no auth type of group, say HVAC, and then I can go and check this no auth group. So three groups I have moved, and then I can click save here. Now you can see that in 52, now it become 49, and in no auth policy group VN, that's the name of the VN, I have 3. Correct. Now again I can go back to the scalable groups, and here you can see that no auth. So these things has been moved here, correct? Great. So what we want here now, that we want to create the policy. So for that you can go and you can click to the policies. Once you are in the policy, clearly you can see that for BUID you have the permission from BUID, permit IP, that's why it's green, to the deployment server. This is nothing but the metrics. Now what we want, that we want to create our own policy. So I can go here and click to the create policies, for example destination to source, and then it will ask me, okay, what's your destination, select it. So my destination is, at this moment I want to filter as well, is HVAC. Oops, I have to give the full name, otherwise it will not take it. Otherwise you can scroll down and you can select as well. So here you can see that I can go and check the destination is this guy here, and I want to select HVAC, so let me scroll. HVAC, this is my destination. And then what is your source? So if you go and click next, and on top you can see the workflow. So I have selected the destination, then I can go and select the source. So my source I can go and take two. One I want to take as a So here, let me show you this no auth devices, and other I want to take as a batch reader. If I can see here, so I'm not able to see this. Let me scroll down. Yeah, batch reader. Both are there. So now I have the destination. Now I have the source. I can go next to create the permission label. I have this permit, IP permit deny, etc. But if you want to create your own, you can go and create it. What's the action? Permit or deny? I want to deny. What's the application? Now here you can go and select the application, and then you can go and give the transport protocol, then you can go and give the destination and etc. But what I can do here, that obviously if you have some use cases you can use that method, but I have inbuilt deny IP. Anyways, if I want to deny, I can deny everything from the destination to the source, correct? And that's it. So this way we have created one of the rule that's for deny, and here you can see. So HVAC, deny IP, cameras, this is not that we have created. Let me quickly go scroll batch readers here, and HVAC, no auth and HVAC, correct? Now I want to create one more, and this time again destination to source, and my destination is last time my destination was HVAC, and this time I'll go and make destination as no auth, just to show you that how easily actually you can go and create these policies. Very easy. Simply go select it, put the contract, and it will work, correct? So this one and the no auth devices, or maybe batch reader, no auth devices is already there. I'm looking for batch reader. If you have long list of group, then again you have to go and you can do the filter as well, so no problem on that. Next, here also I want to deny, next, and next. So now we have created the policy inside the policy matrix. That doesn't mean that this is applicable, because we need to go and deploy this. Now to deploy this, I already told you that you can go to the provisioning, and inside provisioning, let me go to that particular site where I want to deploy this policy. So I can go to the location, and I can go to this site. First of all, I need to find where is my IoT devices, and here you can see that I have the IoT devices. I can quickly find out with the topology diagram. You have two options here, list of devices and topology diagram. It is generating the topology diagram. The other option we have, that we have the filter mechanism as well on the top actually. So here also you can go and find the hierarchy. The moment it seems a little bit slow, so it is not generating the topology diagram. Let me refresh the page. I have refreshed the page here, and I want to show you the devices. So here you can see that I have the device IE3400, and here you can see the complete picture as well. So where is the other devices and the edge devices? All right, so what I want to do here is that I want to do the host onboarding with respect to this particular device. So let me quickly show you that how you can do the provisioning. You can go to the fabric. Once you're inside the fabric, we have one fabric where you have 8 sites, 29 fabric devices, etc. You can go inside that, and we are looking for the building number 6. Okay, so I can go inside this SJC06, and inside this is the device actually, and for this particular device I want to do the onboarding. So here you can go and click the host onboarding. Then here comes the authentication template, and this is actually the key. Now, if you have the legacy devices where uh, for you it's very difficult to do the authentication, then you can go and do the manual authentication method, the static authentication method. So here you can see that we have these four methods. Open authentication is a moderately secure based on 802.1x. So you have open authentication, you have closed authentication. Obviously, close will be much more tighter than the open, and it's the most secure because this is something that you are doing 802.1x authentication. If authentication is fail, there is no open session. There fail means the session will get disconnected or you will not get the access. But if you are in the low impact where you have the AD based authentication, or maybe if you are in the open authentication method, there is still some sort of access will be granted. And if we are in the no authentication, that means we are not doing any authentication. Again, you can argue that why we are using no authentication. No authentication we may use at the time of migration or at the time of first time or day zero deployment, where we want everything is open, everything is working, and after that we can go to more granular security, so we can go to the no authentication to the close authentication. Other use cases, maybe you have devices who doesn't support 802.1x authentication. So for those devices also we can go and do this. Let me save this. So my first section is done. Now we'll go to the virtual networking, and here you can let us continue where we left off in the last section. Now here I can go to the no auth pool, and here you can see that we have the address pool option, authentication policy, traffic type, layer 2 flooding, etc. There's nothing, so I can go and click add. The address pool for this particular authentication that we are going to use is 192.168.45.0 no auth pool. That's the name of the address pool is inside things pool, and this is the authentication policy, correct? Now the scalable group is no auth devices and traffic is data. We can flood the layer 2, click add. So now we have the VN created for that with the IP address, because whenever you are doing the uh, host onboarding, you have to assign the IP pool from the main pool. So now you can see this is blue. That means this is successful. Now next, at this point of time, we don't have the wireless SSID assignment, so we can leave it. Next, we have this port assignment. So I can go to the port assignment, and in this demo purpose, we want to use 1/4. So if I go and click, because anyways we want to do the manual assignment of the port. Now once you go here and click, you can see that 1/4 what type of device you want to connect. I want to connect either IP phone or computer or laptop. This is the user devices. I can use it. Now you can see that because since we are doing the manual or the static assignment, so what is the address pool? The address pool, it is coming no auth pool. The scalable group, I want to use, say here I want to connect HVAC, so I can use HVAC. Then the address pool for voice, we can leave it. The authentication type is no authentication, correct? I can click update. Remember last time I told you that most of the things will get dynamically. So the authentication process here is dynamic, but there are chances that there are devices where you want to do the manual assignment. So for those type of devices, you can go and assign everything statically, like I'm doing here. Click the save. You want to apply now, or if you want to do any scheduling, I want to apply now. and now it is getting applied to that particular interface, and here you can see the configuration as well. Correct. So we have saved it, and let me close this, and I can go back. So like that, you have the other devices as well, and if you have any assignment, you can go there and you can do the assignment. Let me go back to the provisioning and inventory, and we are at the same label. We have this particular device. This is the building floor that we have. I can go and open this device. So you'll see that assurance page will pop up, and let me scroll down. Here you can see the device, but we have done the configuration to one of the interface, that is 1/4. So if I can check, first of all, the interfaces, show a run, if I can show you, we have some restriction to run that command, and you can see that we can run, but we can run limited commands. So I can go and check the interface and interfaces. I'm looking for one of the interface, and if I can get that interface information. But once you have the super admin access, you can go and you can check most of the things from this particular CLI as well. Okay, so this is the way that we can go and create the policy. We can do the host onboarding like that, but it's still in upcoming section we are going to learn and understand more and more theory, and again I'll come back one more time to these locations, so it will be 100% understandable for you that how we can go and do the stuffs. Remember, we have this design and this policy. So whatever you are doing inside the design phase and the policy phase, those things will become the input for the provisioning. So while you do the provisioning, already you have done the designing for your hierarchy, network hierarchy, system, image, etc., etc. And then you have your policy in hand. So those you want to add connect inside the provisioning, and if you want to do the monitoring, troubleshooting, and all those other stuffs related to operational monitoring, so you can go to the assurance. Okay, all right, so let's stop here. That conclude our theory and the lab. Coming two videos, I'm going to show you that what are the steps involved to do the device onboarding. Now the step number one is that you should discover the devices. So in my devices, I have some basic configuration, and those devices are able to reach to the DNAC server. Inside my device, I have basic configuration related to IP reachability and SSH to the devices, means once I want to communicate with the DNAC, they will do SSH to the system and then they can do the configuration, correct? So that's the reason I want at least the SSH credentials to be working enabled. Now once my DNAC will discover the device, then I will go and add the devices to the respective site. Now once we'll go and add the device to the respective site, the next stage is to do the provisioning. Remember I told you that before doing the provisioning, you can plan your work, means you can have your design ready, you can have your policies ready, that what you want to implement. Means in my case, I have my ISE to the DNAC integration. Now the last thing that you want to do is provisioning that, correct? So for that, you can go and do the provisioning. So step number one here mentioned that provisioning fabric devices to the site profile. Now first of all, I'll go and create my own fabric. By default, there will be one default fabric, but I can go and give the name. Here you can see the university, but I will go and give test 01 or fabric 01 as a fabric name. Now once I have the fabric created like this, again it's very easy. I'll show you in the provisioning section. Just after the slide review, we'll go and perform the lab task. At this point of time, we know that what's the usability of the edge node, the border, and the control plane. So I will not redo the same thing, but edge nodes are someone who is going to provide the IP. So here you can see that IP Anycast gateway to all the uh, end hosts. So they have seamless mobility from one location to other location. In between that, they are running the VXLAN tunnel, so the communication will happen inside the VXLAN tunnel. And apart from that, they will do the authentication because the endpoints they are going to be connected to the edge node. These things we have discussed, correct? So now what will happen that once you have the fabric, so adding the fabric edge nodes, obviously you will go and add all the devices. So I'll go and add the edge node, the border, the control, etc. And again, this is just a few click. One thing I want to point out here that when you are adding the edge node, you have to simply use this option called add to fabric. But when you will go and add the control plane, so maybe somewhere you have the CP, or maybe you have CP plus border. So you can add the control plane, that's a standalone control plane, or you can go and add the border, that's the standalone border. But suppose if you have the collapsed control plane and the border, same device can work as both as well, correct? Again, the use of control plane, we know that is used as a host tracking database. At the moment, these endpoints, whenever these edge nodes actually, whenever they are learning any endpoint information or host information with help of Lisp protocol. So we have some terminologies inside Lisp, and in the Lisp section, we are going to learn deep about the Lisp terminologies and how it is working. But suppose if I don't know Lisp, still I can go and enable all those features, because it's not mandatory that you should know ISIS and their working, Lisp and their working, VXLAN and their working, but still you can go and deploy the fabric, because behind the scene the DNAC server is going to do all those things on behalf of us. Now again, if your device has dual role, both the control plane and the border, you can use like that. If not, then you can use either border or control. Okay. Now, what's the use of this border? We know that these border devices, they are doing the communication. So if you have the known network, means the traffic towards the data center, DC rather, so it's okay. All the Anycast gateway they can reach to here, and then again you have the routing going outside inside to the fabric. Or maybe if you're going to the internet, again we have one complete section related to how to route to the external network. So from the STA fabric, how we can go and route. We'll discuss those plus and minus those things there in the complete separate section. That's the communication to the external routers. Correct. But again, suppose if you have C and P together, and then you may have fusion router in between that, there you have enabled multiple VRF. So those VRFs will get mapped here inside your control and border router, and then underlying they will go and reach to certain VRF inside that, correct? So those things can be happen. The use of the border node, we know at this point of time that they are doing the communication within the organization or maybe outside the organization. Again, to enable it's very easy. The role you can go and assign as a border or control plane plus border net, and that's it. Now, once you assign it, so once you deploy the control border net, then you have deployed the edge as well. Now, suppose if these border nodes they have the connection to the outside world, correct, and you want to configure BGP inside that to do the communication. So at that time, when you go and deploy the border node, it will ask you that what's the BGPA's number. You can go and assign it, and that's it. Okay. So let me quickly log into the lab section and let me show you these steps one by one. All right, so we are inside the lab section, and let me show you that what we can do. So we have the devices that we have discovered. So I can go here to the tools and I can show you the discovery. Let me show you all those things one by one. So here you can see that I have one router and two switches. Again, I can go back to the design. And once I'm inside the design, I can show you the network hierarchy. These things already we have discussed. So what we need to do here, that whatever discovered devices that we have, I want to uh, assign those devices to the site, correct? So let me quickly go to the settings, and even I need some baseline settings as well. So I can go here to the global, because whatever configuration that we can do to the global, that can be inherited to those particular sites, correct? So let me quickly go and give all these information here. Let me give the DHCP server. So I have my DHCP server, their DNS, so domain name. So let me quickly give that domain name and then the IP. So here you can see that we have this information, plus I can go and add the servers. I want to add the AAA network IC, and then it will fetch that ISE information that we have already provided, correct? And this particular global setting, actually I can save it now. I am saving at the rate of global, but I can inherit this to the lower level as well, correct? Now what I want here, that I have discovered the devices, and those devices I want to do the provisioning. So I can go to the provisioning, and here I have the inventory. You can see that I have 3 unassigned devices that I want to assign to certain tasks, a certain site. I can click and I can go to the action. So you can select all these devices, and then you can go to the action, and then you can assign devices to the site and which particular site you want. They all belong to one site, and that is SAN 15, and I want to apply this to all the devices. Next, assign it, and here it is. So now you can see that devices, they got assigned to this particular label, and even you can go and check their topology as well. So now here you can see that I have my devices, and even you can see the connection as well. So 4451 is connected with 3850, and it is connected with 9300, and back-to-back connection also we have. Okay, so what's the next thing? Next thing, that we want to assign these devices as their specific role, correct? So I will go here again. Let me go and show you all the steps. I can go inside the provisioning, and once we are inside the provisioning, here you can see I can directly go to the fabric. I can create my own fabric as well. Although Cisco is giving you the default fabric and one of the default transit, but if you want, you can go and create your fabric. Let me quickly give the name, say test 01, and this fabric I want to belong to this particular location. By default, here you can see that we have these two default VN, but we know that how we can create the VNs as well, and then we can assign. So what we are doing basically here is that we are creating one fabric, and we are attaching with all the virtual network existing that we have. And here you can see that I have my test. That's a SAN 15. Now once we are here you can see that we are at the level of the fabric and then the fabric infrastructure. Now if you go here and click to that device, the device need to be provisioned to the site before roles can be assigned. So let's do the provisioning to the site. And you can see that in the bottom we have the deploy option. We can go and apply, means we can deploy it to that particular fabric. Now here you can see that fabric provisioning initiated, devices updated to fabric domain successfully. Now I can click here.
All right, so let's continue where we left off. What we want here, we want to do the provisioning. So let me go to the provisioning and the fabric. Once we are inside the fabric, we have created our fabric test 01, SAN 15, and you can see the devices. Now I'm going to show you how easy that you can go and select the device. Once you click there, then you have to choose the role. Now here you can see that you have option called details. So here you can see the details about this device, the inventory, the software image, provisioning, credential status not provisioned. All right, then you can go and check the fabric. What will be the role? So I want to assign the role as a control plane and the border. And once you assign the border, it will ask you that what's your local BGP ACE number, a transit or peer network. If you have the transit or peer network, then you can go and use this option. If not, then you can leave this. And then here you can see the help menu. Let me close this. So default to all the virtual network, do not import external route. That is checked by default. Now, how the fabric is going to do the routing, uh, we are going to discuss this later on. Obviously, uh, we have one separate discussion about the designing and placement of border and the control plane. So if you have the border node, and then if you are going to the known network or unknown network or internet, etc., what will be the use cases and what about the redundancy across the border devices? If we have the collapsed border plus control plane, then what will be the use cases, etc. So that again we can discuss in the separate discussion. What I'm going to do, that I'll go and create one new section where we can go and discuss about these things. So let's continue this here, and you can click add. Once you click add, then you can see that now this is ready to do the provisioning. Then you have this deploy option. You can go and click the deploy. You can schedule it or you can do the deployment now. Now you'll find that the color that you have, this will become blue, and still it is in the deployment state. Still behind the scene, the configuration push is happening. On the top, you can see the role is C and B, control and border, correct? So we can give him some time, and now we can see that um, the color look like this blue color. That means it has been deployed, and now we have this successful message in the bottom that it is telling that device has been deployed inside the fabric. We can check this. We can go back again here, and if you go to the details, provision status is success a few seconds ago, and other details as well, correct? You can go to the fabric. You can see the role. You can see here this border and then a border server as a gateway. Then you have this option called configure. You can see this configuration, and then let me go back, and here you have the details as well. So the border type is external. Again, we'll discuss about the type of borders in upcoming sections. And then you have the control plane.
If you have any port channel, in our case we don't have because we are using L3 boundary or L3 handoff, so it's not required. Then we can go and check the full configuration. Few of the configuration was there by default, and few of the configuration has been pushed from the DNAC server. So those configuration you can see here. Let me scroll a little bit down. You can see here that we have some of the configuration pushed. This SNMP full configuration and other configuration will be pushed from the DNA. The radius configuration obviously pushed from the DNA and some of the other configuration, correct? Then go and check the interface, who is the up and who is the down interfaces. Great. Let me close this. So once we provision this, I can go here and I can provision one more device, and that device role is the edge. Do you have any embedded wireless? If you click, you are enabling the wireless capability as well. At the moment, no. And now I want to deploy it. Apply it now. Again, it is in progress. Fabric provisioning initiated, and you can see that shortly we'll get one message called a successful. Correct. So we can wait for that. And here on top you can see that you have the show task status. There you can go and check the messages. So here you can see that deploying a state is in progress. If you want to check the provision, here you can see that success. So start, then processing to the business intent, a validation of that, validation of device. You have long list of configuration and the deployment status, view target device list, and finally in the bottom you can see that the successful. Okay, great. Again, you can go here and you can check the command. Either you can run this command from here, or you have this option, you can go and click configure, and whatever the configuration that DNAC has pushed here, all the IPGT track device tracking commands and all the new configuration, the class map type of command as well. And then here you can see this parameter type, subscriber attribute, etc. There's so many things that the DNAC will go and push, because now you have one control plus border, and then you have the edge device. Initially what we have done the host onboarding as well. So in future, if you want to connect the interfaces here, and obviously for that you need the host pool as well, the pool of IP addresses. So how we can do, we have discussed about that as well. Great. So you can see that now your fabric is provisioned, and now you can go to all fabric here. Inside this fabric, you can see that you have one side, two fabric device, one control plane, one border plane. Correct. And let me go back to the main section. Again, I can go to the provision, and I can go to the inventory. Once you are inside the inventory, you can check this. This is the manage state, the uptime, the role of the devices, the health score. Uh, you can do all sort of thing. One uh, point I want to highlight here is that, since suppose if you go and select the devices like this, and then if you go and check the action button, you can see inside the action you can check the inventory, you can resync, correct? So all inventory management you can do. You can go and do the image management as well. You can go and do this LAN automation and provisioning of devices that we have already done from here, correct? But I want to show you this telemetry section. Now you can see that the telemetry is already enabled with these devices, correct? Otherwise you will get this option, enable application telemetry. And that was the case with the wireless network. Say, once you provision the wireless network, you don't need to enable the telemetry. By default, the DNAC will enable the telemetry, and it will provide all the feedback, all the information inside the assurance. Correct? Now here you can see that for these devices, clearly we are seeing that the telemetry is enabled. So if I go here as well, and if you go here and check the telemetry, see, for this device I'm not seeing the telemetry. So that's very important point. That say you have two different type of device. You have router, you have switch. For routers the telemetry is different, for switches telemetry is different. For router, again we'll see this in the assurance section. Now when I selected here all the devices, I can see that it was showing that telemetry, we are not getting that option because obviously we have mix of different devices. So what you can do here, simply go to the telemetry, enable the application telemetry. Now what will happen, that the application visibility um, telemetry will get kicked off, and again in the telemetry section we'll learn more about that, what exactly happening behind the scene, because all the telemetry features like syslog, the netflow, the snmp, others as well, will get started with this simple click, enable application telemetry. Now once you enable this, then you can go back to the assurance, and obviously it will take some time to collect those information. So let me go to the application and health. At the moment router health is 100%, but you can see here you have the network, you have the client, you have the application. So whatever applications those are flowing over that devices, it will tell you, but it should collect those information first. So in the upcoming section I will deep dive inside this assurance and the telemetry things. All right, so far you have seen that um, how you can work inside the DNAC, how you can enable the ST access fabric, how you can add the devices in that. And later on, we are going to discuss little bit deep concepts about the ST access fabric and different type of device rule and some sort of LAN automation and assurance and the other stuffs.